मनसुख इसको थंबनेल चेंज करो ना, इसको वही लगाओ थंबनेल जो उसमें है, जल्दी ऐसे जल्दी जल्दी क्विक। Am I audible, guys? I don't know what happened. What is happening? Even in the yesterday's session, also in Wasim sir's session, same thing happened. We have no clue what is happening. Call your friends, okay? Just a second, guys. Just a second, guys. I'm sharing the link with everybody. Huh? Okay. Let's start from here, my dear NEET aspirants, okay? Let's dive into this particular session. So, am I audible, visible to each and every single student? Am I audible and visible to each and every single student? Tell me quick. Tell me quick. Okay. So this is Newton's laws of motion. Okay. So we have started the chapter that is laws of motion. This is the chapter 3. 2 chapters we have already completed in the previous stream. Now we are starting the 3rd chapter, that is laws of motion, my dear NEET aspirants. First I told you that is first law of motion, Newton's first law of motion. What does it say? Newton's first, yes, JEE students can also watch this. Newton's first law of motion says if there is an object which is at rest, and if force is acting from this side and same amount of force is acting from this side, so means net external force is 0. So we say if net external force is 0 on an object, we say if the object is at rest, then it remains in the rest forever. And if the object is moving with some constant velocity, means its direction is constant and its magnitude is constant, 10 meter per second, 10 meter per second, 10 meter per second. Then my dear NEET aspirants, in this particular case, if net external force is 0, then it will move with a constant velocity forever. So Newton's law says, first law says, if the body is at rest, if net external force is 0, it will remain in the rest forever. If the body isn't moving with constant velocity, if net external force is 0, it will move with a constant velocity forever. If net external force is not 0, then its velocity may change. Then its velocity may increase, its velocity may decrease. Okay? Okay? Okay. I think now everything is perfect, huh? Then, my dear NEET aspirants, I told you we have to basically study forces. Fundamentally, there are 4 categories of forces: gravitational force, electromagnetic force, strong nuclear force, weak nuclear force. Now, then we have derived force. Derived forces means weight. We say normal reaction. Derived forces means weight is a gravitational force. We say normal reaction is electromagnetic. This tension, this friction, and this spring force. So these 4 we need to study in this one, and this one we have to study in this particular chapter. So first we are moving on to the weight. What is weight? Weight is a gravitational force. That force with which Earth attracts the objects towards itself. Like I have a pen in my hand. Is there any force acting on this pen in the downward direction? Yes, sir. That is weight, gravitational force. Earth is attracting it towards itself. Okay. Its unit is Newton. And we say like over here, this is the object. It's placed on the surface. In the downward direction, we say W is equal to mg. So we say, sir, this W means weight. Weight is the gravitational force mg. Now here in this particular case, my dear NEET aspirants, we say this is mass m. If I say this is placed on the inclined plane, we say in the downward direction, mg will act on this. And if this angle is theta, we say this angle is also theta. So this will be over here mg sine theta, and this will be over here mg cos theta. Okay, because if we consider if this is theta, this will be theta. So this component will be cos, this will be sine. Then I told you, normal reaction. Whenever 2 bodies come in contact with each other, my dear NEET aspirants, we say they apply a force on each other that is called normal force, normal reaction. Like here, my dear NEET aspirants, in this particular case, this is the block. This is the block. On this block, we say in the downward direction, listen to me very carefully. This block is in contact with this surface. Let me again show you over here. See, this block is in contact with this surface. So this table applies a normal force on this one that is upward, away from the body. In return, this block also applies the normal force on the table. That's what we call N dash. It is basically when 2 bodies interact, their atoms come in contact with each other. So due to that interaction, they apply normal force on each other. And normal force is always perpendicular to the surface. Then, my dear NEET aspirants, listen to me very carefully. This block is in contact with this surface. So this surface this surface is applying the normal force on this block, even this block also applies the normal force on this surface, that is n dash. Now, my dear NEET aspirants, if this is the block placed on inclined plane, on this block in the downward direction, we say mg is acting. If this is theta, this surface also applies the, okay, first let's talk about the normal force. This surface applies the normal force on this block. Let's suppose that is n. Even this block also applies the normal force on this surface, and normal force is always perpendicular to the surface. And when I say in this particular case, sir, mg is acting in this direction. So here, if this is theta, this will be in this particular case also theta. So if this is mg, this will be cos component, mg cos theta. And this component is going to be mg sin theta. Now here, normal reaction will be balanced with what? Mg cos theta. So you will remember from now onwards, whenever two bodies come in contact, they apply a force on each other, that is normal force. If the two bodies lose contact, then normal force will be zero. Like here, tension force. Now tension force is always in a string. Like I have this string. Sir, what kind of force will be created in this string? Tension. Right now it is tension force. If I'm pulling this string from the out in the outer direction, so tension is created over here. Like. If I say this is the block, on this block, is there any force acting in the downward direction? Yes, sir, mg. Why isn't the block going down? If mg is acting, why isn't the block going down? Sir, it may be because of the tension. It may be because of the force which is created in the string. So in this string, I would say tension is created. Downward is mg, upward is tension. So we say in this particular case, tension will be equals to mg. Tension will be equals to mg. In this particular case, we say tension will be equals to mg. Okay. And now, my dear NEET aspirants, let's talk about over here. And tension is always away from the point of contact. Here, away. It is a force which is created in a string. It is always away from the point of contact. Here tension is T, here also T. Now this is what we call pulley. This is what we call pulley. In this particular case, on this block, what is the force in the downward direction? M1 into G, gravitational, and upward will be here tension. If tension is here, here also it will be tension away from the point of contact. Here same tension, I would say T. Here same tension T, and in the downward direction, I would say M2 into G. Now, if the string is ideal, that means massless, tension at all the points will be same. Now, guys, we in our syllabus we consider massless strings. Okay, so tension at all the points will be same. Here, at all the points will be same. Okay, and one more important thing, my dear NEET aspirants, if string changes, tension changes. Like. If I say this is a block over here, this is one more block over here. In this particular case, let's suppose this is M1, this is M2. What I can write over here, guys, we say in the downward direction, what is the force that is going to act? That is, I would say M2 into G. In this string, tension will be T1. Here also tension will be T1. Now, what about this string, sir? Tension here will be T2. In this string, tension will be T2. Why? Because there's a different string. If the string is same, tension is same. If the string is not same, tension is not same. Okay. And guys, we say on this block also one more force will act in the downward direction, that is M2 into G. Okay. So if the string changes, tension changes. Free body diagram. See, this is a very important concept. How do we make the free body diagram? Guys, see, in order to draw a free body diagram, let's suppose I am asking you to draw the free body diagram of this. Okay, this is the mass M. You have to draw its free body diagram. It is attached to the string. So whenever somebody asks you to draw the free body diagram, what you will be doing in that particular case is, we say first is draw all the forces. Before this, represent the body with a point mass. Represent the body with a point mass. When you represent the body with a point mass, Then, my dear NEET aspirants, next thing what you guys are supposed to do in this particular case is represent the body with a point mass. Then draw all the forces acting on a body. Acting on a body. Then draw all the forces acting on a body. Represent the body with the point mass. Then draw all the forces acting on a body. Then, my dear friends, see. So we are representing this body with the point mass over here. Draw all the forces acting on the body. So this will be mg in the downward direction. In the upward direction, it will be tension. Then you apply the Newton's laws. Then apply Newton's laws. Newton's laws. So this I will show you after some time. How can we apply the Newton's laws? Right now, I would say here, T will be equals to mg if the body is at rest in this particular case. Let's take a look at this particular question, guys. Let's take a look at this particular question, guys. Guys, make sure you smash the like button, okay? Because liking the session is mandatory. Everybody, quick. Smash the like button. Now, guys, in this particular case, if the system is in equilibrium, then find the value of mass m. System is in equilibrium means net force on the system is 0. If I say, guys, if I say this block is in the equilibrium, what does that mean? That means net external force on the block is 0. That means force acting from this side is equal to force acting from this side. Now, guys, take a look in this particular case. The system is in the equilibrium. It is not moving. It is not going down. It is not going up. What you guys are supposed to do in this particular case is, what is the force acting on this mass in the downward direction? 4g. In the upward direction, it is tension T. So it is the same string over here, same tension will be T. And my dear NEET aspirants, here, it is mg in the downward direction. And if this is theta, I have recently told you this will be also theta. And this will be what? That is mg sine of 30. Because this component is going to be mg cos 30. Okay. Now, draw FBDs of these two bodies. Now you need to draw FBDs. Draw FBD. First, let's draw the FBD of this body. In the downward direction, it is 4g. In the upward direction, it is tension T. So can I say in this particular case, my dear friends, if the body is in equilibrium, upward force is equal to downward force. T is equal to 4g. G is 10. So T will be equals to 40 Newton. Then if we draw the FBD of this mass, guys, this mass, which is on the inclined plane. In this direction, I would say tension T. In this direction, it is mg sine of 30. So can I not say in this particular case, this T will be equals to, that is mg sine of 30? Absolutely, sir. Now, guys, this is tension T. T is how much? We recently got it as 40 is equal to mass is m. G is 10 and sine of 30 is 1 divided by 2. 2 ones are 2 5s are 5 ones are 5 8s are. So mass is coming out to be equal to 8 kgs. So whenever you have given the body is in equilibrium, then you can balance the forces in that particular case. Okay. Now there is a very famous question in this one that I want you guys to understand. Find the tension and angle theta made by the string if the system is in equilibrium. Understand very carefully. Let's suppose there is a block which is attached to a string. Okay, there is a block which is attached to a string. Its mass is m. You are pulling this mass with a force F. You are taking it over here. Now you are holding this mass. Mass is in equilibrium. See, guys, if the body is in equilibrium, what did I tell you? Balance the forces. If the body is in equilibrium. Whenever you get this question, balance the forces. Balance the forces. Like you did here. You made the body in equilibrium, balance the force, upward force, downward force. This force equal to this force. That's it. Same we need to do here. See guys, in this particular case, what is the force acting in the downward direction? That is mg. What is the force acting in this direction? That is t. If this is theta, this will be over here theta. If this is t, this is going to be t cos of theta. And this is going to be t sine of theta. T cos of theta and t sine of theta. Okay, guys, in this string, tension will be created. This will be t cos, this will be t sine. Now, draw FBD. FBD of mass m. This is the mass m. In the downward direction, you have mg. In the upward direction, you have t cos theta. In this direction, you have t sine theta. And in this direction, you have f. Now, if the body is in equilibrium, can you balance the forces? Yes, t sine theta will be f. T sine theta will be equals to f. T cos of theta will be equals to mg. Now, divide the two. When you divide the two, t and t will cancel. Sine theta by cos theta is tan theta. And tan theta will be equals to f divided by mg. And we can say this theta will be equals to, take this over here, tan inverse of f divided by mg. This came out to be the value of theta. Then, my dear NEET aspirants, you also have to find tension. You also have to find tension. Okay. Now, how can you find the tension in this string? Consider this block. Consider this block, yes. What is the force acting on the block in the downward direction? Mg. What is the force acting from this side? F. What is the force acting from this side? T. We resolve T in two components, this and this. But here in this particular case, it is T. Now, yes, Lami's theorem also you can use. Lami's theorem also you can use. Now, in this particular case, simple. I can say, sir, resultant of this and this will be R is equal to under root of. R is equal to under root of, I would say this f square plus I would say mg whole square. Mg whole square. So my dear NEET aspirants, we say resultant of this one and this one will be this. Because when two vectors are at an angle of 90 degrees, their resultant is simply, what is the angle between this vector and this vector? Directly remember their resultant is under root of one vector square plus another vector square. That's it, directly. Now, if the block is in equilibrium, we say this force tension must be equal to this R. So we can say this R will be equals to tension. So tension is equal to how much? That is F square plus we say mg whole square. I hope this is crystalline clear. Tell me guys in the chats if this is clear. Quick. Tell me guys if this is clear. And smash the like button. Everybody guys, huh? Liking the session means marking the attendance. I'm waiting for you guys. Come on. Okay. Now guys, let's move on to this one, Newton's second law of motion. Okay, before Newton's second law of motion, I need to teach you momentum. Let's understand momentum first. See guys, momentum. Let's understand momentum first. Let's understand momentum first. We say momentum is simply the product of mass and velocity. Like. Let me form, I'll tell you later. That is simple, bro. Force divided by sine of one angle upon force divided by sine of another angle. I'll tell you later that. Momentum. You have over here in this particular case, a wall. There's a wall. And there is a big truck. Okay. There's a big truck. And this big truck is moving with certain velocity. Let's suppose its velocity is less, very less. And it's a strong wall. We say in this particular case, my dear NEET aspirants, if the truck is coming and it is hitting the wall, is it possible that it can break the wall? No, sir. Why? Because its velocity is less. Okay. Now, my dear NEET aspirants, you keep over here a toy car. You keep its velocity very large. Is it possible that it can break the wall? No, sir. Why? Because its mass is less. So, means in order to break the wall, mass as well as velocity, both must be large. Now, if the truck is moving with a large velocity, is it possible that it can break the wall? Yes. So, it is not velocity only which is breaking the wall. It is not mass only which is breaking the wall. It is product of mass and velocity which is breaking the wall. That is what we call momentum. So momentum is simply product of mass and velocity. This momentum is product of mass and velocity. We say whenever mass comes in motion, we say it has momentum. The train is having ultimate amount of momentum. Why? Because train has a large mass. Train has a huge velocity. So whatever comes in front of the train, it is going to smash it. So that's why we say momentum means product of mass and velocity. When mass is large, velocity is large, the momentum is large. Okay? Yes. Now, guys, let's talk about Newton's second law. Let's suppose there is an object over here. Its mass is m. It's moving with velocity v. What is the momentum of this mass initially? Mass into velocity, m into v. Now, if this mass is moving, if let's suppose you apply the external force on this mass, you pushed it. We know, sir, if we push it, velocity will change. Its velocity will become v dash. After some time, its velocity becomes v dash. Yes, sir. Now, my dear NEET aspirants, can I say finally its momentum is going to be m into final velocity v dash? Obviously, sir. Now, can I say in this particular case, due to the force, we say velocity changed. Due to the velocity, I would say momentum changed. So, my dear NEET aspirants, can I say due to the external force, momentum of the body changes? Yes. So, how can we write this? We can write it like this. Due to this external force, we say there is change in momentum, okay, with respect to time, delta P divided by delta T. This is what we call Newton's second law. Whenever you apply the external force on a body, its momentum changes. Obviously, here it is mv. Here it is mv dash. Velocity changes, momentum changes. Okay. Now. So, my dear NEET aspirants, we can also call it like this. This is the average force. Average force is equal to delta P divided by delta T. Means, if you apply the force on this body from A point to B point continuously, how much will be the total change in momentum from A to B? Delta P. How much is the total time? Delta T. So, total change in momentum upon total change in time is average force. If you keep on applying from A to B, it is like average velocity. Total change in displacement upon total change in time. Okay. Similarly, is the average force. From here to here, if you are applying the force, so there will be total change in momentum upon total change in time. This is the average force. And if I say, my dear NEET aspirants, see, if you are applying the force at an instant, if you apply the force at this instant, there will be change in momentum only at this instant. So that will be change in momentum is small dp, time is small dt. If force is acting for a particular instant, then in that case, we say instantaneous force in that particular case will be dp by dt. If force is acting for small time, then there will be small change in momentum. So that is dp divided by dt. We can write it like this. Absolutely, sir. Absolutely, sir. Now, guys, can we write it like this? We say this force we got, F is equal to dp divided by dt. So can I write it like this? This is d divided by dt of mass into velocity. Guys, simply I am saying if you are applying force from A to B, there will be total change in momentum. So that is average force. If you are applying force at a particular instant, then there will be change in momentum at that instant. That is instantaneous force. Now here, differentiation of mass as well as velocity with respect to time. Apply the UV rule or product rule of differentiation. What is that? Keep mass as it is, differentiation of velocity, dv by dt. Then plus, keep velocity as it is, then differentiation of mass, dm by dt. dm by dt. This one. Now, my dear NEET aspirants, this is the differential version of Newton's second law, differential form. Now, my dear NEET aspirants, listen to me very carefully. If I say, if velocity changes, mass is constant. If let's suppose mass of an object is constant, velocity changes. So if mass is constant, dm by dt means change in mass. Okay, so change in mass will be zero because mass is constant. Differentiation of mass will be zero. So this term will become zero. In that case, you can write the force as m dv by dt. Now dv by dt is acceleration. In that case, force will be mass into acceleration. So use this as Newton's second law only when mass is constant. Let's suppose if we say mass is variable, if mass of the body is changes and velocity is constant. Okay. Like rocket propulsion, when rocket goes up, its fuel burns by a large amount. In that case, mass decreases. So we say in that particular case, if velocity is constant, so dv by dt, this term will become constant, differentiation of velocity. So in that case, we can write force will come out to be this v dm divided by dt. This will be the force in that particular case. This will be the force in that particular case. Okay. So if both are variable, then this will be the force. I have told you all the expressions, whatever is required over here. Now take a look, my dear NEET aspirants, in this case. If a force F is equal to, this is the force acting on the body. Okay, this F, it's in vector form. That is 6i cap minus 8j cap plus 10k cap. This is the force acting on a body. Produces an acceleration of root 2 meter per second square. This is the acceleration. So means this much of force is acting on a body. Due to this force, acceleration is produced in the body. We have to find the mass of the body. Guys, see, we say force is equal to mass into acceleration. Acceleration will be force divided by mass. Okay, we have to find mass. Mass will be force divided by acceleration. Now tell me, what is, see, you need to put the magnitude of force over here. Don't put the vector form. Mass is a scalar. So what is the magnitude of force? Under root of 6 square plus minus 8 whole square. Minus square is plus, so 8 square plus 10 square. Okay, under root of 36, 64. That is 100. 100 plus 100 is 200. Okay, so this will be a root 200 divided by root 2. So it is like this. 200 divided by 2. 2 ones are 200s are. So root 100 is 10 kg. 10 kg is the mass of the object. What 36? Is this clear or tell me? Is this clear? Tell me. Okay. Now guys, a player catches a cricket ball of 200 grams moving with a speed of 20 meter per second. There is a player, he catches a cricket ball of 200 grams. Mass is 200 grams. Okay. Moving with a speed of 20 meter per second. Now guys, if the time taken to complete the catch is 0.5 seconds, the force, see guys, the player catches a cricket ball. So when ball pushes the hand, so it applies the force on the hand. Okay, now we are supposed to find how much is the force exerted on the player's hand due to the ball. Guys, see, we say force is equal to delta P divided by delta T. Let's first find delta P, change in momentum. So change in momentum, what does it mean? That means final momentum minus initial momentum. So change in momentum means final momentum is mass into final velocity minus mass into initial velocity. So take this mass out. This will be final velocity minus this will be initial velocity. Now, what is the mass of the ball? That is 200. So 200 grams, if you convert to the kgs, so 200 divided by 1000. So why? See guys, we say 1000 grams is equal to 1 kg. If I say 1 gram will be 1 divided by 1000. If I say 1, how many grams? 200 grams. 200 grams will be simply 200 divided by 1000. Into final velocity. Finally, object comes to rest. So final velocity 0, ball comes to rest. Initial velocity, it is moving with 20. Okay. Now guys, take this minus out. So now do the cancellation over here. When you take the minus out, 0, 0, 0, 0, 0 and this 0. Now tell me, this is minus out, 2 into 2 is 4. So this will be minus 4 is change in momentum. If I say mod of delta P, magnitude only, that will be 4 because mod makes a negative quantity positive. And total time taken, in how much time it catches the ball? 0.5. 0 point means 5 by 10. Now, F is equal to delta P. Delta P is 4. Time is 5 divided by 10. So 4 into 10 is 40 divided by 5. 5 ones are 5, 8s are. So force is equal to 8 Newton. Force is equal to 8 Newton. Let's suppose question is something like this. Take a look, guys. If momentum of a particle is varying with time as, momentum is given like this, 2 plus 3t square. This is the momentum of a particle. We are supposed to find force acting on the particle at t is equal to 3 seconds. We have to find force at t is equal to 3 seconds. So at t is equal to 3 seconds means instantaneous force. What is the value of instantaneous force? That is dp by dt. That is differentiation of momentum. So this force will be differentiation of momentum. What is the differentiation of 2? That is 0. What is the differentiation of 3t square? 3 into 2 is 60. This came out to be force. Now at t is equal to 3 seconds, what can I write? Force will be 6 into 3. So force will be, that is 18 Newton. Force will be 18 Newton. Okay. Let's take a look at the rocket propulsion. Okay. Let's understand the rocket propulsion first. Questions come from that. Motion of the connected pulley. Okay. Motion of the connected body system. That I'll show you after some time. See guys, in this particular case, rocket propulsion. What does rocket propulsion mean? You have a rocket over here. There is a gas filled inside the rocket. Sir, how does the rocket go up? See. There is a gas filled inside the rocket. Gas burns. Okay, sorry, not gas, it's a fuel. There is a fuel inside the rocket. When fuel burns inside the rocket, it pushes the gas out. When fuel burns inside the rocket, it is converted into a gas. So it pushes the gas out in the form of exhaust gases. Okay, so here fuel of the rocket burns, due to which exhaust gas come out of the rocket.
When fuel burns, we say exhaust gas. Due to that, exhaust gas come out of the rocket. So rocket pushes the gas down. In return, this gas pushes the rocket up. Rocket pushes the gas down and gas pushes the rocket up. How does rocket go up? Basically, there is a fuel inside the rocket. It burns, due to which exhaust gases come out. So rocket pushes the gas down. Gas in return pushes the rocket up. So upthrust force is created. Due to that, we say upthrust force is created. In the downward direction, what is the force acting on this? Mg. Upward direction, upthrust due to this. And this gas comes out with the velocity v. This is the velocity of the gas. Velocity of the exhaust gas. Okay. Now, my dear NEET aspirants, if I asked you in this particular case, my dear NEET aspirants, that how much is the upthrust created on the rocket? You say, sir, it is V dm by dt. Directly remember this. What is V? V is the velocity and dm by dt, that is the rate of change of mass, or with what rate fuel is burning, with what rate mass of the rocket is decreasing. Guys, as the rocket goes up, it is common sense. When the rocket goes up, mass decreases. This is a variable mass system. And in case of variable mass system, how can you find the force? When mass is variable, V dm by dt. Okay. So we say in this particular case, dm by dt is rate of change of mass. Okay. Or we say dm by dt is, I would say, a rate of fuel combustion. With what rate fuel is burning. If fuel is burning at higher rate, mass is decreasing. Like if I say dm by dt is 6 kg per second, means every second, how much fuel is burning? 6 kg. How much mass is burning? 6 kg. Don't say in liters. Here we say in kgs. 6 kg per second. Every second, 6 kg fuel is burning. Take a look, guys. A cracker rocket is ejecting gases at the rate of 0.05 kg per second. So this is a rocket. Okay. It is ejecting the gases at the rate of dm divided by dt. This is given as 0.05 kg per second. Every second, how much kg mass is decreasing or it is sending out? 0.05. With a velocity of, so velocity of the exhaust gas over here is 400 meter per second. Okay. The accelerating force means upthrust force created on this. So upthrust is V dm by dt. So this will be V is 400, dm by dt is 0.05. So this is 400 into 0.05 is 5 divided by, I would say 100. 0, 0, 0, 0. 5 fours are 20, 20 Newton. Let's take a look at this. A 600 kg rocket is set for vertical firing. There is a 600 kg rocket. Guys, this is a rocket over here. This is a rocket over here. It is set for vertical firing. And the exhaust speed, velocity of exhaust speed, gas, it is 1000 meter per second. The mass of the gas ejected per second to supply the thrust needed to overcome the weight. Okay, we are supposed to find the value of dm by dt. This is a very good question. Guys, see. In this particular case, what I am saying is that, what is the force acting on this in the upward direction? Upthrust. Okay. What is the force acting on this in the downward direction? Mg. Now, what if I tell you that this mg is greater than upthrust? Is it possible that it can go up? Impossible, sir. If downward force is greater than upward force, how is it possible? If I say, what should be the value of upthrust so that it can go up? Sir, either it must be equal to mg or greater than mg. Okay. Now, how much dm by dt? What is this dm by dt? Rate of fuel combustion. how much fuel we need to burn so that it can provide sufficient upthrust, because due to this only upthrust is created, which can overcome the weight, which can balance the weight. Sir, if we burn less fuel, we say due to that less upthrust will be created. So it cannot overcome the weight, it will not go up. So what should be the value of this so that it can balance? Okay, so we say in this particular case, upthrust must balance what? Mg. So how much should be the value of dm by dt so that it can create sufficient upthrust to balance mg? Okay, the mass ejected per second, how much mass we should burn or eject per second to supply the thrust needed to overcome the weight. So now this will be V dm divided by dt is equal to mg. Now velocity of exhaust speed is 1000 and this is dm divided by dt is equal to mg. Mass of the gas is 600. Mass of the rocket is 600 and acceleration due to gravity is 10. 0, 0, 0, 0, 0, 0. So dm divided by dt came out to be 6 kg per second. So if you burn the fuel of 6 kg per second, then only the sufficient upthrust will be created which can balance mg. Guys, tell me in the chats if this is clear. Quick, guys. Tell me quick if this is clear. Guys, smash the like button. If you have not liked the session yet, do smash the like button quick. Now, this is the question which I have kept homework. Its solution is also given. Please do check it later, okay? Do check it later, okay? And this also, my dear NEET aspirants, this is also homework. Please do check its answer from your end later on. Okay? Now, motion of connected body system. This is important. This is important. This is important. This is important. Now, my dear NEET aspirants, listen to me very carefully. Motion of connected body system means in which you have a bodies which are connected. See, these two bodies are connected by means of a string. And you are pulling it with a force of 20 Newton. In these particular questions, mostly you will be asked acceleration and tension. Mostly you will be asked what? Acceleration and tension. Mostly you will be asked acceleration and tension. Now, boys and girls, what I'm trying to say in this particular case, I want you to understand. Whenever they ask you to find the acceleration, you always remember net pulling force divided by net mass. Acceleration means net pulling force by net mass. So if I say acceleration means net pulling force, what is the pulling force in this system? Sir, that is 20 Newton. Can I not consider tension? No, tension, these are the internal forces, don't consider. So net pulling force here will be, that is 20. And net mass of the system, 6 plus 4 is 10. This and this will cancel. So this will be 2 meter per second square. This is the acceleration. Okay. Now, my dear NEET aspirants, they asked you to find the tension. Let's find tension. Let's find tension. So in order to find the tension, you need to create the ABD of any body. Here tension will be same because string is same. Now, my dear NEET aspirants, this is a body over here. In this, consider which one? Let's find tension. We say FBD of let's suppose 4 kg. Okay, we'll make both 4 kg. Now in this case, we say what is the force acting on the 4 kg T? Okay, yes. And T is the force. Now, can I say, sir, net force is equal to mass into acceleration? Absolutely. If the acceleration of the system is 2, sir, it is the acceleration of the entire system, even if it is the acceleration of 4 kg as well as 6 kg, because they are connected. So net force is tension. Mass of this block is how much? We say 4 kg, and acceleration is 2. 4 into 2 is 8 Newton is the tension. Even if you consider this block also, you can get the same answer. Let's consider this block, FBD of 6 kg. So this is the 6 kg block over here. On the 6 kg block in the forward direction, we say force is acting as 20 Newton. In the backward direction, it is tension T. So now we say, if the acceleration is forward, net force is forward, we say if we apply net force is equal to mass into acceleration here, Newton's second law. So what does that say? Net force means F minus this, bigger force minus smaller force. F minus T is equal to mass into acceleration. So F is how much? 20 minus T, mass into acceleration. What is the mass of the block? That is 6 into acceleration is 2. Now take this over here, 6 2s are 12. So 20 minus 12 is equal to T. So T will come out to be 8 Newton. I believe this is clear. Let me show you more questions on this. Let's first understand this. Okay. Now, my dear NEET aspirants, you have to find the acceleration and the tension in the string. First and the foremost thing, what is the force acting on this in the downward direction? That is 5g. What is the force acting on this in the downward direction? That is 3g. If I say what is the acceleration? You say acceleration is net pulling force. Okay, let me directly write. Net pulling force means this. Sir, can I consider tension as pulling force? No. That is 5g minus 3g. This is the net pulling force. Divided by net mass. 5 plus 2 is 7 plus 3 is 10. This is 10. So 5g minus 3g is 2g divided by 10. So this is going to be 20 divided by 10. This and this will cancel. So it will be 2 meter per second square is the acceleration. Then if I ask you to find the tension T1 and tension T2. Let's find T1. Consider FBD of 5 kg. Let's draw the FBD of 5 kg. So guys, in the downward direction it is 5g, in the upward direction it is T1. Since 5g was greater than 3g, so this is the direction of acceleration. So this will be the acceleration. So now tell me, if you apply the Newton's second law, what does that say? Net force is equal to mass into acceleration. Net force means downward force means upward force. That is 5g minus T1 is equal to mass into acceleration. Mass is how much? 5. And g acceleration is 2. So 5 into 2. So this is 50 minus, take it over here, 10 is equal to T1. So T1 will come out to be 40 Newton. Okay. Then if I make the FBD of 3 kg, FBD of 3 kg. So guys, this is 3 kg block. In the downward direction, it is 3g. In the upward direction, it is T2. So what can I say? Guys, its acceleration is upward. Why? Because its acceleration is downward. It is going something like this. So can I say here, net force is equal to mass into acceleration. Net force is upward force minus downward force. T2 minus 3g is equal to mass into acceleration. How much is the mass over here?
that is 3. Acceleration is 2. 3 into 2. So this is T2 is equal to 6, 30. 30 plus 6 is 36 Newton. Tell me in the chats if this is crystalline clear. Everybody guys, quick. I'm waiting for your answer. Let me know in the chats if this is crystalline clear. Quick guys. And do smash the like button. Quick. Liking the session is mandatory. Now guys, find the tension T1 and T2 in the given figure. Okay, this is the figure. In this particular case, okay, we'll take the break. Please, wait. We'll take the break. Okay, take a look. Find the tension in T1 and T2 in the given figure. This is that given figure. First of all, let's find the acceleration. Acceleration is net pulling force. How much is the pulling force over here? 120 Newton. Can I consider this tension T1 and T2? No. So net pulling force is 120 divided by net mass. 5 plus 3 is 8. 7 plus 3 is 10. 10 plus 5 is 15. This is 15. Okay. So 5 3s are 15. 5 2s are 10. Okay. 5 4s are 20. 3 1s are 3 8s are. So 8 meter per second square is the acceleration. Then my dear NEET aspirants, if you have to find T1, T2 and T3, consider in order to find T1, let's first find T2. Consider 7 kg block. Start from this point only. Sir, why are you not starting? You can start from this point only, but better is to start from here. Why? Because there is only one force acting on this block. So we say consider 7 kg block. So if this is 7 kg block, on this 7 kg block, we say T2 is acting. So we can say net force is equal to mass into acceleration. Net force is T2 because only one force is acting on this one. Mass is 7, acceleration is 8. So T2 will come out to be 56 Newton. Then consider 5 kg block. Consider 5 kg, or you can consider that one also, one and the same thing. So if this is 5 kg, from this side I would say T1 is acting, from this side I would say T2 is acting. So can I say in this particular case, net force is equal to mass into acceleration? Net force will be, if you are pulling the system from this side, so T1 is greater than T2. So T1 minus T2 will be equals to mass into acceleration. Mass is 5 and acceleration came out to be 8. Now this is T1 minus, what is the value of T2? 56. This is 56 is equal to 40. Now take it over here, 56 plus 40, that is 96. T1 came out to be 96 Newton. This is done. Now this question I have given over here, check its answer from your end, okay? This is your homework. Its answer is mentioned. Do check its answer from your end. Now, this is the question which is given. Do check its answer from your end. Okay. Do check its answer from your end. So solve this from your end. In this particular case, answer is given. Let's move on to the spring force. Okay. Spring force. Now guys, see, take a look in this particular case. Let's suppose you have a block over here. Let's suppose you have a block over. There is a spring, and with the spring, a block is attached. Now, if you are pulling this block from here to here, if you're pulling this block from here to here, let's suppose how much displacement? X. By which force? Spring force. Sorry, by external force. We said this spring will create a restoring force. Okay. That restoring force is what we call the spring force. If you pull a spring, the spring is going to pull the block back. With what force? Spring force. Now guys, see, if you pull the block more, if this displacement is more, what do you think? This spring will create more restoring force or less? More. The more you pull the spring, more restoring force it will create, more difficult it is to elongate. So we said this spring force or restoring force is directly proportional to this X. More you pull the block, more you do the displacement, more spring force will be created. Now, instead of X, I would put minus X over here. Why? Because if the displacement of the block is towards right, spring force is acting towards left. Even if you push the block, compress the spring, in that case, spring force will be opposite. Displacement is towards left, spring force will be towards right. Still, it is opposite. That is this negative sign. Now, replace this with a constant. So, spring force will be minus K times of X. Spring force will be minus K times of X. Spring force will be minus K times of X. Sir, what is the spring? This is what we call spring constant. Spring constant. Even we call it or force constant. Force constant. We call it force constant. Okay, we call it force. Sir, this force constant defines the stiffness of the spring. Like you have the spring of the car, it is difficult to elongate. Why? Because its value of K is large. For a car, value of K will be large. Stiffness will be large. It is difficult to elongate. So K defines the stiffness. If you have the cycle spring, so its K will be less. It is easy to elongate. It will create less restoring force. It will create large restoring force. So it depends upon K. It depends upon K. Now, whenever you have, my dear NEET aspirants, a question, find the reading of spring balance. Reading of spring balance means find the restoring force. And extension in the spring. And extension in the spring means how much spring is going to elongate. See what you are going to do. Let's suppose this is the mass over here. There is a spring attached. What is the force acting on this mass in the downward direction? mg. Due to mg, it will be elongated. The spring will elongate. It will go down. So spring will create restoring force. At some point, this will be balanced with this. They will come to the equilibrium. No? If it is elongated, now it will remain at rest. Downward force is equal to upward force. Whenever you have this question of this sort, always replace the spring with tension. Replace the spring force with tension. Okay.
Then apply the Newton's laws. So can you say, sir, this tension upward force will be equals to mg? Absolutely. In reality, tension is equal to spring force. That will be equals to k times of x. Okay. So here, what we do is replace the spring with what? Tension. Simple. Then instead of tension, what will you put? K times of x is equal to, you will say, m into g. Now this x will be equals to, I would say, mg divided by k. This x will be equals to mg divided by k. So from here, you will get the value of extension. This is called extension in the spring. Extension in the spring. And then afterwards, if you have to find the spring force, then you will say, sir, spring force will be k times of x. This is called the reading of spring balance. Like, let's take a look at this question. See, guys. In this particular case, find the reading of spring balance and extension in the spring. Value, this is the spring. Value of k is given as 200. I want you to understand in this case over here, guys, listen carefully. Listen carefully. We say, okay, one more important thing I just want to mention. Whenever you have a pulley, something like this. So if there is a block attached over here, there is a block. So here in this string, tension will be T, tension will be T. In this string, tension will be T dash, different tension. Always remember, if the system is in equilibrium, upward force, this T dash will be always equal to downward force, that is 2T. Okay. If you have a pulley, something like this. Okay. So here tension is T, here tension is T. In this case, tension is T dash. So here also T dash will be equals to 2T. Keep this thing in your mind. Okay. 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 Now, my dear NEET aspirants, in this particular case, this is a 5 kg mass. In the downward direction, I would say 5G is acting. In the upward direction, tension is acting. So here also tension will be away from the string. Here also tension will be away from the string. Now, in this particular case, I would say spring force is created because these two tensions will elongate it downwards. Spring force will be created. And you can replace this spring force with tension. So what you are going to do is, in this particular case, guys, okay, first let's make the FBD of the block. FBD of the block. So this is 5 kg. In the downward direction, 5G. In the upward direction, T. So T will be equals to 50. 5G. Now, let's make the FBD of pulley. FBD of pulley. So this is the pulley. In the upward direction, the spring force. Instead of spring force, I'll write T dash tension because replace the tension with the spring force. So this is T and this is T. So can I say, guys, T dash will be equals to 2T? Yes. In reality, this T dash is what? Spring force. That is K times of X. So this is K times of X. It will be 2 times of, what is the value of T? That is 50. So K is given as 200. Is equal 2 into 50 is 100. This is X. This. So X will be 1 by 2. So X will be 0.5 meters. So extension in the spring is 0.5 meters. If you have to find the spring force, that is K times of X. So spring force will be, K is 200, X is 1 by 2. So this will cancel. So spring force in this particular case will be 100 Newton. And it is obvious you got this here only. So spring force is equal to tension. In the downward direction, 50 Newton, 50 Newton. 50 plus 50 is 100. So T dash is equal to 100. F is equal to 100. I hope you got the feel of this one. But tell me, quickly, ladies and gentlemen.
Smash the like button if you have not liked the session yet. Mohammad Nadeem, we have a problem session tomorrow, na? Don't worry. Leave that on to me. Chill. Take a chill pill. Leave that on to me. Okay? Because, see, different sessions have different variety. I can't show you 50 problems in this on a particular topic in this particular session. Why? Because I have to finish the entire 6 chapters. So then it becomes impossible. So that's why I am showing you concept plus those problems which can clear the concept. Okay. So tomorrow, that's the reason we have put up the problem session tomorrow, for that reason only. Now guys, take a look at this. I'll show you this quickly. It is mentioned over here. See. There is a, this is a spring. This is one more spring over here. This is one more spring. Now this spring has K is equal to 100 Newton meter. This also has the value of K. This is 1 kg block. This is 2 kg block. You are supposed to find extension in the both springs. How much is the extension in this spring? How much is the extension in this spring? Do one thing, make ABD of 2 blocks. This is 2 kg, this is 1 kg. So on this 2 kg, guys, see, we say replace the spring force. See, replace this spring force with tension, let's call it T2. This is actually spring force. And replace this spring force actually with what tension? Tension T1. That's what I said. So this 2 kg upward force tension, downward force 20 Newton. Okay. Yes, this 2 kg. Okay, this is 2. This is 2. Okay, this is T2. So make this as T2 and make this as T1. Okay. So on this 2 kg block, in the downward direction, what is the force acting? Mg. That is 2g. On this, what is the force acting? That is g. 1g. That is g. 10. So on 2 kg, downward direction 20, upward direction T2. Okay, upward direction T2, because this T2 is actually spring force. This is actually spring force. Okay. Now, on this block, in the upward direction T1, in the downward direction, I would say what? G. And here also, my dear NEET aspirants, we say if here it is T2, here also it will be T2. It will have T2. Attention na, T1, T2, and we say downward direction is G. In the downward direction is G. Okay. Now, my dear NEET aspirants, it is, you can understand it like this also. Due to this mg, body goes down. This spring will be elongated. So it will create the restoring spring force upward. Now due to this block, it will push the spring in the downward direction. It will create the restoring force upward. It will push the block back, because restoring force is always opposite to the displacement. Here displacement is downward, so restoring force is upward. Here also here compression takes place, so it creates restoring force. That's why we say T1, T2. Now in this case, can I say this T2 will be equals to 20? T2 is equal to 20. Now what is T2 actually? Spring force. T2 is K times of X. And I would say X2 over here. Okay, K times of X2 spring extension in this string. Extension in this. So you can say, sir, K times of X2. Take a look here. So what I can write over here. So this is T2 is 20. So this will be 20 is equal to K times of X2. So this is 20 is equal to, what is the value of K? K is 100. This and this will be cancelled 2 by 10. So X2. So X2 will come out to be 1 by 5. X2 in this particular case came out to be 1 by 5. Okay. This is the X2. Now let's consider this block, upward force, downward force. So upward force is T1, downward force is T2 plus this. Now T2 we recently got, okay, T2 we recently got as 20.
Put it 20 over here. 20 plus 10 is 30. Now, what is the value of T1? T1 is also K times of X1. Okay. So, K times of X1. So, put it over here. X1 will be T1 divided by K. So, T1 is 30. This is and this will be 0, 0 will cancel. 3 divided by 10, that is 0.3. Okay. Okay. I hope you got the feel in this particular case. Okay. 2 divided by 10, that is 1 by 5 or 0.2. I hope you got the feel in this particular case. Is this clear? Do you want me to solve this again or this is clear? Is this clear or do you want me to solve this again? That's great. Pseudo force. See guys, what does pseudo force actually mean? Maximum number of students have problem in the pseudo force. Let's understand pseudo force in 5 minutes. There is a person over here. This is at rest. There is another person, it is moving with constant velocity. There is another person, its velocity is not constant. It is accelerating, means its velocity is changing. Okay. Now there is a block placed here at rest. I am standing over here. There is a block placed at a large distance at rest over there. I am asking you the simple question. I am asking you the simple question. I am asking you the simple question. The question is, sir, what is the block at rest or in motion? If I am asking the person, this person at rest, is saying obviously, sir, block, I am at rest, block is at rest. I can see the block, it is at rest. But when you ask this person, he said block is in motion because he himself is moving with certain velocity. It is like you are inside the car. You look outside, the trees are moving. In reality, the trees are at rest. It is with respect to you, trees are moving. Okay. So basically this person is moving with some velocity. That's why he says it has constant velocity, but in reality, it's at rest. So according to A, block is at rest. According to B, block is moving with constant velocity. And when I ask this person C, is the block at rest or is this moving with constant velocity or acceleration? He said it has acceleration A, but in reality, block is at rest. He himself has the acceleration A. So he feels that this person has the acceleration A. So he feels that the person has the acceleration A. In reality, block is at rest. Now, my dear NEET aspirants, what I'm trying to say in this particular case is, listen to me very carefully. So according to C, block is accelerating. Can I say this is the acceleration of the block? It is fake acceleration. It is not real acceleration. It is according to this person. Yes. So my dear NEET aspirants, this fake acceleration, see, whenever there is acceleration, we say it may be because of some force. It is not possible acceleration is there and force is not there. So force has to be there. Force has to be there. So this fake acceleration may be because of the fake force. That fake force is what we call the pseudo force. In reality, see, when does this pseudo force act? When the observer who is observing the situation is in the accelerated frame. This observer is in the accelerated frame. So according to this person, this is accelerating. So means fake acceleration. So this fake acceleration may be because of the fake force. That's why, my dear NEET aspirants, we say here F is equal to M into A. Okay. So this is the pseudo force. And see, this is what we call when observer is at rest or acceleration, constant velocity. It is called inertial frame, and this is called non-inertial frame. When observer is accelerating or non-inertial frame it is in, then only we are applying the pseudo. And observer has forward acceleration, pseudo acceleration or pseudo force acts opposite. See what is mentioned over here. This acceleration of the block according to C is fake acceleration, which is due to the fake force called pseudo force. One more important point. A and B are in the inertial frame because velocity of A is 0 and velocity of B is constant. And C is in the non-inertial frame. Why? Because velocity of C is not constant. Pseudo force acts when observer is in the non-inertial or accelerated frame. Whenever the observer is in the non-accelerated frame or in non-inertial frame, then only pseudo will act. Otherwise, it will not act. Okay. Like if I say, this is a block, my dear NEET aspirants. Okay, this is a block. There is a person over here. This person is actually having the acceleration 10 meter per second square. So this is the 10 kg block. Okay. Now I am asking you, will the pseudo force acts on this block according to this person? So according to this person, this is also having the acceleration, but in opposite direction. How much? I would say 10. So we say pseudo force will act in this direction. So this pseudo acceleration may be because of pseudo force. So I would say that will be mass into acceleration. Mass is how much? That is 10. And acceleration is how much? That is 10. So this will be 100 Newton pseudo forces acting on this block according to that person. Now guys, see, this elevator problem is very famous and students make mistakes over here. Let me show you. Find the normal force on the block of mass m placed in an elevator accelerating upwards. Listen carefully. Solve this question using non-inertial frame. Put the observer inside. Put the observer inside. That means non-inertial frame. Why, sir? Because if you put the observer inside, this lift has acceleration. Observer will also get the same acceleration. Now observer has the same acceleration. Now, my dear NEET aspirants, in this particular case, what I'm trying to say over here is, listen to me very carefully. You have to tell me what is the value of this normal force. See, on this block, what is the force acting in the upward direction? See, on this block, what is the force acting in the upward direction? Normal reaction. What is the force acting in the downward direction? That is mg. Okay. Okay. Forget about this force initially. Is the observer in non-inertial frame or inertial? Non-inertial, because it is accelerating. So will the pseudo act? Absolutely, sir. That's why I have made this pseudo force ma in the downward direction. What if I place this observer outside? Will the pseudo act in that particular case? No, sir. Like here. Wait. Observer is outside. We say here, put the observer outside. It is inertial frame because observer is at rest. In this case, only normal reaction is acting and mg is acting. Sir, did I apply pseudo? No. Why? Because this is in the inertial frame. Pseudo will only act when the observer is in the non-inertial frame. This is in the non-inertial frame. See, pseudo mgn. Now, according to the observer, we say block is at rest or motion. Block is at rest. Array, observer is also in that lift. If the lift is going up, observer is also going up. So with respect to the observer, block is at rest. So block at rest. So you can say upward force is equal to downward force. Upward force is N, downward force is mg plus ma. So you can say N will be equals to m into g plus a. So this is, we solved the question using non-inertial frame. Same question with the inertial frame. Now here, observer is in the inertial frame. Now, according to observer, block in motion. Block in motion. Why? Because if the lift is going with an acceleration a, we say the block is also having the same acceleration. Now this observer is seeing, yes, block is accelerating. So with respect to this, observer has acceleration, observer is in motion. So apply Newton's second law. Net force is equal to mass into acceleration. Here, why did I say according to observer, block is at rest? Because he himself is in the same block. So now tell me, net force is equal to mass into acceleration. Net forces, upward force
Because if the acceleration is upward force minus downward force, N minus mg will be equals to mass into acceleration. Take it over here. N will be equals to ma plus mg. So we say N will be equals to, take this m out, we say a plus g. Okay. Okay. A plus g, m into a plus g, m into a plus g. Sir, we got the same answer, na? M into a plus g, m into a plus g. But which one should we prefer? You will be always preferring the non-inertial frame. Because simple. Put the observer inside, then apply the pseudo, then upward force is equal to downward force. Simple, simple, simple. Let's talk about this. If the lift is accelerating downward, you have to find the value of normal reaction. Will you solve this using inertial or non-inertial? Non-inertial. So put the observer outside, put the observer inside. This is observer inside. Now, when the observer is inside, on the block, upward force is normal, downward force is mg, and if acceleration of the observer is a downward, pseudo will be upward in this case. Oh, sir. Now, can I say, according to the observer, block is at rest, upward force is equal to downward force. N plus ma will be equals to mg. Take it over there. N will be equals to mg minus ma. So N will be equals to, take this m out, we say g minus a. I hope this is crystal clear to each and every single student. I hope this is the question on the same pattern. This is your homework. Please do check it from your end. Okay. This is also the question on the same pattern. This is also the homework. Please do check it from your end. Please tell me, is the pseudo force concept clear? Please, let me know in the chats first. Is the pseudo force concept clear? And how will you solve the questions? By pseudo frame, inertial frame or non-inertial frame? Tell me. Okay. So we'll take the break till okay. Oh, we'll have to take the break. Okay. We'll take the break till 5:50 and then we'll stretch to 3 hours more. Break is till 5:50. Okay. And then we'll stretch 3 hours more. Oh, I also need a break. Oh, it is already 5:22. So 25 minutes break is there. So then we'll stretch. Next will be friction. Then we'll finish work, power, and energy. Okay. Okay, guys, let's get back to business. Okay. Now, guys, let's start the frictional force. Let's start the chapter friction. Understand this very, very, very carefully. See, let's suppose this is the surface over here. On this surface, I am placing this block. I'm placing this block. Understand very carefully. Understand very carefully. Let's suppose if I push this block or pull this block with a force F. So we say this block wants to do the relative motion with respect to the surface. Sir, what does relative motion mean? Relative motion means simply, if let's suppose this is the block, okay, if let's suppose this is the block, understand this very carefully, I'll make you understand. Now, my dear NEET aspirants, this is the surface. Now the block is moving, block is in motion. We said this block is in motion with respect to this surface. It is doing the relative motion with respect to this surface. So when the block is doing relative motion with respect to this surface or wants to do the relative motion, we say in that case the surface will apply the frictional force on the block. Okay. So I can say if you pull the block with the force in the forward direction, this surface will apply the frictional force on this block in the backward direction. So if the block wants to do the relative motion means this body is doing motion with respect to this body. So we say frictional force will be acting in this block, which opposes the relative motion. Friction is that force which opposes the relative motion. Okay. Now, my dear NEET aspirants, listen what is mentioned over here. Frictional force is a contact force which acts parallel to the contact surface, This is the frictional force. It cannot be perpendicular. It is parallel. Now, guys, see, due to the force F, block wants to do relative motion. Due to this force F, this block wants to do the relative motion. Relative motion means it wants to move with respect to the surface. It wants to go forward. Okay. But F, small f frictional force is opposing it. So friction acts opposite to the relative motion. If it wants to go forward, if it wants to do the relative motion in the forward direction with respect to the block, so friction will act in the backward direction, opposite. Okay. Now same thing. See guys, if the block wants to move forward with respect to the surface, friction on the block is backward. On this block, friction is backward. But surface is also moving backward with respect to the block, See guys. Understand it like this. The block, this block is going forward with respect to the surface. So the person inside the block, if he looks outside, it feels like that the surface is going in the backward direction, like you are inside the car. Okay. So while you take a look outside, if you see the road,
it feels like road is going in the backward direction since you are moving in the forward direction. It is because of relative motion. So with respect to the block, surface is going backward. With respect to the surface, block is going forward. So that's what I'm trying to say in this particular case, my dear NEET aspirants. We say also surface is moving backward with respect to the block. With respect to the block. With respect to the block. So friction on the surface acts in the forward direction. Guys, see, block wants to go forward with respect to the surface. So on the block, friction is backward. Now surface, if this wants to go forward, this surface wants to go backward with respect to the block. So on the surface, frictional force will act in the forward direction. That means on both the bodies, friction will act. Obviously, that's what I said over here. See? See? This is the frictional force on the block. Now, this surface is going backward with respect to the block. So on the surface, friction will act in the forward direction. So friction acts on both the blocks. Keep that thing in your mind. So friction opposes the relative motion. Friction opposes the relative motion. Okay? Friction opposes the relative motion. Now guys, static friction, there are two types of friction, static friction and kinetic friction. This I'll be making you understand with this one, with this example. Please listen to me very carefully. This will make you understand static as well as kinetic. Let's suppose there is a block over here. On this block, you are applying a force of F is equal to 10 Newton. But still the block is not moving. There is a block, you are applying a force of 10 Newton over here, but still the block is not moving. Sir, it may be because the frictional force is acting on the block in the backward direction. How much must be that? Obviously 10, because then only block is not moving, na? Because if the frictional force is 9, then the block must move because forward force is greater than backward force. So if the block is still at rest, we say then friction will be same. So applied force is 10 and friction created is also 10. Okay. Now, right now, this friction is called static friction. Why? Because when the body is at rest and the friction which is acting on the body, that is called static. So this is static. Okay, yes. Let's suppose if you are applying a friction of 30 Newton, sorry, applied force 30, friction is also acting 30. Will the body move? No, sir. So we say friction. Still the body is at rest. It is also the static friction. Let's suppose if you are applying the force of 40 Newton, still the body is at rest, means friction must be also 40, then only body is at rest. So this is also static friction. If you are applying 50 Newton, still the body is at rest, so means friction is also 50. Applied 50, friction 50. If you are applying 54 Newton, so body is still at rest, means friction is also 54. Body is still at rest. If you are applying 55 Newton, now friction in this particular case is also acting how much? 55 Newton. Will the body move? Body is still at rest. So in all these cases, body is at rest. So static friction is acting. So static friction is that friction which is developed between the body and the surface when the body is at rest. Body is not doing the relative motion. Okay. Now, my dear NEET aspirants, what I'm trying to say in this particular case, just a second. Now guys, let's suppose maximum value of friction this surface which it can create is 55 Newton. Now, if you apply, let's suppose 56 Newton. Now, what is the maximum value of friction that can be created over here? That is 55. Will the body move? Absolutely, sir. So, when you apply the 56 Newton, this is the maximum value of friction, maximum value of static friction, and this is what we call limiting friction. This is what we call limiting friction. Limiting friction is the maximum value of friction the surface can produce. Now, when you apply 56 Newton, now the body is in motion. Now, how much the friction will be created? That we need to calculate, my dear NEET aspirants. Now, see, I'll tell you that also. Boys and girls, don't you think till the body was at rest, we say frictional force, when you are applying 10, friction 10, 30, 30, 40, 40. So frictional force means static friction. It was adjusting its value according to the applied force. Yes, sir. When you apply 40, it applies 40. When you apply 54, it applies 54. Up to what value? Maximum value. That is the limiting friction. So my dear NEET aspirants, this static friction, which acts when the body is at rest, we say it is a self-adjusting force. It adjusts its value according to the applied force. And its maximum value is this. And when you apply, my dear NEET aspirants, greater than the limiting friction, applied force is greater than the limiting friction, then body is in motion. Kinetic friction acts. Now kinetic friction acts. FK, kinetic friction acts. And this kinetic friction is slightly less than, listen carefully, it is slightly less than maximum friction. It is not greater than or equal to maximum friction. It is slightly less than this. Sir, how to calculate this? I'll tell you. Wait. Okay. Sir, why did you put the values here directly? Because it's a self-adjusting force. It is always equal to the applied force. Whatever the amount of applied force you apply. Here, this you need to calculate. Okay. But it is slightly less than the maximum value. Now, let's move on to the static friction. Static friction, it is that friction which acts when the relative motion begins. Before the relative motion begins. Relative motion has not started yet. It acts when the body is at rest. Okay. It is a self-adjusting force. If you apply 10 Newton, it will apply 10 Newton. It adjusts its value according to applied force. It is always equal to applied force. Maximum value of static friction is limiting friction. Okay. Then, so limiting friction acts when the object is about to move. Now, guys, see, when the object is about to move, like here, after this, body will move for sure. So limiting friction acts when the body is about to move. After this, body will move. Body will come to the motion. Okay. Okay. And if somebody asks you how to find the limiting value, how to find the maximum value of static friction, that is frictional force is equal to mu L into N. N will be the normal reaction. Mu is the coefficient of friction. Mu gives you an idea how much a surface is capable of creating friction. Like rough surface creates more friction. Smooth surface creates less friction. So rough surface will have large mu, smooth surface will have less mu. So mu decides how much friction is created by the surface. Kinetic friction. We say it is that friction when the body is performing the relative motion. It is slightly less than the limiting friction. Okay. Its value does not depend on the type of motion such as accelerated constant velocity. It does not depend upon that. And how do you find this kinetic friction? Fk is equal to mu k into n. Mu k is the coefficient of friction. It will be given in the question. Okay, mu k is the coefficient of kinetic friction. Guys, see, if you have to find the maximum value of friction, F limiting, then you will be using mu s into n or mu L into n. It will be also given. If you have to find the kinetic friction, you will be saying, sir, mu k into n. If you have to find the static friction will be always equal to F applied. F applied. I hope this is crystal and clear. So maximum value of static friction is limiting friction. I hope this is also clear. Now I hope this is also clear. See guys, applied force. We say if you apply 10 Newton force, friction, see. If you apply 10, friction is 10. If you apply 30, friction is 30. If you apply 40, friction is 40. If you apply 50, friction is 50. If you apply 55, friction is 55. And that is the maximum value. After that, when you further applied 56 Newton applied force, 56 Newton, then my dear friends, this body starts moving. So, my dear NEET aspirants, in this particular case, from here to here, we say static friction acts. Maximum value of static friction is limiting. After that limiting friction, we say kinetic friction will act, and this kinetic friction is constant. It will be constant throughout the motion. And my dear NEET aspirants, it is slightly less than limiting friction. It is slightly less than limiting friction. I hope this gave you the crystal clear feel. I hope this gave you the crystal clear feel. Guys, tell me in the chats, give me the signal in the chats if this is clear. Guys, this is frictional force is equal to applied force, static, up to limiting. Then limiting will be, then kinetic will be slightly less than that. Tell me, guys. Is this clear? And smash the like button if you have not liked the session yet. Quick. Okay, this is the question that we have. This is the question that we have. Now see, because see, it is obvious kinetic friction has to be less than the limiting na. Because kinetic means when body comes in motion, limiting means maximum. So that will not let the body move. So if after that you further increase, then the friction will be less than the limiting force. Now see, if the find the frictional force on the block. See guys, listen to me very carefully. You are applying the force on this particular block. Okay, this is the force acting. This is the velocity of the body. Now, forget about this force. This is just to confuse you. If the velocity of the body, so means body is in motion. Body in motion. Whenever you see the velocity is given, means body is in motion. If body is in motion, we say frictional force will act over here. And which force? We say kinetic friction. So kinetic friction in this particular case will be mu k into n. So here mu s is also given, mu k is also given. So you'll have to take mu k in this particular case. And what is the value of n? So this is the block. Upward direction is n and downward direction is mg. So I can say n will be equals to mg. So n will be equals to, what is the mass of the block? That is 20. And what is g? That is 10. That is 200. So now guys, this fk will come out to be mu k. Mu k is 0.6. 0.6 means 6 by 10 into mg. mg is 20 into, I would say, 10. This and this will cancel. This will be 120 Newton. 120 Newton is the kinetic friction acting on the body. Next. In this particular case, you guys are supposed to find the frictional force. See guys, this is the force acting. Okay. You have to find the frictional force. Is the body in motion or at rest? Motion, velocity. So we say frictional force will act over here. Which force? Kinetic friction. So kinetic friction in this particular case will be mu k into n, because body is in motion. Now you have to find the normal reaction in this particular case. Guys, take a look. If this is F, this will be over here, F cos of 37. So this will be over here, F sine of 37. And in the upward direction, normal reaction will also act. In the downward direction, I would say mg will act. Let's find normal reaction in this case. Guys, normal reaction will be, the block is not doing the motion in vertical direction. So upward force is equal to downward force. So n plus, I would say, F sine 37 it will be equals to mg. Okay. Now this f will be, n will be f. What is the value of f? F is 50. Sine 37. Guys, always remember these two triangles. This is a 37-degree triangle. This is 53-degree triangle. So whenever the angle of this triangle is 37, this is 37-degree triangle, this is 53-degree triangle. Okay. Now guys, in both the triangles, hypotenuse will be 5. Now, the sides will be actually 3, 4 and 5. Hypotenuse is 5 in both. Now you have to decide 3 and 4. If you compare 37 and 53, which one is smaller angle? 37. If you compare 3 and 4, which one is smaller? 3. So in front of 37, you have smaller side. In front of bigger angle, you have bigger side. So in front of 37, 3. So this will be 4. In front of 54, this is 53. It is 4. This will be 3. Now tell me sine 37, perpendicular upon hypotenuse. Sine 37 is 3 by 5. Is equal to mg. Mass of this is 5 into, I would say, 10. G is 10. 5 ones are 5, 10s are 50. 10 into 3 is 30. Take this 30 over here. So this will be 50 minus 30. This will come out to be 20 Newton. So normal reaction came out to be 20 Newton. Okay. Now let's find the frictional force. Fk is equal to mu k into n. So Fk in this particular case, that will be Fk is 0.5 divided, okay, 0.5, mu k is 0.5. So that will be 10, 5 divided by 10 into, normal reaction is 20. This and this will cancel. Fk came out to be in this particular case. Did I make any mistake? 5 ones are 5, 10s are 50. This is 30. This is 50. M into G. P by 5. N plus this. If you take it over here, this will be 10 Newton. Is this clear? Is this clear? Okay. Okay. And one more important thing, my dear NEET aspirants, in this particular case, if you say what is the limiting value of friction that can apply over here? Sir, that is mu L into N. Or you can say mu L means mu S. So limiting value will be mu L is 0.6 into N. N in this particular case is 20. Okay. Okay. Now this will be 6 divided by 10 into, I would say, 20. This and this will cancel. So this will be 12 Newton. Now see, this is greater than kinetic friction. Static friction, limiting friction is greater than kinetic friction in this particular case. And what about static, sir? Static will be always equal to applied force. Static will be always equal to applied force. Okay. In that case, you don't have to think. You just check the applied force, how much it is acting, and accordingly, you apply this one. Accordingly, you apply this one. Okay. Now, guys, this is your homework. Please do check this from your end. Okay. So I have solved this also. I have answered this also. Now, in this particular case, there is a topic that is angle of repose. This is important. See, in JEE mains, questions have come from this one. Okay. Okay. Now, my dear NEET aspirants, listen to me very carefully. What does angle of repose mean? Let me make you understand the angle of repose once again. See, angle of repose simply means this is the block placed on the surface. Let's suppose if I start increasing its inclination, with respect to the horizontal, is the block slipping down? No, sir. Is it slipping down? No, sir. Is it slipping down? No, sir. I'm increasing inclination. Okay. Slipping down? No, sir. No, sir. No, no, no. It is not slipping. It is not slipping. It is not slipping. Yeah, now it starts slipping. The angle at which block starts slipping down This is what we call the angle of a repose. It is that angle after which the block starts slipping down. That's why it is called angle of repose. Okay. So it is that angle after which the block starts sliding down. That is what we call the angle of repose. Okay. Now, my dear NEET aspirants, what you guys are supposed to remember in this particular case is, listen carefully. Three cases are over here. Three cases in this particular case. Mu is the coefficient of friction between the surface and the block. Remember these cases directly. If tan theta is equal to mu s, tan theta means value of this theta, if that is equal to the coefficient of friction, if tan theta is equal to mu s, then we say in that particular case, block is about to slide. Directly remember this. If the value of tan theta is equal to mu s, block is about to slide. If tan theta is less than mu s, means friction is more, we say block will not slide. Block will not slide. This is the only thing you have to say in the question, not slide. I'll show you the question also. And if tan theta is greater than mu s, this angle becomes greater than this friction. In that particular case, we say then the block will slide. Now, when the block slides, it will gain acceleration. Then the acceleration, so block accelerates. This is the acceleration of the block. G sine of theta minus mu k cos of theta. This will be the acceleration of the block. So in third case only we say block accelerates, block slips down. In this case it will not slip down because mu is greater. In this case it is about to slip. Let's take a look at the question. A cubical block rests on a plane of mu is equal to √3. There is a cubical block. It rests on an inclined plane. Here mu is given as a √3. Okay. The angle at which the plane must be inclined. At what angle we must incline this plane? To the horizontal so that the block just slides. It is this condition. At what angle? At what angle, my dear NEET aspirants? You need to keep this inclination so that the block is about to slide. Okay. We say block is about to slide. Block is about to slide. Then what must be the angle? We say angle must be tan theta must be equal to mu. That is this mu. So we say tan of theta in that particular case will be equals to √3. When is the value of tan theta? We have to find the value of theta at what angle block is about to slide. Use that condition. So tan of theta is equal to, we say tan of 60 because tan 60 is √3. So theta will be equals to 60. So if you keep the value of angle as theta, we say block is about to slide. Next, the angle of inclination of the inclined plane is 60. The angle of inclination of this inclined plane is 60. Coefficient of friction between 10 kg body and the surface is 0.2. Coefficient of friction in this particular case is 0.2. The acceleration of the block down the plane is okay. First you check will the block go down or not. Guys, what is the value of tan theta in this case? You'll say, sir, the value of tan theta is tan 60. Tan 60 is √3. And what is the value of mu in this particular case? That is 0.2. Now tan theta is √3. √3 mu is this. So we can say here I can say tan of theta is greater than mu. When tan of theta is greater than mu, in that case block slides. So here block slides. And when block slides, my dear NEET aspirants, acceleration of the block will be G, then we say sine of theta minus mu k cos of theta in that particular case. Now, boys and girls, you'll be directly writing over here, acceleration will be, what is the value of G in this case? G is 10. Then we say sine of 60 minus mu k, that will be 0.2. So that will be 2 by 10. Take mu k also here. When only this mu is given, consider this only. So cos of 60. Okay.
This will be 10. And sine 60 is root 3 by 2. Minus, this is 1 by 5. Into cos 60 is 1 by 2. Okay. Find its answer. It is approximately 7.5 meter per second square. Is that clear, guys? Okay. Okay. 7.5 meter per second square. Okay. Do check this question from you. Okay, this is the question of NEET 2023. In this particular case, guys, what is the value of tan 30? Tan of 30 in this particular case is 1 by root 3. And what is the value of mu? 1 by root 3. So can I say the condition over here is tan 30 is equal to mu? So when tan 30 is mu, block is about to slide, but block will not slide. Block is about to slide, but block will not slide. So my dear NEET aspirants, when block is about to slide, can I say in that particular case, upward force will be equals to the downward force? Yes. So how much will be the net force on the block? That will be 0. When block is not sliding, net force is 0. In this case, you were supposed to find the net force on the block. NEET 2023. Net force is 0. Or is this clear, or give me the signal in the chats? Yes, you can, Danish, you can say it like that kind of. Okay. Because limiting friction is the maximum value of friction. And static friction has the capability only that it will not let the body move. Okay. But when you are applying a large amount of external force, then the body has to move. And when the body comes in motion, then kinetic friction will act. Is this clear, or give me the signal in the chats, everybody out there? Now, guys. Pulling force. Okay. Take a look, guys. What does pulling force actually mean? This is also the problem that you need to understand. Let's suppose this is a block. This is a block over here. Okay. On this block, if you are applying, let's suppose, force F. Okay. At an angle of theta. And friction over here is mu. If I am asking you what must be the minimum value of force so that the block starts moving, what must be the minimum value of force so that the block starts moving, that is what we call the pulling force. Minimum value of force acting at an angle theta. What must be the minimum value of force in this particular case? What must be the minimum value of force over here so that the block starts moving,
Okay. How much minimum force should we apply so that the body starts moving? This is the minimum force. Directly remember, mu mg, mu is the coefficient of friction, m is the mass, g is the acceleration due to gravity. Theta is the angle at which you are applying the force. Okay. Or let's suppose if in a question theta is not given, then in that case you can say minimum force is also equal to mu mg upon 1 plus mu square. Mu mg upon 1 plus mu square. Now guys, see, find the value of F minimum so that the block starts moving. What should be the minimum value of the force so that the block starts moving? What will you say? Is the angle given in this particular case or no? Which formula you will prefer, first or second? I'll prefer second. So I'll say in this particular case, it will be mu mg upon, what does it say? Under root of 1 plus mu square. So we say under root of 1 plus mu square. Now tell me, what is the value of mu? 3 divided by 4. What is the value of mass? Mass is over here 10. What is acceleration due to gravity? That is 10 divided by, we say under root of 1 plus mu square. Mu is given over here 3 divided by 4, its whole square. Okay. Okay. Now guys, you can solve this. Okay. So this will be 30 into 10 is 300 divided by 4. So this will be 300 divided by 4 upon. So this is 4. 3 square is 9. 4 square is 16. 16 plus into 1 is 16 plus 9 is 25. So this is a root of 25 divided by 16. So this will be 300 divided by 4 upon 5 divided by 4. 4, 4, 5 ones are 5 6s are 5 zeros are. So answer is 60 Newton. 60 Newton. And there is a question which was asked from the pulling force in JEE 2021. One-liner question if you know the concept. See, one-liner question. A body of mass 1 kg, okay. Coefficient of friction is 1 by root 3. Find the minimum force applied so that the body starts moving. Mu mg upon 1 plus mu square. Mu is 1 by root 3. Mass of the body is 1 kg. And g is 10 upon under root of 1 plus mu square. Mu is 1 by 3. Okay, 1 by root 3, its whole square when you do the square root. So answer is 5 Newton. Just one-liner question if you know the concept. Then you have the hanging chain problem. Hanging chain problem. Let me make you understand hanging chain problem. This is also very important. This is also very important. Okay, there are variety of problems asked in this friction portion. So I have mentioned all these problems. So, okay. See, what is the hanging chain problem? Guys, see. Let's suppose, imagine this is a chain. Imagine this is a chain. Okay, placed on this. What should be the maximum length of the chain? Maximum. So that it should not fall down. So if I increase more, it will start fall down. So what should be the maximum length that can overlong? Okay, so that it should not fall down. What fraction of the chain, okay, should be placed on the table so that it does not fall? How much can be the maximum length of the chain that can overlong? Okay, so we say this is the chain. We say, let's suppose x is the length which is hanging over here. Sir, if we increase more than this, then it will fall down. It must not fall. Now this is x. Now, my dear NEET aspirants, in this particular case, how much is the value of this x? How much is the value of this x? Its value is mu L. L is the total length of the chain upon 1 plus mu. That's it. Take a look at this particular question. See guys, a heavy chain lies on a horizontal table. Okay, there is a heavy chain which lies on a horizontal table. There is a chain which lies on a horizontal table. Something like this. Of coefficient of friction between the chain and the surfaces, mu is given as 0.25. Okay. The maximum fraction of the chain, fraction of length of the chain that can hang over the edge of the table means it is asking us to find the value of x. How much can be the maximum length of the chain that can hang over one edge? What is the value of x? That is mu into L upon 1 plus mu. Mu into L upon 1 plus mu. It is 1 plus mu. Now, what is the value of mu? 0.25. And L is the length of the chain upon 1 plus 0.25. So, 1 plus 0.25 is 1.25. 0.25 means 25 divided by 100 into L upon 1.0.25. 1 plus 0.25 is 1.25. 1.25 means 125 divided by 100. 100, 25 ones are, 25 fives are. So it is L by 5. So if the length of the chain is L, how much you need to hold over here? L by 5. L by 5 can hang. Okay. A rope is on the table, so that part of it is hanging. The rope begins to slide when the length of the hanging part is 25. See guys, 25% of the entire length. This is the rope or this is the chain. It says how much is the hanging portion? That is 25% of the entire length. 25% of L. This is. Now, if you make it 26, it will start falling down. At 25%, it begins to slide. It has not slided yet. It begins to slide. It has not slided yet. It begins to slide. Okay. So 25% of the L is hanging. So how can you write this 25%? See guys, 25% means 25 divided by 100. Sir, 10% means 10 by 100. Yes. 30% means 30 by 100. Yes. So L. 25 ones are, 25 fours are. So what is the value of X? L divided by 4. Now what does the question say? What is the coefficient of friction between the rope and the table? It says coefficient of friction. Guys, as we know, what is the value of L? Mu into L upon 1 plus mu. We are supposed to find the value of mu. Multiply over here. This will be x plus mu x is equal to mu into L. Now take it over here. Okay, in this particular, okay, take it over here. This will be x is equal to, this will be mu into L minus mu into x. Now take mu common. So x will be equals to, if you take mu common, L minus x. Take it over there. So mu will come out to be x upon L minus x. Now this mu will be, what is the value of x? L by 4. L divided by 4 into L minus L by 4. Because here also it is x, na? So mu will come out to be L divided by 4. This is 4L minus L. That is 3L divided by 4. 4 and 4 will cancel. L and L will cancel. It is 1 by 3. Value of mu is 1 by 3. Is this clear? Oh, tell me. Quick. Smash the like button, guys. If you have not liked this session yet, I would want you guys to smash the like button quick. See, rough and smooth inclined surface. This is important. This is also important. This is another variety. Very important. See guys, in this particular case, what does it say? Let's suppose there is an inclined plane. It is smooth. It is smooth. And this is theta. The same inclined plane, but it is rough. So friction will be here. Friction will be here. If you release the object from here, it will fall down. It will take some time. If you release the object from here, it will also slip down. It will take some time. Obviously, I can say, sir, time taken here will be less than time taken here. Okay? Yes. Time taken in slipping down will be less in smooth as compared to time taken in the rough surface. Now see, if the time taken, guys, understand this very carefully. If the time taken on rough surface, understand this, is n times of time taken on smooth surface. Okay. If the time taken on rough surface is n times of the time taken on smooth surface. Let's suppose time taken on rough surface is 2 times of the time taken on smooth surface.
Let's suppose on smooth surface, it is taking 10 seconds. Okay. Here it is taking twice. So 2 into 10 is 20. Here it will be taking 20 seconds. Then in that case, coefficient of friction of this surface rough, it will be n square minus 1 into n square into tan theta. Direct. If time taken on smooth, on rough is n times of the time taken on the smooth, then coefficient of friction of this will be n square minus 1 upon n square into tan theta. If the time taken by the block to go down on a rough surface, on a rough surface is n times of the time taken by the block on the smooth surface, n times the time on the smooth surface. Okay, on smooth surface, time taken on the rough is n times on the smooth, then coefficient of friction n square will be n square minus 1 divided by n square into tan theta. This is the coefficient of friction of the rough surface. I hope this is crystal and clear. Take a look at the question. A body slides down on a rough inclined plane of angle of inclination 30. Okay, angle of inclination 30. As time taken and takes time twice as great as time taken in slipping down on an identical frictionless plane. So here it says time taken on rough surface is 2 times time taken on smooth surface. Okay. The coefficient of friction between the body and the plane is, we are supposed to find the value of mu. But tell me, what is the value of mu? What is the n square minus 1 upon n square into tan theta? So that is n square minus 1 into n divided by n square minus 1 divided by n square into, I would say, tan theta. Now, what is the value of n in this particular case? N is 2 because it is 2 times. So mu will be, that is 2 square minus 1. 2 square minus 1 is 4 minus 1 is 3 upon 2 square is 4. And then we say tan of theta is how much, bro? 30, tan 30. So mu will come out to be 3 divided by 4 into tan 30 is 1 by root 3. Now multiply with root 3 and divide with root 3. Root 3 into root 3 is 3. So answer is root 3 divided by 4. This is the value of mu. This is the value of mu. Is this clear? Oh? Tell me in the chats, everybody. Now you have vertical truck box problem. Is this clear? And smash the like button. Huh? Why are you not liking the session? Mark the attendance quick. Then some people will come in the chats. These Unacademy teachers are always asking for likes. How many times do I need to like this session? Okay. So do like this session. Come on. Quick. Vertical truck box problem. Guys, see. Vertical truck box problem says, what must be the acceleration of the truck so that the block does not fall? With what acceleration truck should move so that the block does not fall? Now see, this is the block, my dear NEET aspirants over here. This is the block over here. I want you to understand in this particular case one thing. What is that? See. If this is the block, what is the force acting on this block in the downward direction? Mg. What is the force acting on this block in the upward direction? That is friction. Upward direction is friction, downward direction is Mg. And what is the force acting on this in this direction? That is normal reaction. Because this block, this platform is applying. And what is the force acting on this in the backward direction? Pseudo. Because acceleration of truck is backward. Put the observer inside. We say friction, pseudo will act in the backward direction. Can I say in this particular case, what is the condition? Sir, when the block is not going to fall, when friction is either greater than mg or equal to mg. If mg becomes greater, then it will fall. So we say this friction must be equal to mg. And second, normal reaction and this must be equal. N is equal to m into at. Normal reaction is n, and this is mass into acceleration of the truck, pseudo. Now, how can we write this friction? Mu into n is equal to mg. So this is mu. What is the value of n? It is mass into acceleration of the truck is equal to m into g. Now, my dear NEET aspirants, can I say in this particular case, m and m will be cancelled? So acceleration of the truck must be equal to g divided by mu. Even this was asked once in JEE. So acceleration of the truck must be greater or equal to g divided by mu. Then only the block will not fall. Because we have taken those conditions only. When is the block not going to fall? When f is equal to mg. Then only we got this relation. So this must be the acceleration of the truck. This is vertical truck box problem. Now, if let's suppose we ask you a question in this particular case, what must be the force applied to the block so that this block must not fall? Now see, we said the block will not fall when acceleration of the system or acceleration of the block or acceleration of the system must be equal to g divided by mu. Now, if this acceleration the system has, the block will not fall. Now, if this is the acceleration, then force is equal to mass into acceleration. Now, this force will be equals to mass. What is the mass? This m plus this m. So that is this m plus small m into acceleration is g divided by mu. We say if this is the force acting on the block, then only the block will not fall. Why, sir? Because acceleration is g by mu. When acceleration is g by mu, it will not fall for sure. So the force which is created due to this acceleration, so that force will not let the block fall. Simple. Then you have truck box problem. This is horizontal truck box problem. Horizontal truck box problem. See guys, what does horizontal truck box problem mean? There's a truck over here. There is a block placed on this truck. Okay. There is a block placed on this truck. Okay. Now guys, take a look. Take a look. In this particular case, if I say acceleration of the truck is forward, this is the acceleration of the truck. On this block, if it wants to fall down, what is the distance it wants to cover? D. Absolutely cool, sir. I am saying in this particular case, in the backward direction, we say pseudo is acting on this one, this F pseudo, backward. So which is holding the block, that is friction. One thing, case first, case one. Okay, I'll just write over here. Case one. My dear NEET aspirants, if I say this frictional force is greater than pseudo force, this force is greater than pseudo force, will the block fall? No, sir, 100%, because holding force is greater than pulling force. So in this case, we say block will not fall. Block will not slide. Okay. So what is the frictional force? Mu into n. Okay. Or mu into mg. Okay. You write it like this. If this force is less than frictional force. So this is mass into acceleration of the truck is less than mu m into g. This and this will cancel. So acceleration of the truck is less than mu g. So when acceleration of the truck is less than mu g, block will not fall. Case 2. If this force is equal to frictional force. So this is mass into acceleration of the truck is equal to mu mg. This and this will cancel. So acceleration of the truck is equal to mu into g. So this is the acceleration when block falls. When block begins to slide. Block is about to slide. Or block is about to fall. This case 2. Then case 3. Then case 3. If this force, pseudo force, is greater than FPFS is greater than frictional force, then block will slide. Then block will slide. We say if, guys, if this force is greater than this force, then in that case block will slide. Block will slide. Then, my dear NEET aspirants, we can say mass into acceleration of the truck is greater than mu mg. So this and this will cancel. So acceleration of the truck is greater than mu into g. So when this is the condition, in that case block will slide. If acceleration of the truck is this, then block will slide. Now see, when block slides, then block will have a relative acceleration. A relative acceleration. So in this particular case, we say block will have its own relative acceleration. Okay. Block will have its own relative acceleration. Okay. Guys, in case 3, when this force becomes greater than this force, then block will slide. So it will have its own acceleration. This is the acceleration of the truck. So the acceleration of the block in that particular case, or we call it a relative acceleration. We call it relative acceleration with respect to truck. That will be acceleration of the truck minus mu k into g. This you will be remembering directly. Okay. Now, some people also, sometimes question have been asked like this. Time taken to fall the block. Fall the block. How much time this block is going to take in falling if it covers distance d? Use this formula. S is equal to ut plus 1 by 2 at square. So S is the distance d. Initial velocity of the block is 0. Guys, how much time this block is going to take in falling? Initial velocity is 0 because initially it is at rest. Okay, 1 divided by 2. This is A relative. This A relative. This you can find A relative like this. And then this is t square. Take it over here. 2d divided by A relative. This is acceleration of the block is equal to t square. So t will be under root of 2d divided by A relative. This was asked in JEE. Let's begin. Come on, guys, give me the signal in the chats. Is everybody alive? Smash the like button. Come on, quick, 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 quick. I have shown you all the problem patterns, okay? Make sure everybody is taking the notes, huh? I'll be sharing the notes on the Telegram channel. t.me/YAWAR MANZOOR. Okay. Let's begin, huh? Okay. Let's start, guys. Let's start. Work done. Work done. What does work done actually mean? See, guys. See, let's suppose you have a surface over here. This is the surface that you have. Okay. And on the surface, you are placing a block. Let's suppose there is a block placed on the surface. And you are applying the force F on the block. You are applying the force F on the block. Now, this block starts moving. Okay, it starts moving. It has covered a displacement of, let's suppose, S. S is the displacement covered by the block. So whenever you apply a force on any body and it starts moving, it starts covering some distance, we say work has been done. We say work has been done. Okay. And in this particular case, my dear NEET aspirants, listen carefully. Listen carefully. So if this is the block, we are applying force F on the block at an angle of theta. At an angle of theta. Okay. Now we say this component will be F cos theta. This component will be F sin theta. F sin theta. This will be F cos theta and this will be F sin theta. Okay. Now due to this force, let's suppose the block has covered the displacement S. We say work has been done. So we say when force acts, when force acts on the block, and work is done. Work is done. And display, when force acts on the block and it covers some displacement. Some displacement. So work is done. Work is done. We say simply what? Work is done. Now, my dear NEET aspirants, in this particular case, I want you guys to understand. When I write work done over here, work is done. See, guys, this displacement is created because of what? F sin theta or F cos theta? F cos theta, because it is pulling the body in the forward direction. So this will be F cos theta and work displacement is S. So I can write this is F S cos of theta. So work done is force multiplied by displacement. The reason I'm taking over here F cos theta, because this is displacing the body. So we can write it work is equal to F vector dot F vector, S vector. So dot product of F and S is work. Dot product of F vector and S vector is work.
So when force acts on a body and it starts moving, work is being done. Now let's suppose this is the force F, this is displacement S. In this case, theta is less than 90. When theta is less than 90, my dear NEET aspirants, in that particular case, we say cos theta is negative. Okay, sorry, cos theta is positive. If you see cos 45, cos 60, okay, cos 30, all of these are positive. So I can say then work done in this particular case will come out to be positive. Directly remember, when theta is less than 90, work done will be positive. Now see, this is the force, this is the displacement. In this particular case, theta is greater than 90. So cos theta will be negative. Like cos 120, cos 150, cos, okay, 130. All these values will be negative. So work done in this particular case is negative. If theta is 90, we say cos 90 is how much? Cos 90 will be 0. So work done in this particular case is 0. This is called zero work. When angle between force and displacement. Let's talk about this question. Find the work done by external force, frictional force, mg and normal reaction. See guys, this is the block over here. So external force is acting on the block in the forward direction. It is displacing by displacement S. What is the work done in this particular case due to external force? Guys, see. You'll be simply saying it is force is F, displacement is S, and then we say cos theta. What is the angle between force and F? That is 0. So it is Fs. If I say what is the work done by friction? Don't think that, sir, this force is only displacing the body. We have to apply work done formula for this force. No, we can apply for any force. If there is displacement, if there is force. So work done will be frictional force, displacement and cos of 180. In this case, friction is backward, displacement is forward. That's why cos 180. So it is minus Fs. Now, my dear NEET aspirants, when it comes to work done by normal force, it will be normal force N, displacement S. What is the angle between normal and displacement? 90. So cos of 90. Cos 90 is 0. So work done by normal force will come out to be 0. Okay. Then if I say what is the work done by my dear NEET aspirants? mg. So it is going to be mg. Displacement is S. Then we say cos of 90. So this is going to be 0. So this is the work done by all the forces over here. Let's take a look at this. This is the question asked in NEET 2016. Take a look at the question, guys. A particle moves from this point. This is the point. So its position vector is given as minus 2i cap plus 5j cap. To this point, its position vector is given as 4j cap plus 3k cap. Okay. This is the position vector of the particle. When a force of this is applied on the particle, okay, on this particle force is applied, I would say 4i cap plus 3j cap. Then how much work has been done by the force? We need to find the work done. Guys, this is the initial position, this is the final position. What is the displacement? Final position minus initial position. Now, final position here, is it 4j? 4j plus 3k. Okay. So what is the I cap over here? 0. So 0 final minus. Initial over here is minus 2. So 0 minus of minus 2 is 2. So this will be 2i cap. Okay. Then here it is 4j, here it is 0j. So 4 minus 0, final position minus initial position. That is plus 4j cap. Okay. Then k. No. Wait. I made a mistake. Here it is 4j. Okay, 2. Here it is 4j, here it is 5j. So 4 minus 5, final minus initial. So it is minus 1. So it is minus j cap. Okay. Here it is 3k, here it is 0. So 3 minus 0 is 3. So plus 3k cap. This came out to be the displacement vector. Now, my dear NEET aspirants, if I say work done is equal to force dot displacement. You say work done is equal to F dot S. Now tell me, guys, F dot S. This is F, this is S. Now, whenever you have to do the dot product, what is the coefficient of I over here? 4. What is the coefficient of I over here? Do the multiplication of coefficients. Dot product, how do you do the dot? 4 multiplied by 2. 4 into 2 is 8. Okay. Then 3 into 1 is minus 3. Then 0 into 3 is 0 into 3 is 0. So work done in this particular case will be 5 joules. Work done is 5 joules. NEET 2013 question. A uniform force of F is equal to 3I cap plus J cap acts on a particle of mass 2 kg. The particle displaces from this position to this position. This is the initial position of the particle, that is 2I cap plus K cap. Okay. This is the final position of the particle, 4I cap plus 3J cap minus K cap. When a force is acting on the particle, how much is the force acting on the particle? That is 3I cap plus J cap. Okay. So you have to find the work done. Work done will be simply dot product of F and S. And S you can find final position minus initial position. This I am giving you as homework. This you guys need to do it from your end. Now guys, tell me in the chat if this is clear. Is this clear? Oh, quick. Is this clear? Tell me. Tell me. A rope is used to lower a block of work. Okay, there is a block. Guys, see, this is a block. It is connected to a rope. Okay. A rope is used to lower a block of mass M. Okay. By a distance X. Okay. By a distance X. See, what does the question say? There is a rope connected to the block. This is the block. There is a rope connected to the block. Okay. It is lowered by distance X due to the rope. Okay. This is how it is done. Lower the block due to the rope. Take the block down by X distance due to the rope. Okay. Then what does it further says? Then what does it further says? With a constant acceleration g by 2. So acceleration in this particular case, it is given as g by 2. The work done by the rope is, what is the force in the rope? That is tension. It says the work done by the tension. Guys, when it comes to the work done by tension, it is T into X into cos 180. Okay, T into X into cos 180. T into X into cos 180. Because T is upward, X is downward. So what is the angle between T and X? Cos 180. So work done in this particular case will be minus T into X. Yes. Now in this particular question, we have to find the value of tension. So if it says find the work done by the rope, it means work done by the tension. Let's find tension. Let's find tension. How do I find tension? We say net force is equal to mass into acceleration. See guys, what is the net force? What is the force acting on this body in the downward direction? mg. So I'll be saying simply mg is downward minus tension is equal to mass into acceleration. Acceleration is g by 2. Now take it over here. So mg, this will be minus mg by 2 is equal to, take it over here, t. So 2mg minus mg divided by 2. So mg minus mg by 2 is mg by 2. This came out to be the tension. Now tell me guys, if I say work done, that will be minus, what is the value of tension? That is mg divided by 2. And what is the value of x? X is x, displacement is x. This is the work done by the rope or work done by the tension. Work done by variable force.
Now guys, take a look. Work done by variable force. See guys, let's suppose if there is a block over here, you are applying the force on the block, that is 10 Newton. Is this 10 constant or variable? This is constant. Okay, this is constant. Because 10 means 10. It cannot be 11. It cannot be 15. But if I say force acting on the block is 2x, this is variable. Why? Because when x is 1, force is 2. When x is 2, force is 2 into 2 is 4. When x is 3, force is 8. Sorry, 6. So this force is variable. So this equation that you used, this is for constant work done. This is for constant force. When force acting from this point to this point is same, 10, 10, 10, 10, 10. In that case, you'll be putting up this one. But my dear NEET aspirants, when I say work done by variable force, okay, like if this is a body, or directly remember guys, work done by variable force will be simply integration of F ds. That's. And work done by constant force will be what? So it is like if you apply a force on a body from this point to this point. So here from this point to this point, force is not constant, it is variable. Okay. And if I say you have to find the work done from this point to this point, this is x1 or this is s1 to s2. Put the limit s1 and s2. That's it. Okay. Or I'll perfectly write it over here. See guys, so we say this work done will be integration of f ds and then we say cos theta. Okay, so this work done will be integration of f dot ds. So this will be the work done when the force is variable. Directly remember, I'll show you the questions. You don't have to worry about anything. Take a look at the question. If force F is equal to k times of x, F is equal to k times of x square, is it constant or variable? Variable. Why? Because force depends upon x. Then it says, at an angle of 60 degrees with x-axis, the work done in displacing the particle from x1 to x2 is. We have to find, it is acting on a body, okay? At an angle of, this is F at an angle of 60. So from x1 to x2, it is displacing the body. This is x1 and this is x2. We have to find work done. Now you will simply say, sir, work done is integration of F ds cos theta. Or F dx, it is saying in terms of x, so you can write in terms of x cos of theta. So work done will be integration of, what is the value of F? K times of x square, then dx, and then we say cos of 60, and limit is from x1 to x2. Okay, so what can you write over here? Work done will be, take this k out, cos 60 is 1 by 2, so k divided by 2 will be out. Integration of x square, that is x cube divided by 3, from x1 to x2. So work done in this particular case will be k divided by 3 into 2 is 6. Then you will be putting the upper limit in this x2 ka cube minus x1 cube. This is the work done. If a force F is equal to 20 plus 10y is acting on the particle in y direction. There is a particle. Force is acting on this particle in y direction. Okay. Due to this force, it is displaced from y is equal to 0 to y is equal to 1. So here y is 0, here y is 1 meters. You have to find the work done. And this is a variable force, it depends upon y. Work done will be integration of f dy cos theta. So work done in this particular case will be, what is the value of F? 20 plus 10y. Then we say dy, then we say cos of, I would say 0. Because force is acting in the y direction, displace is also acting along y. So it is from 0 to 1. So work done in this case will be What is the differentiation of 20? That is 20y. With respect to y, we are differentiating. Plus, what's the differentiation of 10? 10y. So 10y square divided by 2 from 0 to 1. So work done will be 20y plus 5y square, because 2 ones are 2 5s are. It is from 0 to 1. Then I can say work done will be 20 into, put the upper limit 1, lower limit 0. 1 minus 0 is 1. Then plus 5 into, upper limit in this y square is 1. So 1 square, lower limit is 0. So this is 20 plus 5 is 25 joules. Guys, give me the signal in the chats. Is this clear? So variable force is done. This is the question that I am putting you as homework. You need to look at this question from your end. It is simple. The pendulum comes from here to here. You need to find the work done. Or it is displaced from here to here. Okay. Check the question. You'll get this. This question also I'm putting as homework. Simple, bro. I have shown you already the question of this type. Area under force versus displacement graph. Area under force versus displacement graph. Okay. Is this clear till over here, guys? Do smash the like button, okay? Okay, guys. Okay. Area under force versus displacement graph. Take a look, guys. This is force versus displacement. How do you find this area under this graph? I have told you this area, always it is integration of whatever is on y-axis, whatever is on x-axis, f into ds. Now recently you studied, sir, as what is this f into ds? That is work. Okay. So what I can write over here, area under force versus displacement graph gives us work. Take a look. So if you have to find work done from force and displacement graph, you'll have to find the area. A position dependent force acting on the particle as shown in the figure. Okay. Work done on the particle from 0 to 5 meters. We have to find, this is 4 and this is 5. Work done from 0 to 5 meters. Whenever you have to find the work done, you find area. Okay. Now, first you'll be finding this area, this area, this area. So 1 divided by 2,
How much is the base of this? 1. Altitude is 10. 1 altitude is how much? 10. And area of this, how much is this length? 2 minus 1 is 1. 1 into 10 plus 1 into 10. Okay. Then plus area of this, 3 minus 2 is 1. So 1 by 2, base is 1. Altitude in this case is also 10. Okay. Then area of this minus. Upper area you take positive, lower area you take negative. Then minus 1 divided by 2. Base is 4 minus 3 is 1. Altitude is 10. 1 into 10. Then area of this. So 5 minus 4 is 1. Length is 1. Breadth is 10. So it is minus 1 into, I would say, 10. So. This and this will be cancelled. This and this will be cancelled. So 2 1s are, 2 5s are. So work done came out to be 5 joules. Let's talk about this one. So in this case also you have to find the work done. The work done on the particle during a displacement of 12 meters. So 12 meters. Guys, the graph is like this. So here graph is this. Means from 0 to 3 meters you are applying no force. 0 to 3 meters, no force. Force is 0. Because graph actually starts from here. So means you have to find this area. Okay. So in this particular case, when I say work, it is area. Area of this 7 minus 3 is 4. And this is given as 2. Then plus its base. So 1 divided by 2. How much is the base? 12 minus 7 is 5. Altitude is 2. This and this will cancel. 4 2s are 8 plus 5 is 13 joules. Work done by gravity. Guys, understand this very carefully. Work done by gravity. Work done by gravity. Guys, see, if I say there is an object over here, its mass is m, you are releasing this object, it falls down by High-weightage. What is the work done in this case? Work done will be force is mg, due to work done by mg. Displacement is h, mgh. Displacement is h. And then how much is the angle? This is mg and this is h. Then we say cos of 0. So work done in this particular case will be mgh. In this case, if you throw the body up, then it falls down. How much is the work done in this case? Work done is mg. Okay, downward. Displacement is, guys, no doubt it has gone up. But what is the displacement? Initial point, final point. That is h, mgh again. In this case, you are throwing the body. Here you are releasing. Here you are throwing the body. In this case also, work done will be mg into h. In this case, you are throwing the body horizontally. Something like this. It falls down. If I say, what is the work done by mg? You say, sir, work done by mg is mg. But how much is the displacement? Displacement is this much, na? I don't say displacement is this much. So displacement vertical is this much, na? So mg into h. So don't you think here path is this? Here path is this. Here path is this. But we say work done in all the cases is same. Work done in all cases due to the gravity is same. Yes. So we say this gravity is what we call conservative force. Conservative force. Okay. So my dear friends, that force whose work done is path independent, its work done does not depend upon path. Its work done does not depend upon path. So we say it is path independent. That's why we call it conservative force. That's why we call it conservative force. Its work done does not depend upon the path. Its work done does not depend upon the path. Okay. So it depends upon initial and final point. So this is conservative force. And when it comes to the friction, guys, directly remember it is a non-conservative force. Non-conservative force. Okay, we say it's work done. Its work done depends upon path. Its work done depends upon path, but work done due to gravity does not depend upon the path. Work done due to gravity does not depend upon the path. Okay.
Is this clear? So along different paths, work done due to gravity will be different. Guys, tell me in the chats if this is clear, and smash the like button if you are not liked the session yet. Work done by spring force. See guys, let's suppose you have a spring over here and a block is connected. Now you are elongating this block from here to here. This is x1 to x2. So you are elongating this block from here to here. So we say in this particular case, spring force will be developed. And this displacement is from x1 to x2 in this particular case. Now, my dear NEET aspirants, don't you think that in this particular case, when we define work done, so we say here work force is there. We say in this particular case, displacement is there. Okay. So we say there will be work done. So my dear NEET aspirants, when you elongate this, so means spring force is created, displacement is there, force is there, displacement is there, there will be work done. And if I say what is the work done by spring force, this will be minus 1 divided by 2k. Then we say x final square minus x initial square. This will be the work done by the spring force. This will be the work done by the spring force. Okay. This will be the work done by spring force. Okay. Yes. Okay. So this is work done by spring force. Now, my dear NEET aspirants, one more important thing I just want to tell you over here. If work done by spring force is W in elongation of 2 meters. See guys, let's suppose you are elongating a block from 0 to 2 meters. X initial is 0 and X final in this particular case is 2 meters. If I say what is the work done over here? Sir, work done in this particular case is minus 1 by 2 K X final minus X initial square, that is 2 square minus 0. So work done in this particular case will be minus 1 divided by 2k into 4. 2 1s are 2 2s are 4. So work done in this case will be minus 2k. Then it says if work done by the spring in elongation of 2 meters is W, then find the work done in the further elongation of 2 meters. Then it says further it elongates by 2 meters. So we say this will be X initial considered as 2. And in this particular case, X final will be considered as from 2. This will be exactly, I would say 4 meters. This will be 4 meters. Now in this particular case, my dear NEET aspirants, when I say work done over here, work done will be 1 by 2k. Guys, because if you further elongate it by 2 meters, so it is 2 and 2 plus 2 is 4. So this will be minus 1 by 2k, x final square is 4 square, initial square is 2 square. So work done in this case is minus 1 by 2k. 4 square is 16 minus 4. 16 minus 4 is 12. So 2 1s are 2 6 are 12. So work done will be minus 6k. Now can I write, this is W dash. So W dash will come out to be, this will be 3 into minus 2k. Yes, instead of minus 2 you can put W. So W dash in this particular case will be 3 into, instead of minus 2k you will be putting W. So it will come out to be 3W. It will come out to be 3W. If a force constant of a wire is K and another is 2K, okay, when both are stretched by same distance, then the work done will be, guys, we say work done is minus 1 by 2K x final minus x initial square. I can write this x square. X final minus x initial will have some value x square. Now it says elongation is same, x is same. A force constant of a spring is K and that of another spring is 2K. You have two springs. First has force constant K. Okay. And another spring has force constant 2K. Both are stretched by same distance. X is same. Then it says work. Then the work done will be. See guys. If X is same, so can I say this W is proportional to K? Yes. This is constant. Leave minus. W is proportional to K. Absolutely. So can I say W1 divided by W2 will come out to be K1 by K2? Absolutely. So can I say W1 divided by W2 is equal to K1 is given as K divided by, I would say 2K. This and this will cancel. So 1 by 2. This is the ratio of the work done. Okay. Then the work done will be the ratio you guys are supposed to find out. Kinetic energy. Okay. Kinetic energy. Guys, see, kinetic energy is that energy which is due to the motion. Whenever an object is in the motion, we say it has kinetic energy. Like my dear NEET aspirants, if this is an object over here, its mass m, it has velocity v. So we say it has kinetic energy. And its kinetic energy will be simply 1 divided by 2 mv square. This is the kinetic energy of the object. That is 1 by 2 mv square. 1 divided by 2 mv square. Now, my dear NEET aspirants, this is the kinetic energy is equal to 1 by 2 mv square. So m is the mass, v is the speed. It is not velocity. Okay. Because if you multiply velocity here, kinetic energy will become vector, but it's a scalar. So it has to be here speed. Now guys, do one thing, multiply with m. So this is kinetic energy is 1 divided by 2 m v square. Multiply with m and divide with m. So you will be saying, sir, kinetic energy will be simply m into m becomes m square v square divided by 2m. Now we know that m into v is momentum, p is equal to mv. So can I write over here kinetic energy is equal to p square divided by 2m? Yes, sir. So we got two formulas of kinetic energy, 1 by 2 mv square and second one is p square by 2m. Now take a look. We say kinetic energy is equal to 1 by 2 mv square. Okay. If I say, my dear NEET aspirants, velocity of an object is constant. Let's suppose two objects are there. Their velocity is constant. Two objects are there. Their velocity is constant. Then we say kinetic energy is proportional to their mass. Then we say kinetic energy is proportional to their mass. And in that particular case, if you make the graph between kinetic energy and mass, okay, it is going to be the direct relation. It is going to be the direct relation. Now, my dear NEET aspirants, if I say kinetic energy is P square divided by 2m, P square divided by 2m. So, if let's suppose momentum of an object is constant, let's suppose you have two objects, their momentum is constant. Then we say kinetic energy is inversely proportional to mass. Why? Because this term becomes constant, it is inverse. So in that particular case, I can say the relation between kinetic energy and mass, it is going to be this, a rectangular hyperbola. Rectangular hyperbola. Okay, take a look. Two bodies with kinetic energies are in the ratio of 4:1. You have two bodies, their kinetic energy first divided by kinetic energy of second is 4:1. This is the ratio of kinetic energy. Are moving with equal linear momentum. So momentum in this particular case is constant. You have to find the ratio of their mass, m1 divided by m2. First of all, you tell me one thing. Which of the two relations you are going to use over here, first or second? Momentum is constant, so obviously second. So we say in this particular case, when momentum is constant, mass is inversely proportional to kinetic energy. So we can say m1, or you write this. Kinetic energy is inversely proportional to mass. So you can say kinetic energy of first divided by kinetic energy of second, it will be m2 divided by m1. So you have to find the ratio, na? So k1 by k2 is 4 divided by 1 is equal to m2 divided by m1. Okay, now I can say m1 divided by m2 is 1 divided by 4. 1 divided by 4. An object of mass 4 kg is moving with a velocity this is velocity. Find kinetic energy. Guys, when I say kinetic energy, it is simply 1 by 2 mv square. This v is speed. So if velocity is given, you need to find its magnitude. Under root of, it is 1 square plus 1 square. So don't put directly I cap plus j cap over here. Then it becomes wrong. It becomes incorrect. So this mod of v in this particular case is under root of 1 plus 1 is root 2. Okay. So now kinetic energy in this particular case will be 1 divided by 2. Mass is given as 4 and velocity is given as a root 2 its whole square. Square and root will cancel. 2 ones are 2, 2s are 4. 2 into 2 is 4. So this is 4 joule. Percentage change. Is this clear? Oh? Tell me. Tell me guys, is this clear? Is this clear or tell me in the chats, everybody? Okay. Now, guys, percentage change. See, guys, let's suppose we have a physical quantity y which depends upon x. We have a physical quantity y which depends upon what? X. Okay. What does it mean? If x changes, y changes. Physical quantity y depends upon x. If x changes, y changes. And how do you write change in x? Delta x divided by x. This is called change in x. And how do you write change in y? Delta y divided by y. This is called a relative change. Directly write it. So if there is a change in x, there will be change in y. Now, in order to find the change in percent, if I say x is changed by 2%, x is increased by 2%, tell me how much will y increase? How many percent y is going to increase or change? Percentage. Now, percentage change. Percentage change. You simply say percentage change will be, this percent delta y divided by y. It will be here delta x divided by x into, I would say, 100. Into, I would say, 100. This is called a percentage change in y. This is called a percentage change in y. Okay. Now let's suppose y is equal to x square. Y is a physical quantity which depends upon x square. So here, how do you write the change? Whenever you have power, or y is equal to x raised power n, we say y is equal to x raised power n. Take this power down, and down delta x divided by x. It will be delta y divided by y. Okay. Now, my dear NEET aspirants, you multiply over here percent and you multiply over here 100. So this is going to be the percentage change in y. This is the percentage change in y. But always remember, you will be using this. You will be using this when the change is up to 5%. Use valid only if change is small, up to 5%. I'll show you. If you say, sir, 5% change in x, what will be the change in y? You can use this formula. Now, in terms of kinetic energy, if I say, guys, listen carefully. We say in terms of kinetic energy. In terms of kinetic energy. See, guys, in terms of kinetic energy means we say kinetic energy is equal to P square divided by 2m. Consider mass constant. You simply say kinetic energy is equal to P square. Mass is constant. Leave mass. Now, can I say if the momentum of an object changes, we say kinetic energy changes. So kinetic energy is a physical quantity which depends upon momentum. If momentum changes, kinetic energy changes. How do you write change in momentum? 2 delta P divided by P is equal to change in kinetic energy upon original kinetic energy. Now, if you have to find in percent, so multiply this with 100 from this side. This will be the change in kinetic energy. But you will be using this equation only when change is up to 5%. Like. The question here is, if the momentum is increased by 3%, see, momentum is increased by 3%. What does that mean? That means delta P divided by P into 100. This is called percentage change in momentum. This is given as 3%. Then the percentage change in kinetic energy will be, if momentum is changed by 3%, change in kinetic energy will be, guys, we recently studied, that is percentage delta K divided by K will be 2 delta P divided by P into 100. Now, value of this is given as 3%. So you will be simply saying 2 into 3%. So this will be 6%. So kinetic energy will change by 6%. Kinetic energy will change by 6%. Okay.
Now, if the percentage change is large, if the momentum of the body is changed by 200%, what will be the percentage change in kinetic energy? Then that is not valid. Let me show you what is valid. See, guys, we say if the change is large, remember this. Then we say in that case, how do you find percentage change in y, delta y divided by y? Simply, if the change is large and y is equal to x raised, or y is equal to x, okay, you'll be simply saying in this particular case, guys, see, that is final value of x minus initial value of x divided by initial value of x into 100. Use this. Let's suppose if I say y is equal to x square and change is large, how do you find percentage change in y? Delta y divided by y will be x final square minus, because here square is given, x initial square divided by x initial square into 100. Done, sir. Done, sir. Now, in terms of kinetic energy, now guys tell me, in terms of kinetic energy, how do we write this in terms of kinetic energy? See, guys, we say percentage change in kinetic energy. It will be simply, so we know, sir, kinetic energy is equal to p square. You will be simply saying, sir, it is p square, so final momentum square minus initial momentum square divided by initial momentum square into 100. Array, sir, amazing, amazing. Okay, now let's take a look at this question. If the momentum of a body is increased by 200%, okay, as let's suppose initial momentum is p, final momentum is increased by 200%, okay. So if something is increased by 200%, so already it was 100%. If I say I have a pen over here, how much pen is this? 50%, 70%, how much? 100%, complete pen. If it was 50%, I would have mentioned it is 50%, but it is 100%. Now, if it is increased by 200%, already it was 100%, so it will be 300% of initial momentum. 300% of initial momentum. If I say momentum is changed to 300%, to change to 200%, then final momentum is 200%. There is a difference between to and by. By means you add. To means that is the final value. Now see, 300% means simply 300 divided by 100 into p. 0, 0, 0, 0. So this will come out to be 3p. So final momentum is 3p. Now see, percentage change in kinetic energy. Percentage delta k divided by k. It will be final momentum square minus initial momentum square upon initial momentum square. Okay. Into we say 100. So now tell me final momentum square, that is 3p square minus initial momentum square p square upon p square into 100. So 3p is 9p square minus p square is 8p square. 8p square divided by p square into 100. P square will cancel, so it will be 800%. So if momentum is changed by 200%, kinetic energy will change by 800%. Okay, this is another question. This is homework that I am giving you. Here it is saying 2. So 2 means final momentum is 200%. Okay, this is also given in this particular case. Okay, one more important thing I just want to tell you. See guys, if I say if kinetic energy is changed, then find percentage change in momentum. Okay, reverse. Guys, we know, sir, kinetic energy is equal to momentum square. Take the square over here. So P will be under root of K. Now see, how do you find the percentage change in momentum? Delta P divided by P. It will be, if the percentage change is large, sir, it will be kinetic energy final under root. Array, sir. If it was square, put square. If it was n, put n. Minus under root of kinetic energy initial divided by under root of kinetic energy initial into 100. Use this equation and smash. Use this equation and smash the question. Work energy theorem. Is this clear? Please tell me in the chats, everybody out there. Come on, guys, quick. Okay. Now guys, work energy theorem says work done by all the forces is equal to change in kinetic energy. See, work done by conservative force, work done by all the force means work done by conservative force, work done by non-conservative force, work done by internal, work done by external, it is equal to change in kinetic energy. Let me give you the feel. Let's suppose we are taking this question. Okay, how many forces are acting? F is equal to 100 Newton, friction is acting. Let's find work done by all the forces. Let's find work done by all forces in this particular case. Let's find work done by all forces in this particular case. First of all, work done by F force, this F force. You say F force into displacement. Displacement is S, then we say cos of 0. F is how much? 100. Displacement is how much? 10. Okay, this will be 1000 joules. Cos 0 is 1. 1000 joules. If I say work done by friction, so it will be frictional force into displacement, and then we say cos of 180, because displacement is forward, friction is backward. So work done by frictional force will be, friction is mu mg, mu into n, then we say s, then we say cos 180 is minus 1. So put that minus here. So work done in friction by friction will be, what is the value of mu? Mu is given as 0.4. 0.4 will be 4 by 10. What is the given of mass? Value of mass, that is 10. G is 10. Okay. And displacement is also 10. 10, 10. 4 and 10 is 40. 40 into 10 is 400. So work done by friction will come out to be minus 400 joules. Okay. If work done by friction comes out to be minus 400 joules, then what is the work done by normal reaction? Work done by normal reaction is 0, because normal is upward, friction is forward. This is normal. Okay. And this is mg. What is work done by mg? That is also 0. Why? Because mg is downward, displacement is forward. So angle between mg and s is 0. So what is work done by all forces? All forces. You say, sir, 1000 joules minus 400 joules. So that will be 600 joules. This came out to be the work done due to all forces. Now let's find change in kinetic energy. Delta K. Change in kinetic energy means, final kinetic energy means in minus initial. Final kinetic energy means 1 by 2 mass into final velocity square. Sorry, final speed square. Minus 1 by 2 mass into initial velocity, initial speed square. So here you can take 1 by 2 m common. Final square minus initial square. Okay, 1 divided by 2. So it is 1 divided by 2. What is the value of mass? Mass is 10. Final velocity is
root 120. When you put the square, it will become 120. Minus, initially starts from rest. So initial velocity is 0. So 2 ones are, 2 60s are. Now 60 into 10 is 600. 600. So delta Ke, change in kinetic energy, is also 600 joules. And work done by all the forces also 600 joules. So can I say work done by all forces came out to be change in kinetic energy? Yes. This is the work energy theorem. This is the best example which can explain work energy theorem. So work energy theorem simply says work done by all the forces is equal to change in kinetic energy. See, according to work energy theorem, work done by all the forces is equal to change in kinetic energy. Work done by conservative force means mg. Work done by non-conservative means friction. Work done by internal, work done by external, it is equal to change in kinetic energy. Final kinetic energy minus initial kinetic energy. Let's take a look at this question. A particle of mass 3 kg is moving along x-axis and its position versus time is given. So this is the position of the particle. X is equal to 2t square plus 5. Work done by all the forces acting on the particle from t is equal to 0 to t is equal to... Okay. Guys, position is given. How can we find the work done over here? Work, see, displacement is not given, force is not given, displacement we can find, by the way, but force is not given. So we can use this work done by all the forces is equal to change in kinetic energy. So work done is equal to final kinetic energy minus initial kinetic energy. That is 1 by 2 m v final square minus v initial square. You can see this. But the point in this case is you need to find v final first. So if position is given, you can find velocity. Velocity is dx by dt. So that is 2 into 2 is 4t and differentiation of 5 is 0. Okay. Now if I say initial velocity at t is equal to 0. What is the value of initial velocity? Put t is equal to 0 over here. So this will be 0. At t is equal to 3 seconds. Final velocity will be 4 into 3 is 12. Now you can use this. Work done is equal to 1 divided by 2. What is the value of mass, bro? Mass is given as 3. Final velocity square, that is 12 square. Minus initial velocity square is 0. Okay. So work done in this case will be 3 by 2 into, this is 12 square means 12 into 12. 2 ones are 2, 6 are 12. Okay. Okay. So 144. 12 square is 144. 2 ones are, 2 sevens are, 2 twos are. Work done is equal to 3 into 72. Okay. Two 116, huh? That is great. A particle, okay, here. A particle of 2 kg travels along a straight line with v's. Velocity of the particle is given. V is equal to a root x. A under root of x. The work done by the net force during the displacement of particle from x is equal to 0 to x is equal to 4 is. Okay. Guys, see, in this particular case, at x is equal to 0, let's find initial velocity. Put x is equal to 0 over here, velocity will be 0. At x is equal to 4 meters, what is the velocity? This is final velocity. That is a into root 4. Root 4 will be 2a. This is final velocity. So from, see, it is common sense, bro. If velocity is given, you can find initial velocity, you can find final velocity. So you can say work will be 1 divided by 2 mass into final velocity square minus initial velocity square. Work energy theorem, na? So work done in this particular case will be 1 by 2. What is the mass of the object given? That is 2. Final velocity square, that is 2a whole square, that is 4a square, minus initial is 0. So 2 and 2 will be cancelled. Work done in this particular case will be 4a square. So basically, whenever the questioner asks you the work done, and if somehow you are able to find initial and final velocity, then use work energy theorem. Then use work energy theorem. Like this question, it is common, sir, velocity time graph is given and clearly I can see at t is equal to 0, you can see velocity is 20. So initial velocity is 20. At t is equal to 2 seconds, clearly I can say final velocity is 0. Now, since you got initial, since you got final, you can find work energy theorem. So I can say work energy theorem will be 1 by 2 m, mass is m, v final square minus v initial square. Okay. So work energy theorem will be 1 by 2 m. What is the value of mass, guys? That is 2. Final velocity square. Final velocity is how much? That is 0. Minus initial velocity is how much? That is 20 square. Okay, this and this will cancel. So this will be minus 400 joules. See? Work energy theorem makes questions very simple and very easy. Is this clear? Oh, guys, tell me. Come on. Oh, smash the like button if you have not liked the session yet. Come on, quick. Make the like count 400. It is 379 right now. Make it 400. Potential energy. Now, guys, this is for the first time you will be understanding potential energy. This is for the first time you will be understanding potential energy. Okay. My dear NEET aspirants, when it comes to the potential energy, listen to me very carefully. Let's suppose you have an object over here on the surface. Its mass is m. You are taking the surface to the height h. Okay, this is height h. So means you are applying the external force over here. This is the external force which you are applying. In the downward direction, I would say mg is acting on the object. Mg is acting in the downward direction on this object.
an external force you are applying in the upward direction. Okay. Now, my dear NEET aspirants, what I'm trying to say in this particular case is, you are doing the work done. Okay. So, in lifting the block from this point to this point, okay, the work done in lifting the mass m to height h. Now this work done, this energy which you used, your own energy, is stored in the form of potential energy. It is stored in the form of potential energy. Okay. So can I not say, due to this external work done, potential energy of the object is changed? Yes, I can say it like this. Because here potential energy was something. Here potential energy would be something in this particular case. Okay. Yes. So due to this external work done, that you lifted the block from here to here, we say potential energy is changed. We know, sir, from here to here, potential energy will be stored. Yes. Now, if I say, my dear NEET aspirants, what is the work done by the external force? Sir, you say worked. Okay, first of all, we say whatever is the value of external force, same will be mg. So if mg is 10 Newton, we are applying external force also 10 Newton. Why? Because we need to take the block slowly, so that our work done should not change its potential energy. Our work done should be completely stored in the form of, so that our work done should not change its kinetic energy. So that our work done should be completely stored in the form of potential energy. So that's why this force has to be exactly equal to this force. Now, if I say what is the work done by external force, you say it is force into displacement. It is external force into displacement is h, and then we say in this particular case cos theta. Okay. We say magnitude wise this and this are same. And what is the angle between, my dear friends, this force and displacement? That is 0. Absolutely, sir. Now, whatever is the value of this, same is the value of this. So you will be saying, sir, work done by the external force is equal. Instead of this, I can write mg. I'm just putting the value of mg over here. I'm not putting the force mg. I'm putting the value of this, because value, if this is 10, this is also 10. I'm just putting 10 into h. Cos 0 is 1. So this will be the work done due to the external force, mgh. So if this is the work done due to the external force, this work done only will be stored in the form of potential energy. Yes. Now, my dear NEET aspirants, one more important thing. What is the work done by mg? Okay, this is work done by conservative force. Yes. So, okay, what is the work done by mg? You say, sir, work done by mg will be simply force is mg, displacement is h, mg, h, and then we say cos 180. Absolutely, sir. So work done due to mg will come out to be minus mg into h. Sir, why did you put 0 angle over here? Because I am saying this is external force. You are supposed to see the angle between external force and h. So I'm just putting the value, just the value of external force as mg. It is not the force mg which I am putting. Its value I am putting over here. That's it. That's why it is actually force and h. So can I write over here work done due to this conservative force, because mg is conservative, is equal to minus. What is mgh? This is work done due to external force. Array, sir, amazing. Now guys, take it. Okay. So can I write work done due to conservative force is equal to negative of work done by external force, that is delta U. So this is very important. So work done by the conservative force is negative of change in potential energy. Work done by external force is positive of change in potential energy. Now guys see, since you said as when I say change in potential energy is external work done. So change in potential energy is external work done means, guys,
That is mg into h. Okay. Now, my dear NEET aspirants, we say this is final potential energy minus initial potential energy is equal to mg into h. Let's suppose initially potential energy over here I am assuming 0 because reference surface you need to assume 0. Here potential energy will be UF. So this is 0. So final potential energy at height h will be mg into h. Extremely important. Extremely important. Extremely important. Due to the external force, there will be positive change in kinetic potential energy. Due to the conservative force, there will be negative change in potential energy. And potential energy at height h will be mgh. Potential energy at height h will be mgh. Okay. Now, one more important thing I just want to discuss over here. What is that? See, guys. See, guys. We say due to small work done. Due to small work done. Okay. Due to small work done. Okay. Due to small work done, there will be small change in potential energy. Guys, since you said if we lift an object from this point to this point, large work done, there will be large change in potential energy. But if the object is displaced by a small amount, then in that particular case, change in potential energy is going to be small. Then in that particular case, change in potential energy is going to be small. So, due to small work done, there will be small change in potential energy. This is how do we write small work done, small change in potential energy. And if I say work done by conservative force, due to small work done by conservative force, there will be small change in potential energy, minus, but put the negative sign. How do you write this work done? I told you, sir, small work done will be force multiplied by small displacement, or F dot dr we write over here. Usually ds dr, it is one and the same thing. Okay. We say F dot dr we write over here is equal to minus du. Now take it over here. Force will be equals to minus du divided by dr. This is the relation between force and potential energy. Means if potential energy is given, you are supposed to find force, you'll do the differentiation. Okay. Now, from this equation, one more relation I can calculate. Integrate both sides. Integrate both sides. So it will be integration of du is equal to, take the negative sign over there, minus integration of f dr. Okay. Now guys, integration of du is delta u is equal to minus integration of f dr. Angle I am considering 0, cos 0. So this is basically, if force is given, you are supposed to find change in potential energy, you'll do the integration. If potential energy is given, you are supposed to find the force, you'll do the differentiation. Example, guys, see, if let's suppose potential energy is given as 2x square plus 3x, find force at x is equal to 2 meters. See guys, potential energy is given, you are supposed to find force. You say, sir, F is equal to minus du by dr. That is minus. Differentiation of this, 2 into 2 is 4x. Plus I would say 3. Now, at x is equal to, it says 2 meters. At x is equal to 2 meters, let's find the force. So force will be minus. This is 4 into 2 plus I would say 3. 4 into 2 is 8. 8 plus 3 is 11. So force will come out to be minus 11 Newton. Please tell me in the chat if this is clear. Please tell me in the chats if this is clear. If all these details are clear. Is this clear? Oh, just a second, guys. Now, guys, if work done by conservative force to move an object from A to B, see, guys, first of all, you need to understand work done by conservative force is negative of change in potential energy. Work done by conservative force is negative of final potential energy minus initial potential energy. Now, take a look. If work done by conservative force to move an object is moved from A to B. This is A to B. So work done by conservative force is given as 50 joules. Okay, absolutely, sir. Then find the potential energy at A. Okay. Okay. Now, my dear NEET aspirants, in this particular case, if the work done by conservative force to move an object from A to B is 50 joules, then find the potential energy at A if potential energy at B is minus 20. Guys, see, potential energy at A, okay, you are supposed to find, and potential energy at B is given as minus 20. It is simple, bro. Now, see, work done by conservative force is given as 50 is equal to minus potential energy. Okay, fine. Finally, it is at B, so it is given as minus 20 minus. Initially, it is at A, so initial is given as UA. So people usually make mistakes in these questions because of plus minus. So this is 50. Now tell me, minus into minus is plus. This will be plus 20. Minus into minus is plus UA. Take it over there. 50 minus 20 is equal to UA. So U potential energy at A will be 30. Tell me if this is clear. Tell me if this is clear. Okay, next one on this one. If the work done by conservative force is 30 joules, work done by conservative force is given as minus 30 joules in moving an object from A to B. In moving an object from A to B. Okay. Okay, if the potential energy at A, so potential energy at A is given as 30, then find the potential energy at B. UB, you guys are supposed to find out. Guys, if the work done by conservative force is equal to negative of change in potential energy, final minus initial. This is how we write now. So work done is given as minus 30 is equal to, this is minus. Final potential energy you have to calculate. Minus initial potential energy is 30. This is 30. So this is minus 30 is equal to minus UB, minus into minus is plus 30. Take it over there. Take it over there, take it over here. So UB will come out to be 30 plus 30. That will be 60 joules. Ho 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 ho. I hope this is crystalline clear. Okay. Now guys, take a look at this. If potential energy is given in terms of X, Y, and Z, then do the partial differentiation also. Guys, see. Let me directly show you the question over here. Okay, let me directly show you the question over here. See? Guys. In this particular case, potential energy was given in terms of X only. You had to calculate the force. So you directly differentiated with respect to X. But if, let's suppose, potential energy is given in terms of X, Y, and Z. Okay, this is given in terms of X only. Huh? So where is that question? So here it is simple, bro. Okay. Wait. Let me just show you that question first. See, let's suppose if the potential energy is given as that is 4x square y plus yz plus z square x. Okay, z square x. Okay, here put y square z. Now, this is the potential energy given. Here, potential energy is given in terms of x, y, as well as z. In this particular case, you need to do the partial differentiation. Okay, to find force. Guys, see, listen carefully. First, you will be finding the force, x component of force. Listen to me very carefully. Guys, if it was given in terms of x only, you would have done du by dx. But in this particular case, it is given in terms of x, y, as well as z. So we'll be doing partial differentiation, fx. So fx will be simply minus dou u divided by dou x. So this means differentiation of potential energy with respect to x, partial differentiation. So where y comma z will be considered as constants. Let me show you. This will give the x component. Listen carefully. Now, do the differentiation of this. Take the negative out. Do the differentiation of this with respect to x. Rest will be considered as constants. Guys, see. Here, 4y will be considered as constant. 4y will be considered as constant. What is the differentiation of x square? That is 2x. Okay. Then plus y is constant, z is constant. Because when you are partially differentiating, when are you supposed to do this? When you have given potential energy in terms of x, y, and z. When you are partially differentiating with respect to x, y, and z is constant. So differentiation of this will be 0. And differentiation of this with respect to x, take this z square out.
differentiation of x will be 1. Okay. So what did you get over here? Fx will come out to be, x component of the force will come out to be, that is minus 2 into 4 is 8xy plus z square. This came out to be the force, Fx. Now, if you differentiate this with respect to y, find y component of the force. You'll be simply saying minus dou u divided by dou y. In this particular case, x comma z will be considered as constant. Now differentiate with respect to y. This term you need to differentiate with respect to y. So take this negative out. Now differentiation of this with respect to y. Guys, if you are differentiating with respect to y, take rest of the terms out. So 4x square is out. Differentiation of y is 1. Then here, take z out. Differentiation of y square is 2y. In this case, z is constant, this is constant, so differentiation of both will be 0. So here it will come out to be minus 4x square plus 2zy. Okay, 2zy. And then, my dear NEET aspirants, if I say fz, so this will be dou u divided by dou z. It will be minus dou u by dou z means differentiation of this, my dear NEET aspirants, with respect to z. Here x comma y will be considered as constant. Please do remember this, in which you have x, y and z, how you are supposed to differentiate. So with respect to z, you are differentiating, this term will become 0. It's because 4 is constant, x is constant, y is constant. Here you need to take y square out, differentiation of z is 1. Here you need to take x out, differentiation of z is 2z. So what are you going to get in this one? Minus y square plus 2zx. Now, once you get the value of fx, fy and fz, then you can write this force will be simply, that is fx into I cap plus fy into j cap plus fz into k cap. Fz into k cap. You can find the force something like this. Even you can write it like this. F is equal to, guys, see, fx is minus dou u by dou x. Keep negative out. Dou u by dou x. Dou x. Dou means partial differentiation. Means rest of the terms are constant. Into I cap. Plus dou u divided by dou y j cap. Plus dou u divided by dou z k cap. You can write it like this. Now tell me what is going to be the force in this particular case. Take negative out, because negative is common in all the three. Here, here and here. What is the f value of fx? 8xy plus z square. We'll be writing over here 8xy plus z square. And you'll be mentioning I cap over here with it. Okay. Then plus. Okay, then plus. What is the value of fy? 4x square plus 2zy. 4x square plus 2zy. J cap. Then plus. What is the value of fz? Y square plus 2zx. Y square plus 2zx. And it is k cap. And it is k cap. Just a second. And it is k cap. This is the force. Now, my dear NEET aspirants, in this particular case, if somebody says you need to find force at, now, find force at 1, 1, 1. Let me show you. Force will be negative. Put the value of 1 here, 1 here, 1 here. 1, 1, 1 means put x is 1, y is 1, z is 1. So this will be 8 into 1 plus 1 square. Here into I cap. Then plus 4 into
1 plus 2 into 1 into 1, j cap, then plus. Here, 1 square plus 2 into 1 into 1 into k cap. I have gone up to J mains level. peak J mains level. Now guys, so this force will come out to be minus 8 plus 1 is 9 I cap plus 4 plus 2 is 6 J cap plus 1 plus 2 is 3 K cap. This came out to be the force. Even you can find the magnitude of the force also. Under root of 9 square, 6 square, 3 square. Please tell me in the chats if this is clear. Oh, are you able to understand these things, sir? Or I am just wasting my time, not yours. My time. My time is important. Okay. Sir, why taking x and y as constant? Because in partial differentiation, we have to take x and y as constant when you differentiate with respect to x. Then you take y and z as constant because this is the rule. Okay. Okay. Guys, now you have certain, okay, spring potential energy, conservation of energy. Now guys, let's take a break, huh? Dinner break. Break is till 9:10 p.m. Okay, we'll have to finish these chapters. Please stay, huh? So break is till 9:10 p.m. See you guys after the break. Okay, guys, let's dive into the session once again. Okay. Okay. This is the question. This question is your homework. Okay. I'm just gonna give you the hint in this particular case. Potential energy of a particle is given over here. Okay. So potential energy is given as ax minus bx square. Okay. You have to find the equilibrium position. What is equilibrium position? Equilibrium position is that position where net force on the object is zero. Where net force on the object is zero. So my dear NEET aspirants, if this is the position, okay, if this is the potential energy, so we can say from this potential energy you can find force minus du divided by dx. So that's the differentiation. Keep minus out. That is differentiation of ax is a minus 2bx. Okay. Now this is the force. Now we say at equilibrium position, at equilibrium position, listen carefully, guys. The potential energy of an object moving along x-axis is this. You have to find the equilibrium position of the particle. Equilibrium position will be where net force on the particle is zero. At equilibrium position, we say net force on the particle is zero. So put the value of force is equal to zero. So this is 0 is equal to minus a plus 2bx. Take it over here. So a will be equals to 2bx. So x will be equals to a divided by 2b. This will be the equilibrium position of the particle. Potential energy with respect to the reference line. Guys, see. Always remember, as I recently told you, let's suppose if this is the reference line. This is the reference line. Okay, this is the reference line. Always consider the potential energy on the reference line as zero. U reference. Okay. Let's suppose if you take an object to the height h. This is mass m, height is h. We say here potential energy is going to be that is mg into h. Okay. And if you take an object below the reference line at a height of h, consider potential energy minus mg into h. Simple. Simple. Above the reference line plus mgh. Below the reference line minus mgh. Right, guys? Let's suppose this is the rod placed something like this, the rod placed something like this. So we consider its mass at center of mass. Right now, I'll have to teach you the center of mass separately. Okay. So my dear NEET aspirants will be considering the mass of this rod at this point L by 2. L by 2. So what will be the potential energy of this rod? That will be mg into h. Instead of h, we'll be writing L by 2. What will be the potential energy of this? This will be mg into L divided by 2 here. Okay, and it is minus mgl by 2. Minus mgl by 2. Okay. Yes. Similarly, guys, if a chain is present over here, if a chain is present over here, my dear NEET aspirants, okay, if a chain is present over here, okay. Now, my dear NEET aspirants, half of the chain is present on this. And this will be considering as reference line. So, potential energy of this portion is going to be 0. Now, this is the half of the chain. Its length is L by 2. Okay.
and it is below the reference line, if the entire length of the chain is given as L divided by 2, can I say the center of mass will be at L by 2 upon 2? That will be L by 4. And if the mass of the entire chain is M, what will be the mass of this portion? That will be M by 2. Guys, this is the chain. This portion of the chain is present on the reference line. Its potential energy is 0. But we have to find the potential energy of the hanging portion. Potential energy of hanging portion. Potential energy of hanging portion. So my dear NEET aspirants, we say potential energy of this hanging portion will be U is equal to minus. Instead of M, I can write M divided by 2. G is G and L divided by 4. Because we have to consider the mass of this at center of mass, that is L by 4. So 2 into 4 is 8. So it is going to be minus mg L divided by 8. This will be the potential energy of this. Let's take a look at spring potential energy. Spring potential energy. See, my dear NEET aspirants, what does spring potential energy mean? Let's suppose there is a spring over here. Okay. And you are connecting a block to the spring. Okay. You are connecting a block to the spring. And now in this particular case, my dear NEET aspirants, you are elongating this block. You are elongating this block. You are elongating this block. So when you elongate this block, you apply the external force and you displace it by X. We know that, sir, here restoring force will be created, that is spring force. So in this particular case, what I want you guys to understand is, we say on elongating the spring, work is to be done. Okay. And that work done will be stored in the form of potential energy. That work done will be stored in the form of potential energy of the spring. Like when you lifted the block from surface to height edge, you did the work done. That work done was stored in the form of potential energy. Same is the case over here. If you elongate this spring, you have to do the work done. That will be stored as potential energy of the spring. So here how much it was? mgh. In this particular case, we say potential energy will be stored as, that is 1 by 2 kx square. This will be the potential energy stored in this case. K is the spring constant and x is the distance that you are displacing this. Okay. X is the distance that you are displacing this in this particular case. 1 by 2 kx square. Now, my dear NEET aspirants, we can also write it like this. We say as F is equal to K times of X. So can I say X will be F divided by K? Absolutely. Now put it over here. So U will come out to be 1 divided by 2K. Instead of X, you will be putting F square divided by K square. F square divided by K square. Now K and square will be cancelled. U will come out to be F square divided by 2K. Okay. F square divided by 2K. F square divided by 2K. Now, my dear NEET aspirants, listen to me very carefully. If in a question, we say if X is given as constant, in that case, potential energy is directly proportional to K. Okay. And if force is given as constant, okay, spring force is given as constant. So we say in that particular case, U is inversely proportional to K. Okay, U is inversely proportional to K. So my dear NEET aspirants, let's suppose you have two springs. In two springs, displacement of the elongation in the spring is same.
we say U will be directly proportional to K. Okay. Okay. Like you have a question. If the potential energy of a long spring when stretched by 2 centimeters is U, there is a spring. There is a spring. Okay. When X is 2, let's call it X1 is 2, potential energy U1 is U. If the spring is stretched by 8 centimeters, if the same string X2 is 8 centimeters, what will be the new potential energy it is asking over here in this particular case? What will be the new potential energy? Now, my dear NEET aspirants, in this particular case, listen carefully. We say U is equal to 1 by 2 kx square. If it is talking about the same spring, initially this is the spring, finally the same spring. So can I not say this k will be same? If it is talking about the same, initially the spring was elongated by 2. Finally it is elongated by 8. So we can say U is proportional to x square. Absolutely, sir. So U1 divided by U2 will come out to be x1 divided by x2 whole square. U1 is U, U2 is U2 is equal to x1 by x2. x1 in this case is 2, x2 in this case is 8, its whole square. 2 1s are 2 4s are 8. 4 4s are 16. U divided by U2 will come out to be 1 divided by 16. Multiply here. So U2 will come out to be 16U. U2 will come out to be 16U. Okay. So this is the question of NEET 2023. Force constant K1 and K2 of two springs are in the ratio of 5:4. There are two springs, their force constant is given as 5:4. This is the spring 1 and this is the spring 2. They are stretched by same length. X is constant. Both are stretched by same length. If the potential energy of one spring is 25 joules, then the potential energy in the second spring will be. So U2 in this case it is asking. Now guys, tell me, if X is constant, in that particular case, what we are going to say? Guys, if X is constant, potential energy is directly proportional to K. This is what we recently studied. So we say, if X is constant, we say potential energy is directly proportional to K. So can I say U1 divided by U2 will come out to be K1 divided by K2. So U1 is given as 25. U2 we have to find out. K1 by K2 is given as 5 divided by 4. 5 1s are 5 5s are. 5 into 4 is 20. So U2 will come out to be 20 joules. Is this clear? Oh? Tell me quickly in the chats if this is crystal and clear. Tell me, guys. Smash the like button if you have not liked the session yet. Conservation of mechanical energy. Guys, see. Conservation of mechanical energy simply says total energy initially, that is EI, will be equals to total energy finally. And when I write total energy initially, it means kinetic energy initially plus potential energy initially. It will be equals to kinetic energy finally plus, I would say, potential energy finally. Kinetic energy initially plus potential initially is equal to kinetic energy finally plus potential energy finally. Guys, a simple and common example we take over here. Let's suppose you release an object from certain height. At topmost point, we say potential energy is mg into h, that is maximum. When it is at rest, and kinetic energy is 0. And we say when it falls, when it strikes, here potential energy on the reference line is 0, but kinetic energy is maximum. Okay, that is 1 by 2 mv square. So my dear NEET aspirants, in this particular case, we said total energy is conserved. Here energy is with what? Potential. Here potential energy has all of the energy. But when it strikes the ground, that energy is converted to kinetic. But whatever is total energy finally, Same is total energy initially. Okay. Take a look in this particular case. A particle is released from height s. There is a particle. It is released from height s. At certain height, its kinetic energy is 3 times of its potential energy. Let's suppose at certain height h, its kinetic energy is 3 times of potential energy. This is finally at this height. So at this point, potential energy is, sir, this potential energy is this. Okay. Then it says the height from the Earth's surface and the speed of the particle at that instant. We have to find what is this height and what is the speed at this instant. First, let's find height. Use conservation of mechanical energy. Use COME. If an object is released from certain height s, at certain height, its kinetic energy is 3 times of potential energy. What does it say? Sir, it says kinetic energy initially plus potential energy initially will be equals to kinetic energy finally plus we say potential energy finally. What is kinetic energy initially? Initially, this is initial. Initially, it is released from this, and this is finally. Kinetic energy initially is 0 because it is released. Whenever an object is released, initial velocity is 0. Okay. So potential energy initially, I'll just write over here something like this, is equal to kinetic energy finally. Finally, kinetic energy is 3 times of potential energy plus this potential energy. So potential energy initially at topmost point, what is the potential energy, sir? mg into s. Height is s. mg into s is equal to. Now at this particular instant, how much is potential energy? mgh. And 3 potential energy plus potential energy, 4 potential energy. 4 times of mg into h. mmgg. H will be equals to s by 4. This is what you were supposed to calculate. S will be equals to h by 4. Now let's find the speed at this instant. Guys, see. Let's find V. Since you say kinetic energy at this instant is 3 times of potential energy. So kinetic energy is 1 by 2 mv square is equal to. So 3 times of potential energy. Potential energy at this point is mg into h. mg into h. H you recently got s by 4. So 1 divided by 2. M and m will cancel. So this is v square is equal to 3g. Instead of h, you'll be writing h divided by 4. So 2 1s are 2 2s are 4. Take this over here. V will be under root of 3 divided by 2 g into h. This is the velocity. Is this clear? Tell me. Is this clear? Tell me, oh. Is this clear? Okay, power. This is the last portion of this chapter, that is power. It is defined as rate of doing work. See, a person is doing work very quickly. He has a lot of power. With what rate a machine is doing work? If the machine is performing work in a less amount of time, we say power is more. It is defined as rate of doing work. If we have 2 cars, okay, with less horsepower and more horsepower, what does it mean? It means one is capable of doing more work as compared to other in the same time. You have 2 cars. One is less horsepower, another is more horsepower. What does it mean? One is capable of doing work, more work in less time. Another is capable of doing less work. That is more power. So power is the rate at which work is being done. With what rate work is being done? Sir, I am taking the block from this point to this point in 2 seconds. Another person is taking the block from, I am taking the block from this point to this point in 2 seconds. Another person is taking the block from this point to this point in 10 seconds. So power mine is more, his power is less. So I'm doing work quickly, he is taking work, he's doing work and taking time. Okay. So power we can write simply over here, that is delta W divided by delta T. This is what we call rate of work with respect to time. Okay. And this is average power. Even we know, sir, work done is equal to change in kinetic energy from work energy theorem. So you can say this average power, we can write it like this also, delta KE divided by delta T. Okay. Now, if I say instantaneous work, instantaneous power, guys, power at particular instant, instantaneous power. Okay. We say, sir, power instantaneous will be simply, that is dW divided by dt. Okay. Work done at a particular instant. Sir, work done from this time to this time, large power, average power. Okay. From this point to this point, from this time to this time, if you are doing work done, so means you are applying average power. At a particular instant, instantaneous power. So you can say instantaneous power will be simply dW means, instead of dW, you can say small change in kinetic energy upon dt. Because work done is also change in kinetic energy. Work done is also change in kinetic energy. Is this clear? So it is the work done at a particular instant. It is the work done at a particular instant. Okay. Now, one more important thing I just want to say over here, guys. When you say power, it is dW divided by dt. Okay. So you can say power something like this also. Work done is force into displacement, FDS, then we say cos theta. Okay. Upon, I would say dt. FDS cos theta upon we say dt. Okay. Now, my dear NEET aspirants, can I not write it like this? This power will be simply FDS means F dot ds. Okay. Upon, I would say dt. Now, what is ds by dt? That is velocity. So, power will come out to be F dot b. Power will also come out to be F dot b. So, dot product of force and velocity gives you power. Even you can write it like this, power is equal to F dot V means FV cos theta. FV cos theta. FV cos theta. Okay. Now take a look. If you have work time graph, slope of work time graph, what does slope here mean? Slope means dW divided by dt. And what is dW by dt? That is power. Okay, so slope of work time graph is going to give you power. From now onwards, if power versus time graph is given, slope work versus time graph is given, they ask you to find the power, you'll find slope. Now, what is area over here? Area is integration of, that is P, and then we say dt. Now, my dear NEET aspirants, listen to me very carefully. As when it comes to power, that is dW divided by dt. Take it over here. We say dW is equal to P dt.
Now integrate both sides. Integration of dw will be total work done. It will be integration of p dt. So if you have power, you are supposed to find work done, you will be doing integration. Now this is equation first and this is equation second. Don't you think in this particular case, I can say from equation first and I would say equation second. So I can say area will give you the work done. Okay. Area of which graph? Area of power versus time graph is going to give you the work done. Okay. For a variable mass system, for a system with varying mass, like rocket propulsion, guys, we say force is V dm by dt. I recently told you this. Okay. For variable mass system, when you can write it like this, when mass is variable. So when mass is variable, in that case, this is the force acting. Now tell me, what is power? Power is Fv cos theta. Okay. Now you can say power is, instead of F, you can write V dm divided by dt into V, then you can say cos theta. So in that particular case, V into V becomes V square. Then we say dm divided by dt and then we say cos of theta. You can keep this in a box also. Okay. So this is the power for variable mass system. If mass is decreasing or changing, then this will be the power. Now NEET 2023 question. A particle moves with a velocity of, there is a particle, it has a velocity of 5i cap minus 3j cap plus 6k cap. Horizontally, under the action of a force, force is acting on the particle, that is 10i cap plus 10j cap plus 10j cap plus 20k cap. Okay. The instantaneous power supplied to the particle is, so power is simply, that is F vector dot V vector, F dot V. So you can say, sir, this power is F dot V. Sir, dot product of force and velocity. How do you do the dot product? Which one you want me to repeat? Which one you want me to repeat? Oh, which one? This one. This one, this one, this one. Oh, which one? This one. It is simple. It is simple. See. If an object is there, okay, its mass is constant. Its mass is constant. You are applying force on this object. It has some velocity. If I say how much is the power supplied to the particle? How much is the power supplied to the particle due to this force, because it has velocity v? So you simply say, sir, that is Fv cos theta. Okay. But if the system is there, like guys, see, this is a rocket. This is a rocket. We say its mass is variable. Okay. And we know in this particular case, guys, please listen. When the fuel inside the rocket burns, we say it sends the gas out. Exhaust gases come out of the rocket. And in return, exhaust gases push the rocket up. We say upthrust is created. Upthrust. Okay. And if upthrust is created, in this particular case, my dear NEET aspirants, what is the value of that upthrust? V dm divided by dt. So means due to this gas, upthrust is being created in the rocket. So power is being supplied to the rocket. And how much is the value of power in this particular case? You will say, sir, Fv cos theta. And here power is equal to power due to this upthrust. So power due to this upthrust will be V dm by dt. Okay. And then we say this V, and then we say cos of theta. So this power will be V into V is V square. And then we say dm divided by dt into cos of theta. Now please tell me if this is clear. Now tell me, is this clear? Oh, give me the signal now. Okay. So this is the upthrust. Due to this upthrust, it goes up. So how much power is being supplied to this rocket due to the upthrust? This one. So that's what we say varying variable mass system. Now power is F dot V, dot product of force and velocity. Now see, here it is 10, here is 5. How do you do the dot product? Coefficient of I, multiply the two, multiply the two, multiply the two. 10 into 5 is 50, minus 3 into 10 is 30, plus 6 into 20 is 120. 120 plus 50 is 170. 170 minus 30 is 140. 140. Watt. Unit of power is watt. Okay. This is your homework. Okay. And some more questions I have put up over here. This is your homework. It is simple. It is simple. You can check the answer from the slide itself. Okay. And this is also your homework. Question from power. I have mentioned the answer in this particular cases. Next chapter, we have center of mass. Every single thing I have told you in work, power, and energy. Okay. Center of mass. Now, guys, this is the next chapter. And this is chapter 6. Center of mass and collisions. Okay. Shall we start? Shall we start? Okay, guys. Okay.
Okay, let's dive into the session, guys. Now, guys, the simple definition of center of mass is, okay, if you have an object, you want to hold this object at one point. Where would it be? Sir, at center. At center, somewhere around over here. Sir, will it be here? No. Will it be here? No. Will it be here? No. At center, somewhere around over here. So you want to hold this object at one point. This one. This point, where you can hold this, where you can assume the entire mass of the body, this is what we call the center of mass. If you want to hold the body only at one point, it would be center of mass. That point where whole mass of the body can be assumed. Okay, let's suppose if I say I have a rod over here. I'm saying assume the mass of the rod only at one point, because sometimes we may need it. Like in this particular question. In this particular question, I have recently shown you. While you were calculating the potential energy of the rod, I asked you to assume the mass of this rod at L by 2, because mass is present from this point to this point. Where do you have to assume it? You have to assume it at center of mass. This is where center of mass concept comes into play. If you have to assume the mass of a body at one point, where would it be? It would be center of mass. So here it is center of mass. Okay, yes. Now guys, center of mass can be outside or inside the body also. Okay, outside or inside the body. Center of mass lies to the heavier object, near to the heavier object, lies near to the heavier object. Like this is a ring, my dear NEET aspirants. We say center of mass will be over here. Okay, at the center. Now these are the two masses, my dear NEET aspirants. We say center of mass of these two masses will be here. See, these are outside of the two masses, not inside. This is the body over here. Center of mass will be here, towards heavier side, Okay. And this is over here a sheet. Center of mass will be at the center. So in these cases, you say center of mass is inside. In this case, center of mass is outside. And if this is 2m, this is m. Center of mass will shift towards heavier mass. Okay. Location of center of mass. See, my dear NEET aspirants, let's suppose if I say I have a mass m1 over here, its coordinates are x1, y1, z1. I have another mass m2 over here, its coordinates are x2, y2, z2. Okay, these are the coordinates. Coordinates means where the object exactly is. Sir, how much is in the x-axis? How much is it in the y-axis? How much is it is in the z-axis? These are the coordinates of center of mass. If somebody asks you, could you please tell me what are the coordinates of center of mass? These are the coordinates of these two masses. And. Guys, R1 and R2 are the position vectors of M1 and M2. This is M1, this is M2. This is the position vector R1. So position vector means how far it is from the origin. This is the position vector. This is the position vector over here. R1, R2. And how can you write this position vectors? Guys, x1 I cap plus y1 j cap plus z1 k cap. Position vector this. x2 I cap, y2 j cap, z2 k cap. Like, my dear NEET aspirants, listen to me very carefully. If I say
you have an object over here. Its coordinates are 2, 3, comma 4. What does it actually mean? It means this is x coordinate, this is y coordinate, this is z coordinate. It means, guys, this is x axis. Okay. See. So these coordinates basically give you the location of an object. These coordinates give you the location of an object. See, it is like this. This is x axis, this is y axis, this is z axis. If I say these are the coordinates, you have to find this. In x axis, you have to move 2. In y axis, you have to go up 3. In z axis, you have to come out as 4. Here is the particle. Now, if you have to draw its position vector, sir, its position vector would be something like this. This is r. And this position vector r, you can simply say that is 2i cap plus 3j cap plus 4k cap. So when you look at this position vector of this particle, okay, so you saw 2 here, this is the x coordinate. When you look at this, this means x coordinate. This means y coordinate. This means z coordinate. This is how you can draw the position vector. So position vector, you always say with respect to the origin, what is the position of this particle? Okay, with respect to the origin. Now guys, if I say, what could be the position vector of this particle? x1i cap plus y1j cap plus z1k cap. For this, x2i cap, y2j cap, z2k cap. Now let's suppose this is the center of mass. This is the center of mass. So this is the position vector of center of mass, that is RCOM. So this is its position with respect to the center. That is what we call position vector. Position with respect to the center. So now if somebody says, what will be this RCOM? You simply say M1 R1. Okay, M1 R1. So that is mass of first, position vector of first, plus M2 R2. Mass of second, position vector of second, upon, I would say M1 plus M2. This will be the position vector of center of mass. I hope this is crystalline clear. I hope this is crystalline clear. And if somebody says, what is the value of R1 and R2, my dear NEET aspirants? What is the value of R1 and R2? I'll write over here. R1 position vector will be x1i cap plus y1j cap plus z1k cap. And R2 position vector will be, okay, that is x2i cap plus y2j cap plus z2k cap. Z2k cap. Okay. Now, coordinates of center of mass. This is the position vector. With respect to the origin, what is the position of center of mass? This one. Now, if I say x coordinate, guys, x coordinate of this is x1, x coordinate of this is x2. So, x coordinate of center of mass, it will be simply m1x1 plus m2x2 upon m1 plus m2. This is how you can find its x coordinate. If I say what is going to be the y coordinate of center of mass, you simply say m1y1 plus m2y2 upon, you can say m1 plus m2. Okay. Then if I say z coordinate, it is going to be m1z1 plus m2z2 upon, you can say m1 plus m2. This is going to be the z coordinate of center of mass. Is this clear?
Okay. Now guys, so center of mass divides the system in two equal moment of masses. Guys, see. This is the center of mass. This is M1, this is M2, this is the center of mass. So from here to here distance is x1. From here to here distance is x2. If you multiply M1 and x1, if you multiply M1 and x1, if you multiply M2 and x2, if you multiply M1 and x1, if you multiply M2 and x2, we say it will be equal. So we say this is what we call moment of mass. M1 x1 is considered as moment of mass. M2 x2 will be considered as moment of mass. So this, and we say this, and we say this. M1 x1, this moment of mass will be equals to M2 x2, this moment of mass. This moment of mass. Okay. Next, my dear NEET aspirants, take a look over here. Take a look over here. Two particles of masses 5 kg and 10 kg are respectively attached to two ends of a ridged rod. This is the question from NEET 2020. Now guys see. You have two particles. One particle has mass 5 kg. Okay. Another particle has mass 10 kg. Okay. Yes. Are attached to two ends of a ridged rod of length 1 meter. 1 meter is the length of this rod. Okay. With negligible mass. Mass of the rod is negligible. It is not. It is 0. You can consider it. The center of the mass of the system from 5 kg is nearly at a distance of. You have to find distance of center of mass from 5 kg. Guys, see. If you have to find the center of mass from 5 kg, then consider this at origin. 0, 0. Consider this at origin. Okay, origin. Okay. And if this is at origin, this is 1 meter distance, what will be its coordinates? 1, 0. And the rod is present on the x-axis. So guys, if the two masses are present on x-axis, so their center of mass will be also at x-axis. So which one? In order to find the position of center of mass, my dear NEET aspirants, don't you think I'll prefer to use this particular coordinate? I'll find its x coordinate, because the two masses lie on x-axis. Their center of mass will be also on the x-axis. So it is better to use XCOM directly. It is better to use XCOM. Okay. So we'll be saying, sir, x coordinate of center of mass will be, that is M1 x1 plus I would say M2 x2 upon I would say M1 plus M2. Okay. So then XCOM in this particular case, this is M1 x1. What is the value of M1? That is 5. And what is the value of x1? X1 in this particular case is 0. So mass of first, x coordinate of first, because if this is at origin, its coordinates will be 0. Then plus mass of second, that is 10. And coordinates of this, of x coordinate of this is 1. Then M1 plus M2, my dear NEET aspirants. M1 plus M2, that is 5 plus 10, that will be 15. So XCOM, my dear NEET aspirants, what you can write over here? This will be 0, 10 divided by 15 in this particular case. Okay. So 5 3s are, 5 2s are, that is 2 divided by 3. Okay. I hope this is crystal and clear. Guys, tell me quickly in the chats. Is this crystal and clear? So if they ask you to find from the 5 kg, okay. Now, take a look. Take a look in this question. So find the position of center of mass. This is a square. You have 4 masses. 2 kg is here. 4 kg is here. 16 kg is here. And this is here.
Now, in this case, masses are not present only at x distance, only in x coordinate, in on x axis. They are placed x, y in this particular case. Guys, see, let's first write the position vector of this R1. It is 0. Okay. If I write the position vector of this, that is R2. Okay. What is the position vector of this? This is, since this is 4 kg. Position vector of this, my dear NEET aspirants, I can write, guys, what's its x coordinate? That is 10. What is y? That is 0. Because it is placed on x axis only, no y coordinate. So it will be 10 I cap. Then I say position vector of third one. This is the third mass. Its position vector, my dear NEET aspirants, will be, listen to me very carefully. Sir, its x coordinate is 0, y coordinate is 10 because it is present on y axis. It is 10 j cap. And if I say R4, guys, it has x coordinate also, y coordinate also. So it will be 10 I cap plus 10 j cap. If I say RCOM, position of center of mass, that will be M1 R1. It is vector plus M2 R2 plus M3 R3 plus M4 R4. Okay. Then, my dear NEET aspirants, we say M1 plus I would say M2 plus I would say M3 plus I would say M4. Then we say RCOM. M1 R1. What is the value of M1? That is 2. R1 is 0 plus M2 R2. What is the value of M2? That is 4. And what is the value of R2? That is 10 I cap. R2 is 10 I cap. Then we say plus M3. What is the value of M3? That is 8. And what is the value of R3? That is 10 J cap. Okay, then plus. What is the value of M4? That is 16. And what is the value of R4? This is 10 I cap plus 10 J cap. Then we say M1 is 2, M2 is 4, M3 is 8, M4 is 16. Now, guys, it is just the matter of calculation. You just have to solve it now. 40 I cap, 80 J cap, 160 I cap. Okay, 160 J cap. Now, this is the calculation only. Now, this is the question which I'll give you as homework. Please do it from your end. Its answer is mentioned. You can check it later, its answer. This is the question. Its answer is mentioned. Okay, you can check its answer later. First, try it from your end. Then first try to solve, then see the answer. This is also the question homework. Do it from your end. Okay. Now shift in the center of mass. Now give me the signal in the chats first. Please tell me if this is crystalline clear. Tell me, guys, if this is crystal and clear. Guys, smash the like button if you have not liked the session yet. Everybody smash the like button.
Yes, successfully 12 hours completed, huh? Hmm? Way more to go. Keep going, keep going. Sir, मैं आओ 7th मज मैथ वापस बी क्या कर आता कि बिजबी दिन भी क्या कर Now, guys, shift in the center of mass. What does shift in the center of mass actually mean? Shift in the center of mass means, see, let's suppose, see guys, I'll make you understand this. Let's suppose you have M1. Let's suppose you have M2. Okay. And this is the center of mass of the two. This is the center of mass of the two. You have M1, you have M2, and this is the center of mass of the two. If I say you shift M1 and M2 from these two positions, shift. I'm shifting. Is the center of mass there only, or it is also shifting? Sir, it is also shifting. So if you take M1 and M2 here, center of mass is also shifting. So that's what I am saying. If the masses shift, if M1 and M2 shifts from their position, center of mass will also shift. We say if M1 and M2 shifts, then COM also shifts. Then COM also shifts. Okay. Now, my dear NEET aspirants, I can say what will be the shift in the center of mass. I can say what will be the shift in the center of mass. Shift in the center of mass is this, delta R. Delta R means shift in the center of mass. It will be simply M1 delta R1. M1 delta R1, then plus M2 delta R2 upon M1 plus M2. So this is the shift in the mass, shift in the mass 1, this is the shift in the mass 2, and this will be in this particular case what? This will be in this particular case what? Shift in the center of mass. This is shift in center of mass. Okay. Now, center of mass of continuous bodies. Okay. Now, my dear NEET aspirants, how do you find the center of mass of continuous bodies? Like, see, if you have different masses, I told you how can you calculate the center of mass of different bodies. But if you have a continuous mass system like this disk, mass is distributed, like this mass is distributed, like this mass is distributed, like this mass is distributed, how can you find the center of mass in these particular cases over here? See guys, let's suppose you have a body. You need to calculate its center of mass. These are not the different bodies. You say M1, R1, M2, R2. This is just one body. This is just one body. You have to find its center of mass. Do one thing. We say in this particular case, break this body into small, infinitely small masses. This one, this another DM, this another DM, okay? And then find their position vector. Then if you have to find the center of mass, guys, see. If you have to find the center of mass, how will you find the center of mass? Guys, see, center of mass of this body, you'll be simply saying, sir,
Mass of this into position vector of this. This is R, this is R. You say, sir, mass of first one, M1, R1 plus M2, R2 plus M3, R3 and so on and so on up to infinity. Divided by, I would say dm plus dm plus dm and so on. So this RCOM, position of center of mass, will be integration of, guys, if you have to add infinite quantities, okay, so you'll be simply putting the integration. So integration of dm into r upon integration of dm. This will be the position of center of mass of continuous body. So what is the logic? If you have to find the center of mass of continuous body means in which mass is distributed. Mass is not discrete. So in that case, you take a small mass, find its position. Another small mass, find its position. So basically, you are breaking the small masses into infinite number of masses. Then add that and you get the position of center of mass. Even you can find x coordinate of center of mass in this case also. That is integration of dm into, here I would say x, upon integration of dm. Even you can find y coordinate of center of mass also. That will be simply integration of dm into y upon integration of dm. Even you can find z coordinate of center of mass also, integration of dm into z upon integration of dm. This is z coordinate, this is y coordinate, and this one is x coordinate. This center of mass of continuous body. This is the way how we can find the center of mass of continuous body. Now guys, center of mass of an arc. If let's suppose this is an arc. So directly remember its center of mass will be simply this. Okay. This YCOM. YCOM means if this is the origin, this will be y-axis and this will be x-axis. So its center of mass will be on y-axis, maybe somewhere around over here. And what is the y coordinate of center? Sir, x coordinate will be 0 because center of mass is not present on x-axis. Like guys, see. If I say, sir, this point has how much x coordinate? 0. Because it is purely on y. If I say this has how much y coordinate? 0. Because this is purely on x. If I say this point, it has x coordinate also, y coordinate also. Now, if see, this is y-axis, this is x-axis. If I say this is y coordinate of center of mass, what this is, if I say this is center of mass, what will be its x coordinate? 0. Why? Because it is purely on y-axis. So center of mass of this directly. Sir, how did you get this expression? Because of this. Because of this. This after derivation. So y coordinate of center of mass here will be r sine of theta by 2. See, this is an arc. This is complete circle. If you break this circle into two parts, this becomes semicircle. This is semicircle. And if you take some portion of the circle, some part of this ring, this becomes an arc. This is radius r, this is radius r, this is angle theta. That is over here. Now, if I say, what is the YCOM? R sine of theta by 2 upon theta by 2. Now guys, if this is a semicircular ring, in case of a semicircular ring, this is the center, this is R and this is R. This will be x-axis, this will be y-axis. Its center of mass will be also on y coordinate, y-axis. X coordinate of the center of mass is 0 because it is on y-axis. So what is the formula? Formula will be this only. R sine theta by 2 upon theta by 2. So this will be R sine of theta by 2 upon, we say, theta by 2. So YCOM will be R. R is R sine of theta by 2. Theta is 180. So sine of 180 by 2 is 90 divided by, okay, divided by, and guys, write it like this, R sine of, instead of 180, write pi, because pi is also 180, pi radians. So R sine of pi by 2 upon pi by 2. Okay, sine 90 is, sine pi by 2 is 1. So this will be R upon pi divided by 2
Take it, so 2r divided by pi. This is the y coordinate of center of mass. Okay. Okay. 2r by pi. And what is the x coordinate? X coordinate is 0 in this case. Let's talk about complete circle, guys. Okay. In case of complete circle, it will be exactly center of mass will be at center. That is x coordinate 0, y coordinate 0. Because this is y axis, this is x axis. This is 0, x is 0, y is 0. Even you can find it also. Y coordinate will be r sine of theta by 2 upon theta by 2. Theta is 360 or 2 pi. Put here 360. 2 pi divided by 2. 2 and 2 will cancel. Sine pi, sine 180 is 0. So this term will become 0. So 0. Y coordinate 0, x coordinate 0. That means exactly at the center. So in this case, it will not be here at the origin. It will be somewhere around over here on y-axis. But x coordinate will be 0. Guys, tell me, is this clear? Is this clear? Tell me. Quick. Okay. Center of mass of uniform semi-disk. Center of mass of uniform semi-disk. Okay. Now, guys, this is a disk over here. This is a disk over here. Okay. And its mass is m and its radius is r. This is y-axis and this is x-axis. If I say where is its center of mass, x coordinate is 0. First, you remember, it will be on y-axis only. At y-axis, what will be the y coordinate? 4r by 3 pi, where r is the radius. Where r is the radius. Directly remember these guys. Okay. Center of mass of a hollow hemisphere. Hollow hemisphere. Hemisphere is this. Hollow hemisphere. Hollow hemisphere means cap. Its center of mass is also on y-axis. At what distance? R by 2. Y coordinate is r by 2, x coordinate is 0. Center of mass of a solid hemisphere. Solid hemisphere means which is filled from inner side. It is not hollow. Hollow means cap. Solid means which is filled from inner side. You cannot wear solid. X coordinate is 0. Y coordinate is 3r by 8. At on y-axis, 3r by 8. Okay. Center of mass of hollow cone. Hollow cone. Okay. This hollow cone. Its mass is m, this radius is r, and this height is h. So its x coordinate is 0. Its center of mass also lies on y-axis. So that is h by 3, where h is the height of the cone. Center of mass of a solid cone. Solid cone means which is filled from inner side. Okay. Okay. So here also center of mass will be on y-axis. So it is h by 4. In hollow, it is h by 3. Here it is h by 4. X coordinate is 0. Okay, 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 okay. Okay, let's first talk about this one. Wait, this one. Okay, see guys, linear mass density. What does linear mass density actually mean? What does linear mass density actually mean? Or tell me guys in the chats if this is clear. Tell me quickly in the chats. Okay. Now, guys, linear mass density. What does linear mass density actually mean? What does linear mass density actually mean? See, guys, when it comes to the linear mass density, see, let's suppose you have a mass m over here. This is a rod. Its mass is m, length is l. If I say what is the mass, see, simple. I'll make it simple. Now, my dear NEET aspirants, let's suppose this is a rod, its mass is m and length is l. What is the mass of the entire rod? M. Length is l. If I say what is the mass on the unit length, you simply say, sir, that is total mass divided by total length. That is what we call lambda. So lambda helps you to find the mass on the unit length. Okay. Let's suppose if there is a rod. In this particular rod, my dear NEET aspirants, I say lambda is not constant, lambda is variable. Sir, what does lambda variable actually mean? It means that at every single point, okay, mass is not same. If I say lambda is constant, means what is lambda? Lambda means mass present on unit length. So if I say lambda is constant, whatever is the mass of this unit length, same will be the mass of this unit length. Same will be the mass of this unit length. But if I say lambda is variable, we say mass over here and mass on this unit length is not same. Even if I say lambda is proportional to x. So we say here, let's suppose x is 1, we say lambda will be 1. Let's suppose if here x is 10. So we say lambda in this particular case will be 10. So here density will be more, here mass will be more. So lambda simply tells you mass present on the unit length. Lambda simply tells you mass present on the unit length. Now guys, let's suppose you have this. In this particular case, you have a rod over here. Okay. Its mass is m and length is l. You have got a rod over here. Its mass is m and length is l. And you are supposed to find in this particular case, the center of mass of this rod. And lambda is constant. Lambda constant means mass at every single point is same. Mass on the unit length at every single point is same. You directly remember, I will not derive it, my dear NEET aspirants. Its center of mass, position of center of mass, it will be simply at L by 2. Okay. Then, my dear NEET aspirants, if I say, listen carefully, it will be at L by 2. If I say you have got a rod over here, you directly remember, this is very important. If I say you have a rod over here, its lambda is proportional to x. What does it mean? It means that mass is not same at every point. Mass keeps on increasing as you move towards the right. As you keep on increasing the x, mass is increasing. So we say in this particular case, center of mass will be, XCOM will be, that is simply 0.66 at 0.66 L. So here, it will be at, if lambda is constant, this is 1 by 2 means 0.5. Okay. Then, my dear NEET aspirants, if you ever see in a question, we say lambda is proportional to x square. density, linear mass density is proportional to x square. So this will be the center of mass somewhere around over here. In this particular case, center of mass will shift. It will be at 0.75 L. If you see in a rod, density is proportional to x cube. Linear mass density is proportional to x cube. In that particular case, I would say center of mass will be at 0.85 L. 0.85 L. Now tell me guys if this is crystalline clear. Tell me guys if this is crystalline clear. Everybody out there. Okay. Cool, 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 cool. Two identical rods of mass m along x and y. Okay, here is the diagram. You have got two identical rods. Okay. One is present on x-axis and another one is present on y-axis. Lambda means density. Lambda means density, linear mass density. Okay, so this is present on x-axis and this is present on y-axis. And in this particular case, you guys are supposed to tell me what is the position of center of mass. See guys. So whenever you have to find the center of mass of this system, you assume the center of mass of this rod at this particular point, at its center. Because lambda is constant. In both cases, lambda will be constant. And center of mass of this at this point. So means you have to assume the mass of the entire rod at this point. Mass of the entire rod at this point. Now, could you please tell me what is the value of R1 in this particular case? That is, what is the position vector of first mass? So that will be L by 2 I cap. Because it is along x-axis. It is along x-axis. Does it have y coordinate? No, sir. So when it comes to the position of center of mass R2, okay, so this is the position of this mass 2. So you are assuming its mass at center of mass. So that will be L divided by 2 J cap. Okay. Now, their center of mass. I see. Center of mass here means you are assuming the mass of this rod at this point. You are assuming mass of this rod at this point. So if I say when it comes to RCOM, position of center of mass, you'll be simply saying, sir, then that is M1 R1 plus I would say M2 R2. Okay. Then I would say in this particular case, M1 plus M2. So RCOM you will be writing over here M1 R1. M1 is M. R1 in this particular case is L by 2 I cap. Then you say plus M2 is also M. R2 is L divided by 2 J cap. Then I would say M plus M, that is 2M. Now this M will be cancelled. L by 2 upon 2. So this will become L divided by 4 I cap plus L divided by 4 J cap. L by 2 upon 2 is L by 4 J cap. This is the position of center of mass of these two rods. Now, if somebody asks you what is the x coordinate in this particular case, you'll be saying, sir, x coordinate in this case will be L by 4 and y coordinate of the center of mass is also L by 4. This is x coordinate, this is y coordinate. Okay, find the location of the center of mass. This is the question which I have solved. Please do check it from your end. In this particular case, guys, length of this is 2L. Length of this is L. You will be assuming mass of this at this point because this will be its center of mass at L by 2. And you can say position vector of this R1 will be simply L divided by 2 I cap. And you will be assuming mass of this at this point because since its length is 2L, so this will be at L distance. So this is at L distance. This is center of mass. So R2 in this particular case will be simply Lj cap because Lj cap. It's on y-axis. So you got R1, you got R2. And when I say in this particular case M1, mass of this is M. And when I say in this particular case M2, mass of this rod is 2M. Done. Now solve the question. RCOM is M1 R1, M2 R2 upon M plus M. Is this clear? Oh, is this clear? Tell me. Okay. Now velocity of center of mass. Guys, see, let's consider these two masses over here. Okay. Let's consider these two masses over here. There is one more question which I would like to give you as homework. See, guys, this question. This question. This one. These are the four rods. This is origin 0, 0. Its mass is M, length is L. 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 So in this particular case, you have to find center of mass. It is simple. It is not complicated. Guys, see, you will be basically assuming the mass of this at this point. This will be the center of mass of this. This will be the center of mass of this. This will be the center of mass of this. This will be the center of mass of this. Okay, let me write M1, R1, R2. So R1 will be simply, it is at L by 2 distance, okay? So L by 2 I cap because it is present on x-axis. Let's talk about this one, R2. Okay, so this is at, guys, see. This is origin. From origin, it is at what distance in x-axis? L. So L I cap plus, it is at what distance in y? L by 2. So L divided by 2 j cap. Let's talk about R3. Sir, R3 is this. This is at L divided by 2 j cap because it has only j coordinate, y coordinate. So this is y-axis, this is x-axis. When we talk about this, sir, its y coordinate, it is at what distance in y? Sir, it is at distance L in y. So R4 in this particular case, it's at what distance in y? It's at what distance in y? That is L. So that is Lj cap. And in x, guys, in x, how much is its distance? That is L by 2I cap plus Lj cap. Now you can solve this question. RCOM is equal to M1 R1 M2 R2 plus M3 R3. Velocity of center of mass. If you have two masses, M1, M2, this is moving with a velocity V1, this is moving with a velocity V2. So if these two are moving, so obviously their center of mass will be also moving. So what is the velocity of center of mass? Simple. Velocity of center of mass will be M1 V1 plus I would say M2 V2 upon I would say simply M1 plus I would say M2. M1 plus I would say M2. Like here, guys, what is the velocity of V1 mass? That is 2I cap. What is the velocity of V2 mass? This M2 mass, that is 2J cap because it is along y-axis. Now, we have to find their velocity of center of mass, VCOM. That is M1, V1. M1 is M, V1 is 2I cap. Plus M2 is M, V2 is 2J cap. Upon M1 plus M2, that is 2M. M will be cancelled. 2 divided by 2, 2I cap divided by 2 plus 2J cap divided by 2, 2. So this will be I cap plus J cap. This is velocity of center of mass. I cap plus J cap. This is the velocity of center of mass. Acceleration of center of mass. Guys, see, if this is mass M1, this is mass M2, this is, let's suppose, center of mass. So this has acceleration A1, this has acceleration A2. What is the acceleration of center of mass? Very simple. That will be M1 A1 plus I would say M2 A2. Okay. Then I would write over here M1 plus I would say M2 in this particular case. Now, my dear NEET aspirants, we have studied as force is actually equal to mass into acceleration. So can I write it like this also? Acceleration of center of mass will be M1 into A1. This will be force F1 plus M2 into A2. This will be force F2 upon we say M1 plus M2. Upon we say M1 plus F2. M2. Three particles of mass 1 kg, 2 kg and 3 kg are subjected to the forces this and this. Okay. You have three particles. The force on first particle is this. Force on second particle is this. Force on third particle is this. Okay, this respectively. Find the magnitude of acceleration of the system. Acceleration of the system means acceleration of the center of mass. See guys, when I say acceleration of the center of mass, simply, if you have three particles, okay, so if you have three particles, if you have two particles, M1 and M2, and force on the two particles is F1 and F2, then you can use this formula. But instead of two, you have three over here. So here, acceleration of center of mass will be force on first, force on second, force on third. Then we say M1 plus I would say M2 plus I would say M3. Okay. Then my dear NEET aspirants, what I'll be doing in this particular case is F1, F2, F3. This is the force F1, this is F2 and that is F3. So basically you'll be adding this and this. You'll be, okay, this and this and this and this. If you have to find F1 plus F2 plus F3, so I plus I plus I, J plus J plus J, K plus K plus K. Now I is here 3, minus I is here 1, and here it is 1 plus 1. This will cancel, so it is 3. So first one will be 3I cap. This is addition, net force, all the three, net force of all the three. Then J here is minus 2, here it is plus 2, and here it is plus 1. Minus 2 plus 2 will cancel, it is plus 1. So plus j cap. Array, sir. Here it is it plus or minus? It is plus. Here it is 2. Here it is minus 1. Here it is plus 1. This minus 1 plus 1, it is 2. So plus 2 k cap. So this is basically the vector sum of all the forces that I did upon net mass 1 plus 2 plus 3. That will be 6. So this acceleration came out to be, guys, in this particular case, that is 3 divided by 6 I cap plus 1 divided by 6 j cap plus 2 divided by 3 k cap. 3 ones are 3 twos are 2 ones are, okay, this is 6, 2 ones are 2 threes are. So this will be I cap divided by 2 plus j cap divided by 6 plus k cap divided by 3. This came out to be the acceleration. Even you can find the magnitude of the acceleration also. Under root of 1 by 2 whole square, 1 by 6 whole square, 1 by 3 whole square. Okay. Or you can directly write it over here. Under root of 3 square, 1 square, 2 square. Is this clear? Now this is the question that I am giving you over here as homework. Is this clear? Okay. Now let's move further, guys. Conservation of momentum of center of mass. Conservation of momentum of center of mass. Guys, see. Let's suppose if I say for an object, listen to me very carefully. If for an object, if I say net external force on an object is 0. Okay. Like this is the object. Whatever is the force acting from this side, same is the force acting from this side. We say net external force is 0. So if net external force is 0, we know according to the Newton's second law, F is equal to dp by dt. If this force is 0, so 0 is equal to dp divided by dt. Now take it over here. So dp will come out to be equal to 0. So when dp is 0 means change in momentum is 0. Change in momentum is 0 means momentum is conserved. Okay. So when momentum is conserved, we say initial momentum is equal to, we can say, final. Okay. Yes. Yes. Now guys, see. If we have system of two objects, this is very important. If we have system of two objects, like you have mass m1, you have mass m2. If you have system of two objects. My dear NEET aspirants, if I say on this system, net external force is 0. If I say on this system, net external force is 0. So if net external force on the system is 0, we can say, sir, Sir, in this particular case, net external force on this system is 0. We can say F is equal to dP divided by dt. Now the point here is, in this particular case, when you write dP by dt, this is momentum of what? dP means momentum of this object. P means momentum of the object. But here when you write Newton's second law dP by dt, is this momentum of this particle, or this is the momentum of this particle? This is momentum of center of mass. So for a particular particle, you can say dP by dt, P means momentum of a particle, but here it is the momentum of center of mass. If I say this force is 0, so we say dP, center of mass, divided by dt will come out to be 0. D center of mass will be 0. dP will be 0. What does that mean? That means momentum of center of mass in this system is conserved. Okay. That means momentum of center of mass initially is equal to momentum of center of mass finally. This is a very important concept that I wanted to tell you in this particular case. This is a very important concept that I wanted to tell you in this particular case. Okay. Like, see, sir, is there an example in which we say momentum is conserved? Absolutely, sir. Explosion of bomb. This is the example. When the bomb explodes, it is due to the internal forces. No external force. There is no external pressure which breaks the bomb. No, nothing like that. These are the internal forces due to which a bomb breaks. These are the internal forces due to which a bomb breaks. So this is a bomb. So if it breaks, it is because of the internal forces, okay? Internal reactions. So if I say what is the momentum of this initially? So can I say in this particular case, net external force is 0? Yes. If net external force is 0, initial momentum has to be equal to final momentum. Now guys, we say in this particular case, initially bomb is at rest before explosion. Initial momentum must be 0. So after it explodes, we say one fraction goes. So final momentum also must be equal to how much? 0. Let's find the final momentum in this particular case, guys. Final momentum is the momentum of this, that is m1. Because the bomb is breaking in two fragments here. One is going towards left, another is going towards right. Momentum of this will be minus m1 v1. Why minus m1 v1? Minus is because it is going towards left. And momentum of this is, we say m2 v2. And final momentum has to be 0. So this will be minus m1 v1 plus I would say m2 v2. Take it over there. So m1 v1 will be equals to m2 v2. So this momentum in the forward direction will be equal to the momentum in the backward direction. That is the reason one fragment goes in forward direction, another goes in backward direction. It is not possible both the fragments will go in the same direction. Why? Because the momentum has to conserve here. So that is only possible if the two fragments go in the opposite direction. That is only possible if the two fragments go in the opposite direction. Okay. If I say in this case, which of the following cases is possible? Guys, see, bomb explodes. We say initial momentum is 0. What about final momentum? Final momentum has to be 0. Now see, if this goes in upward direction, this goes in downward direction. This is the momentum in upward direction. This is the momentum in downward direction. These two will cancel. But this momentum is not cancelling. So final momentum is not equal to 0. So we say not possible. Not possible. Okay. A particle at rest explodes into two parts, M1 and M2. Just a second, guys. I need to switch on the generator. Just a second. Okay. A particle at rest explodes into two parts, M1 and M2. Find the ratio of their kinetic energies. Guys, see, in this particular case, we know that, sir, momentum remains conserved. Okay. Why? Why? Because in case of explosion of the bomb, momentum remains conserved. We know that. We recently studied. So we know the relation kinetic energy is equal to P square divided by 2M. Sir, how did this equation came into my mind? Only one reason. Momentum is conserved. When momentum is conserved, so kinetic energy and momentum has this relation. So can I say in this particular case, kinetic energy will be inversely proportional to mass? This is constant, 2 is constant, this is inversely proportional to mass. So what can I say? Kinetic energy of first divided by kinetic energy of second will be mass of second divided by mass of first, M2 by M1. Okay, this is the ratio. This is the ratio. Then the ratio of their kinetic energies, this is the ratio. Gun bullet system. This is also the example of conservation of momentum. Okay, here also P is conserved. Okay. Now see, in this particular case, my dear NEET aspirants, see guys, let's suppose this is the bullet inside the gun. When you fire a bullet inside from the gun, is there any external force which pushes the gun, then only bullet comes out? Do you push the gun something like this? No. This is the internal mechanism. So it is because of the internal forces, bullet comes out of the gun. We say in this particular case also, we say net external force on gun bullet system is 0. So momentum is conserved. Okay, so whatever is initial momentum, same must be final momentum. If I say initially gun as well as bullet is at rest, so initial momentum is how much? 0. So could you please tell me what will be the final momentum? Final momentum also must be 0. Now, my dear NEET aspirants, because initially gun and bullet are at rest. Finally, my dear NEET aspirants, we say final momentum must be 0. We say finally when the bullet is coming out of the gun, in that particular case, we have seen recoil of the gun. We say gun pushes our hand back, gun pushes our shoulder back, arm back. So we say if this bullet moves in the forward direction, gun is being pushed in the backward direction. So mass of the gun is M, velocity of the gun is Vg, okay, and mass of the bullet is small m, velocity of the bullet is Vb. So can I say finally, final momentum, if I just write over here, it will be momentum of this gun. So that is mass of the gun into velocity of the gun. Because whenever you fire a gunshot, your arm is being pushed in the backward direction because when the bullet goes out. So plus momentum of this, that is mass into velocity of this bullet. Now take it over there. Okay, this is 0 is equal to minus Vm, this is G, plus this is mVb. Take it over there. So this will become plus, this is mVg is equal to mVb. So we say Vg is equal to m, velocity of the bullet, divided by mass m. So this is what we call recoil velocity of the gun. This is called a recoil velocity of the gun. This is called recoil velocity of the gun. Okay. Okay. One more important thing I just want to say over here. Guys, see, We say in this particular case, whatever is the momentum of the gun, okay, magnitude wise, it is the momentum of the bullet. Oh, because then only they will cancel out each other, na? Net momentum must remain conserved, na? Okay. Okay. So, my dear NEET aspirants, if momentum is conserved, momentum of the gun is equal to momentum of the bullet. So, can I not say, guys, kinetic energy is equal to P square divided by 2m. So, can I not say kinetic energy is inversely proportional to mass because momentum is conserved, momentum of gun is equal to momentum of bullet. So, mass of the bullet is less. So, kinetic energy of the bullet will be more. So, I can say kinetic energy of the bullet is greater than kinetic energy of gun. A reason because you say mass of bullet is less than mass of gun. Mass of bullet is less than mass of gun. Okay. 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 I hope this is also crystal and clear. So we are done with center of mass. Next we have collisions. Collisions. Next we have collisions. Next portion. Sir, we are students of a hostel in Indore and we are 28 students studying from one. Just a second, guys. Sir, we are a student. Sir, we are students of a hostel in Indore and we are 28 students and studying from one device. And your live is getting projected on projector. Please give a shout out. Thank you so much, man. Okay. God bless you. May you all become the doctor in NEET 2026. Okay. Okay. Keep going. Keep shelling. That's all I can say. Okay. That's amazing, huh? It's a great feeling for a teacher also when we get to see comments like this. When we get to see students like this who are so dedicated, who are so, I would say, passionate. Okay. And these are the students who get selection. These are the students who become doctor in the upcoming time. 100%. Okay. And I have seen students like this. Keep going, guys. Huh? May God bless you. Keep going, guys. That's great. Okay. I think we should take a break. I think we should take a break of 10 to 15 minutes. What do you guys say? What do you guys say? Then we'll start the collision portion. Huh? Let's take a break. Break till 11. Let's take 25. Okay. Well, let's finish this. Oh, let's finish this. Let's not end before finishing the entire all Okay, guys. Now, let's dive into the session. In this particular case, let's talk about the collisions. What does collision actually mean? See, guys, it is the interaction between two or more than two objects, okay, in which no external force acts. Like, this is the mass m1, it is moving with velocity u1. This is mass m2, it is moving with velocity u2. Now, if they collide, they interact with each other. After the collision, this will have velocity v2 and this will have velocity v1. So this is what we call the collisions. When two masses interact, there is no external force. Sir, this F2 and F12, this F2 and F12 are the internal forces between M1 and M2. These are the internal forces. And this is the scenario before the collision. This is the scenario after the collision. And always remember, momentum of the system always remains conserved. Whatever is the momentum before the collision, that is M1 plus U1 M1 U1 plus M2 U2. Same will be finally after the collision, M1 V1 plus M2 V2. Okay, so whatever is the momentum before the collision, M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. It is valid in all types of collisions. So collision means when two masses interact. This mass, when they are colliding with each other, this collision. This before the collision, this after the collision. Now guys, we say momentum of the system is always conserved in all types of collisions. Momentum remains always conserved. Okay. Now see, before the collision, after the collision, at the time of collision. So before the collision, whatever is momentum, at the time of collision, whatever is momentum, after the collision, whatever is momentum, all three will be same. Okay. Then my dear NEET aspirants, relative velocity of approach. And understand this very carefully. If I say this mass is coming towards this mass with velocity what? V1. So this is the velocity of approach. Okay. Because this is the velocity with which they are coming close to each other. And after the collision, when they are separating, this will be the velocity of separation. So velocity of approach is always u1 minus u2. Okay. So when I say velocity of approach, it is u1. It is simply u1 minus u2. And velocity of separation, with what velocity they are separating, that will be v2 minus v1. So approach velocity means with which they are approaching. Separation velocity means with which they are separating. Okay, with which they are separating. Velocity of approach and velocity of separation. Okay. And if you divide the two equations, velocity of separation divided by velocity of approach, this is what we call E. This is called coefficient of restitution. You will get to see what is this. So as of now, velocity of approach with which velocity they are approaching, velocity of separation with which they are separating, divide the two, you'll get the coefficient of restitution. Now, my dear NEET aspirants, we say first one is when we talk about types of collisions. See guys, when we talk about types of collision, the first one is elastic collision. What is this? It is that collision after which the two objects regain shape, size, etc. Like see, this M1 is approaching M2 before the collision. When they are interacting, see, deformation takes place. Okay, deformation in the bodies take place. So after the collision, we say this regains its shape and size once again. This regains its shape and size once again.
So we say it regains its kinetic energy also. Whatever was the kinetic energy initially, so it will regain the same kinetic energy finally also. Okay. And this is after the collision, this is before the collision. And in case of this, coefficient of restitution is 1. In case of elastic collision, coefficient of restitution is 1. So when the two objects collide, they deform. After the deformation, if they regain shape, size, this is elastic collision. And if coefficient of restitution is 1, means velocity of approach v2 minus v1 divided by u1 minus u2, velocity of approach, it will be equals to 1. So when it is equal to 1, take it over here. So v2 minus v1 will be equals to u1 minus u2. So means velocity of separation is equal to velocity of approach. Amazing, sir. So whatever is the velocity of separation before, same will be the velocity of approach before, same will be the velocity of separation later. Even kinetic energy before the collision will be equals to kinetic energy after the collision. Okay. I hope this is also clear. Now, my dear NEET aspirants, if I ask you the simple question over here, we say after the collision takes place, if let's suppose initial velocity of this mass is u1, this mass is u2, what will be the velocity after the collision? What will be the velocity of this mass after the collision? After the elastic collision. Please take a look. So after the elastic collision, first mass will have velocity v1 is equal to, this you need to remember, guys. That is m1 minus m2 into u1 upon we say m1 plus m2. Then we say plus 2 times of m2 u2 upon we say m1 plus m2. This is the velocity of m1 after the collision. And velocity v2, m2 minus m1 into u2 upon we say m1 plus m2. Then plus 2 times of m1 u1 upon m1 plus m2. This is the velocity of mass 2 after the collision. So what did you remember in case of elastic collision? First point, when the two objects collide, they regain their shape, size, everything. Even they regain their kinetic energy also. Whatever is the kinetic energy before, finally also same. Coefficient of restitution is 1. If coefficient of restitution is 1, we say velocity of separation will be equal to velocity of approach. Kinetic energy before is equal to kinetic energy finally. That's it. And this is the velocity of mass m1. This is the velocity of mass m2 after the collision. Please give me the signal in the chats if you understood this. Please tell me in the chats if you understood this. Inelastic collision. We say it is that collision in which objects does not regain its kinetic energy. See guys, its kinetic energy, even shape also. This is the mass m1, it is mass m2. It is moving with u1, it is moving with u2. Now before the collision, when the collision takes place, see deformation takes place. After the deformation, you can clearly see it has not regained its original shape. This has not regained the original shape. So after the deformation, the masses do not regain its original shape and size. And here, coefficient of restitution, it is less than 0 and it is greater than 0 and it is less than 1. So coefficient of restitution decides whether the collision is elastic, whether the collision is inelastic. So in case of inelastic collision, my dear NEET aspirants, the object does not regain its shape, size, neither kinetic energy. And here, if coefficient of restitution is less than 1, so E decides the elasticity, that's what I said. If coefficient of restitution is less than 1, it means that body does not regain its shape. If coefficient of restitution is 1, it means body regains its shape. That's how we define coefficient of restitution. And when it comes to inelastic collision, momentum is conserved. Momentum is conserved in all cases. But here kinetic energy is not conserved. Okay. So momentum initially is equal to momentum finally. Okay. Now see, here coefficient of restitution is between 0 and 1. Less than 1, greater than 0. So let's suppose if coefficient of restitution is 0.5. 0.5 is greater than 0, less than 1. So put over here, this E is equal to velocity of separation upon velocity of approach. So put E is equal to 1 by 2. 0.5 means 1 by 2. Now take it over here. So this becomes V2 minus V1 is equal to 1 by 2 of U1 minus U2. This means velocity of separation is half of velocity of approach. Means separation velocity is after the collision. After the collision, velocity is less than collision velocity before the collision. Velocity of separation is less than one half of velocity of approach. Okay. So finally, if velocity of separation is less, so kinetic energy finally is less. Initially, kinetic energy is large. So kinetic energy is lost in compression or deformation. So in case of elastic collision, velocity of separation is less than velocity of approach. So kinetic energy finally is less than kinetic energy initially. Okay. And if somebody asks you, what is the velocity of the mass m1 and m2 after inelastic collision? After inelastic collision, if somebody asks you what is the mass of this one, what is the velocity of this one, and what is the velocity of this one, you'll be simply saying velocity of first mass after the collision, velocity of second mass, m1 minus e times of m2 into u1 upon m1 plus m2 into e plus 1 into m2 u2 upon m1 plus m2. Guys, these are the expressions you have to remember. I can't help it. So v2 is equal to m2 minus e times of m1 into u2 upon m1 plus m2 plus e plus 1 into m1 u1 upon m1 plus m2. Okay. Yes, this you need to remember. The third is perfectly inelastic collision. It is that type of collision in which bodies stick to each other after the collision. Now see, this m1 and m2 before the collision, they are approaching. When the collision takes place, now finally after the collision, they stick together and move together. So if they are moving together, whatever is the velocity of first one, v1, so same will be v2 and call that v, because if they are moving together, they will have the same velocity. Na? And here value of E is 0. If coefficient of restitution is 0, means bodies stick to each other and then they move. Okay. 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 Now, my dear NEET aspirants, we say if you place coefficient of restitution as 0 over here, so this term will become 0. Velocity of separation by velocity of approach. So what will you get in this particular case? What will you get in this particular case if you put it? Okay. So we say V2 minus V1 will be 0. V2 minus V1 will be 0. So take this over here. So V2 will be V1 will be V. That's what is proven over here. So both will move with the same velocity. If I say in this case, kinetic energy is not conserved. Okay. Momentum is conserved. Kinetic energy is not conserved. Momentum is conserved. Okay. So whatever is the momentum initially, same will be finally. Guys, what is the momentum initially? Take a look. Initially, if you take a look in this case, initially momentum is m1 u1 plus m2 u2. Finally, momentum is m1 plus m2 into v. Mass into velocity. That is what is mentioned over here. Na? See, m1 u1 plus m2 u2 is equal to m1 plus m2 into v. So from here you can take it over here. So you will get the value of v. m1 u1 plus m2 u2 upon m1 plus m2. So this is the velocity of the masses after the collision. This is the velocity of the masses after the collision. So this was basically elastical, done, nothing else. Elastic, inelastic, and perfectly inelastic. Okay, perfectly inelastic. Now, my dear NEET aspirants, if I say what is the loss in energy, all the collisions. In case of elastic collision, we say body regains, two objects will regain their kinetic energy. So we say whatever is the kinetic energy initially, same will be the kinetic energy finally.
So we say loss in kinetic energy in this case will be 0. Obviously, in case of inelastic collision, see how do we find the loss in kinetic energy? 1 by 2 m1 m2, mass of first, mass of second, upon m1 plus m2 into u relative square. U relative square. This is u relative square. Then 1 minus e square. 1 minus e square upon m1 plus m2. U relative means u1 minus u2. So that is velocity of first minus velocity of second before the collision. In case of perfectly inelastic, we say loss in kinetic energy is 1 by 2 m1 m2, because see, kinetic energy is only recovered in elastic. So in these two it is lost. m1 1 by 2 m1 m2 upon m1 plus m2 u relative square. U relative is u1 minus u2. I hope this is easy, bro. This is easy, bro. I hope this is crystal and clear to each and every single student out there. Okay. I hope this is crystal and clear to each and every single student out there. Okay. Now see, what does the question say in this particular case? Two masses 4 kg and 8 kg collide each other. Okay. Collide each other. And the collision is perfectly inelastic. Find the velocities of the masses after the collision. Guys, see. If the collision is perfectly inelastic, what is the velocity after the collision? m1 u1 plus m2 u2 upon m1 plus m2. Okay. So it'll be saying velocity of the masses after the collision. That is m1 u1. Okay. Then plus m2 u2 upon m1 plus m2. This is the question. Now m1 is m1. It's a 4 kg. m1 is 4 kg. And velocity of u1 is 8. 4 into 8. Then m2 is 8. Okay. And velocity of u2 is minus 4 because it is in the left. So minus 4 divided by 8 plus 4. So 8 into 4 is 32, minus 32 plus 32. So it will be 0. So they will come to rest. When they hit each other after the collision, they will come to rest. So this is the velocity after the collision. A ball of mass m moving with a velocity v collides head on head with second ball of mass m and rest. You have two balls. See guys, it is solved here. First ball is moving with velocity v, another ball is at rest. Then it says head on head with second ball of mass m at rest. If the coefficient of restitution is E, guys, if the coefficient of restitution E is given, so it is inelastic. Because in case of elastic, E will be given confirm as 1. E will be given as 1. Okay. Then it says, and the velocity of the first ball, if the coefficient of restitution is E and velocity of the first ball after the collision is V1 and velocity of the second ball after the collision is V2, then V1 and V2 will be. So it says inelastic collision is taking place over here. Okay. After the collision, this has velocity V1. You need to calculate this. After the collision, this is the velocity V2. You need to calculate this. Now see, consider inelastic. Apply the formula V1 to find V1. Apply the formula V2 to find V2. This is the answer over here. It is solved. You guys take a look over here and do check it from your end. A ball of mass m moving with a velocity of u suddenly breaks into two parts. Is 2:3. Okay, this ball breaks into two parts. 2:3. If the smaller mass comes to rest, okay, guys, do check this out from your end because I have solved this. It is completely on the screen. So do check it from your end later on. Okay. And then one more question I'm putting over here. This is also your homework. This is also your homework. Keep this thing in your mind. So this is the answer over here. Simple, bro. These are the simple questions. Once you understood the concept, then it becomes simple. So we say done with center of mass, done with collisions, done with collisions. Let's now start the rotation. Okay, let's now start. Okay, let's now start. Okay. Now, guys, we have the new chapter that is what we call a rotational motion. A rotational motion. Okay. And this is chapter 7. This is chapter 7. Come on, guys. Now, the one who stays will get selected because this is the competition. So, in reality, if there are 27 lakh students appearing in the NEET, it is not the competition of 27 lakh students. Who told you that? Okay, there are people who are married. Okay, they also submit this registration form. Let's go and let's see what happens in the NEET exam. Then there are people who are highly dedicated, who are focused. No matter what happens, they give their best, they give their 100%. And this is the category. Okay, right now, the one who stays, he is from that particular category and he is going to go into the medical college, that is for sure. Okay, ladies and gentlemen, boys and girls. So it completely depends upon you. You decide if you want to become doctor. Okay, then stay. If not, And there is a guy saying in the chats, I have been watching consistently from 10 a.m. Okay, that's great. Okay, chances of becoming a doctor is increasing in your case. All the best. That's what I can say. Okay, okay. And I'm also consistently teaching from past 14 hours. Okay, that's not easy standing for 14 hours. Okay, stretch. Okay, now guys, a rotational motion. Rotational motion. Okay, first topic in this particular case is moment of inertia. First topic in this particular case is moment of inertia. Before defining moment of inertia, let's define inertia. Let's define inertia. What inertia is all about? Listen to me very, very, very carefully. Listen to me very, very, very carefully. My dear NEET aspirants, let's suppose you have a box over here. My dear NEET aspirants, let's suppose you have a box over here. Okay. And this is having the mass M, and there is a big box over here. This is having the mass capital M. If I ask you the simple question over here, which one is difficult to disturb? If this is at rest, which one is difficult to move, first or second? So second. So this has more tendency of staying in rest. This has less tendency of staying in rest. Obviously, this is due to the mass. So we say this has less inertia. Less inertia. Okay. And this has more inertia. More inertia or large inertia. Okay. So inertia is simply the tendency of an object to stay in a state of rest or state of uniform motion. If the same two objects are moving with a constant speed, constant velocity, this also. We say which has the tendency to stay in the uniform motion? This one. Which one is difficult to stop? This one. Why? Because inertia is large. So inertia is something which keeps the body in a state of rest if it is at rest. So tendency of an object to stay in a state of rest is inertia. This has more tendency, this has less tendency. This has large inertia, this has less inertia. Now understand the same thing in rotational motion. Understand the same thing in rotational motion, my dear NEET aspirants. Let's suppose you have a rod which is rotating. Then you have this rod. This is also rotating about this axis. So this is the rod which is rotating. This is the rotational motion. Now, which one is difficult to rotate? Sir, second one, this is difficult to rotate. Which one is less difficult to rotate? This one. So we say this has large moment of inertia. We say this has large moment of inertia. So means, sir, concept is same. This is in the translational motion and this is in the rotational motion. Absolutely. So here this has a less moment of inertia. Why? So this has a less tendency of staying in rest. Now, if a rod is rotating with a constant angular velocity, here we say linear velocity, here we say constant angular velocity. Then we say in this particular case, sir, this has more tendency of staying in a rotational motion as compared to this one. Okay. Okay. So this has more tendency as compared to this one. So moment of inertia is inertia only. But in where? But where? We say in rotational motion. We say rotational motion. I believe this is crystal and clear. I believe this is crystal and clear. Okay. So you simply say it is the tendency of an object to stay in a state of rotational motion. Simply you can say it like that. Okay. Okay. In these two cases, okay, we say in the second rod, we
face more difficulty in changing its rotation state because second rod has more moment of inertia. What does the question say over? What does it say over here? Here in the second rod, we face more difficulty in changing its rotational state because it has more moment of inertia. Okay. Moment of inertia, due to moment of inertia, body wants to continue its rotational state. Okay. That's moment of inertia, simply. Now, my dear NEET aspirants, I hope you got the feel of moment of inertia. If an object is in the rotational motion, so it is difficult to change its rotational state if moment of inertia is large. Now see, let's suppose you have an object over here. Let's suppose I'm attaching a stitch to a stone. Now I'm rotating it like this. So if it is rotating about this axis, this is what we call the axis of rotation. This is called axis of rotation. This is called axis of rotation. Axis of rotation. That axis around which an object is rotating, that is what we call the axis of rotation. Now, my dear NEET aspirants, in this particular case, if you have to find the moment of inertia of this object, how do you find? Always remember, moment of inertia will be m is mass into r square. R is the perpendicular distance from that mass to the axis of rotation. M into r square, where r is the perpendicular distance from the axis of rotation. SI unit is, what is the unit of mass? Kg. For this it is meter square. So kg meter square is the SI unit. It is a scalar quantity. Okay. Like moment of inertia of collection of objects. Guys, see, this object is rotating about this axis. This is also rotating. This is this. So we say all will have the moment of inertia. We say net moment of inertia will be moment of inertia of first object, that is m1 into r1 square, because it is at r1 distance. Moment of inertia of second is, we say m2 into r2 square. Then plus moment of inertia of third is m3 into r3 square, plus moment of inertia of fourth is m4 into r4 square. Then my dear NEET aspirants, what I can write, I can say m1 plus I would say m2 plus I would say m3 plus I would say m4 in this particular case. I'm not finding center of mass. Sorry. So just this will be the moment of inertia. I'm still in the center of mass. Okay. So this will be the moment of inertia in this particular case. Moment of inertia of an object with the coordinates. Guys, see. Let's suppose this x-axis, y-axis and z-axis. This is an object. It's having x coordinate and y coordinate. If x coordinate is x, what is x coordinate? How far it is in the x-axis. What is y coordinate? How far it is in the y-axis. If I say, let's assume that this is rotating about x-axis. This object is rotating about x-axis. So what will be the moment of inertia about x-axis? You'll simply say, sir, mass is m and perpendicular distance. From this to x-axis, what is perpendicular distance? That is y, so y square. Keep this thing in your mind. And from here to here, if x coordinate is x, so from here to here distance is x. So what is the moment of inertia about y-axis? Y-axis. It will be mass m and this distance x into x square. Okay. Yes. Okay. Absolutely, sir. Yes. Now, guys, let's suppose you have a question something like this. Find moment of inertia about x, moment of inertia about y, and moment of inertia about z. By the way, moment of inertia is represented with I. And in this particular case,
In this particular case, my dear NEET aspirants, we say this is y-axis, this is x-axis, and this is z-axis. Now the coordinates of the point are given. This is the point. Its coordinates are given x, y, and z. Okay, x, y, and z. Now, my dear NEET aspirants, understand this very carefully. Understand this very carefully. This point is in 3D right now. This point is in 3D right now. This point is in 3D right now. I want you to understand one thing. If I say this point is rotating about x-axis, okay, this point is rotating with respect to the x-axis. So always remember, if all the three coordinates are given, in the previous question, 2 coordinates were given. If 3 coordinates are given, because the point is in 3D, so this r perpendicular will be simply under root of y square plus z square. Okay, this coordinate square plus this coordinate square, then root. Now, what is the moment of inertia about x-axis in this case? You'll be saying that is m into r square. R is this, that is under root of y square plus z square whole square. This and this will cancel. So moment of inertia about x will be m into y square plus z square. This. Okay. And similarly, if I ask you in this case, what is the moment of inertia about y? You say, sir, m into r perpendicular. What is the r perpendicular? That will be under root of x square plus z square. Under root of x square plus z square, its whole square. This will be r perpendicular. Keep this thing in your mind. This and this will cancel. So y will come out to be m into x square plus z square. Then next, if I say what is the moment of inertia about z, that will be m into guys, about z under root of x square plus y square. Under root of x square plus y square. Its whole square. This and this will cancel. So iz will come out to be m into x square plus y square. I hope you got this one. And similarly, if I give you the question something like this. Question is, this is x, this is y, and this is the point over here. This point has coordinates 2, 3, 2. If I say what is the moment of inertia about x-axis, so that is m into y square plus z square. Directly I'll be writing now y square plus z square. So that is m into, what is the value of y? That is 3 square plus 2 square. That is m into 3 square is 9, 2 square is 4. 9 plus 4 is 13. So this will be 13m. Is this clear? Okay. Is this clear? Yes. Let's talk about find the moment of inertia of this system about this axis of rotation. Guys, see. Always remember, if the mass is present at the axis of rotation, then its moment of inertia will be 0. Its moment of inertia will be 0. So in this particular case, I will be, this has the 0 moment of inertia. What is the moment of inertia of this? M into a square. And if this is, guys, what I can say in this particular case, if this is A, don't you think in this particular case, if this is A and this is an equilateral triangle, this is 60. How much will be this? Or this is A by 2, simply, na? So from here to here, because it is exactly at center, this will be a divided by 2. Even you can find this also. This is a sine a cos 60. Cos 60 is 1 by 2, that is a by 2. If this is a by 2, okay, so this will be also how much? A divided by 2. So let's first write the moment of inertia of this, that is m into a square plus m into a divided by 2 whole square. So this is ma square plus ma square by 4. Ma square divided by 4. So 4ma square plus ma square, that is 5ma square. 5ma square divided by 4. So this is the net moment of inertia of this system. Find the moment of inertia about the axis of rotation. Guys, see, this is m, and this is m. If I say what is the moment of inertia of this about this axis of rotation, you'll be simply saying, in this particular case, moment of inertia of this will be 0. Why? Because this is placed at axis of rotation. This distance is a by 2, this distance is a by 2. We always take perpendicular distance. So moment of inertia will be m into a divided by 2 whole square plus m into a divided by 2 whole square. So moment of inertia in this particular case will be ma square by 4. Ma square divided by 4 plus ma square divided by 4. Okay. Now guys, this is 2 times of ma square divided by 4. Ma square by 4 plus ma square by 4, 2 times. 2 ones are 2 twos are. Okay. So this will be ma square divided by 2. Ma square divided by 2. Okay. Is this clear? So guys, this is I'm giving you as homework. Simple bro, not the complicated one. So you have to find the moment of inertia in this particular case about which axis? About this axis, not about this axis. Okay, this is the axis of rotation. About this axis. About this axis. This is the axis of rotation. Okay, so it is solved. You would be able to see this, you will be able to understand in this particular case. Okay, let me solve this right now. This I'll solve it here only. Okay, come on, tell me the answer of this question, guys. Give it a shot. Give it a shot once. Come on. Tell me the answer of this. Quick. I'll just come in a minute. Okay. Check. Now, guys, take a look. Find the moment of inertia about the axis of rotation. This is the axis of rotation. You have to find the moment of inertia. Guys, see, moment of inertia of this mass will be 0 because this present at axis of rotation. For this mass, it is also 0. Now, in this particular case, if the side is A, how much will be this? This is the half of the diagonal. Half of the diagonal is always A by root 2. This is how much? A divided by root 2. So if I say moment of inertia in this particular case, that is for this is the perpendicular distance from here to here because this is 90. That is m into A divided by root 2 whole square plus m into A divided by root 2 whole square. So you'll say, sir, moment of inertia will be, that is 2 times of m into A square divided by 2, because this is A square divided by root 2 square is 2. So 2 and 2 will cancel. So I will come out to be ma square. Okay, what else do you have here? Okay. Let's suppose you have this. This is mass m. This is mass m. This is mass m. This is mass m. And this is the axis of rotation. Okay. This is the axis of rotation. So in this particular case, how can you find the moment of inertia? How can you find the moment of inertia? Just a second, I'll just give you the feel of this. It is like this. And then this is the question of JEE 2024. JEE 2024. See. So it is basically passing through one point. Now, if I say distance from here to here, this distance, it is perpendicular. So distance from here to here, this is also perpendicular distance. So this distance, perpendicular distance, this is perpendicular, this is perpendicular. Okay. So you can say this is A. This is also A. And this will be A or A root 2. So what is the net moment of inertia in this case? Guys, this is perpendicular distance. Don't say it's not making 90, sir. This is not 90. It is in 3D. Yeah? So this will be m into A square due to this. And due to this also plus m into A square plus m into. How much is this distance? A root 2 its whole square. A root 2 its whole square. So ma square plus ma square is 2ma square plus. So this will be over here. A square. This root 2 is 2ma square. 2ma square. So 2ma square plus 2ma square is 4ma square. This is the answer. Now see, let's talk about parallel axis theorem. Is this clear? Let's talk about parallel axis theorem. Guys, see, what does parallel axis theorem actually say? Let's suppose if you have an object over here. Understand this very carefully. Okay. This is the center of mass of the object. if an axis is passing through the center of mass, sir, axis passing through the center of mass means, that means if the object is rotating about the center of mass, if it is rotating, if we have hinged over here, if we have fixed the nail over here and it is rotating about the center of mass, that's what we say. It is basically axis is passing through the center of mass. That is, what does that mean? Axis passing through the center of mass. Now, if I say, if you know the moment of inertia of this about center of mass, okay, moment of inertia of this about center of mass, okay, if you know the moment of inertia of this body about center of mass, then my dear friends, if there is another point, through this is point P, through this point P another axis is passing, okay, through this axis through this point another axis is passing. If I say, what is the moment of inertia about this axis? You know what I'm trying to say? There is an axis which is passing through center of mass, you know it, moment of inertia. There is another axis which is passing through point P, and this distance between them is d, and this is the perpendicular distance. What is the moment of inertia about this? You know about center of mass. You have to find moment of inertia about this axis. You will say, sir, moment of inertia about point P will be moment of inertia about center of mass plus, I would say, md square, plus I would say md square, where m is the mass of this object, d is the perpendicular distance. This is the perpendicular axis theorem. See. Sorry. Parallel axis theorem. This is the parallel axis theorem. Perpendicular is another one. This is the parallel axis theorem. Now, my dear NEET aspirants, what does parallel axis theorem say? Suppose if we know the moment of inertia about an axis which is passing through center of mass, this is the object. If you know the moment of inertia about an axis which is passing through center of mass, then we can find the moment of inertia about an axis which is parallel to center of mass axis, okay, by using parallel axis theorem. By using parallel axis theorem, okay. By using parallel axis theorem. What does parallel axis theorem say? Moment of inertia about that axis, point P, is equal to moment of inertia about center of mass plus md square. But the condition is here, two axes must be parallel to each other. This axis and this axis must be parallel. One axis must pass through center of mass. One axis must pass through center of mass. And D must be perpendicular distance. D must be perpendicular distance. Done. Perpendicular axis theorem. See, what does perpendicular axis theorem say actually? Take a look, guys. Take a look. Let's suppose you have a body over here. This is a sheet. Okay. This is a sheet. Now, in this particular case, if I say this is x-axis, moment of inertia about this x-axis is ix. This is y-axis, moment of inertia about this is iy. And my dear NEET aspirants, this is z-axis, moment of inertia about this is z, iz. Now I can say, in this particular case, this axis is perpendicular to ix and iy. And these two axes are in the same plane. This is ix, this is iy, and this is iz. So we say here, this moment of inertia about z-axis is equal to moment of inertia about x plus moment of inertia about y. This is called perpendicular axis theorem. So perpendicular axis theorem says that if you know the moment of inertia about two axes such that they are in the same plane,
Okay, and they are perpendicular to each other. Then you can find the moment of inertia about an axis which is perpendicular to the this plane. That is perpendicular axis theorem. Like here, perpendicular axis theorem. According to this theorem, moment of inertia about z axis is equal to the moment of inertia about x axis plus moment of inertia about y axis. It is valid for 2D objects. All the three axes must be perpendicular to each other. I, y, ix and iz. Okay. And z must, and x and y must be in the same plane. This and this must be in the same plane. And z must be perpendicular to that plane. That's what I said. That's what I said. Okay, that's what I said. I hope this is clear. Guys, give me the signal in the chats. Is this clear? Tell me. Give me the signal in the chats. Okay. Now, guys, remember this particular point, guys. Remember this point. Moment of inertia of a ring about an axis which is passing through its center of mass and perpendicular to the ring. It is mr square by 2. Sorry, mr square. Where m is the mass of the ring, okay, and r is the radius of the ring. Directly, this is the moment of inertia of a ring about an axis passing through its center of mass. Okay, now listen carefully. I want to show you something. I want to show you something. This is a ring. You know moment of inertia about this axis. This is ICOM, or you call it IZ, Z axis. This you need to remember. This we have derived. You can understand it like that. And this is m into r square. Okay. Now I am asking you to tell me what is the moment of inertia about x and what is the moment of inertia about y. Okay. Okay. Now, guys, this is the passing through the diameter. This is also diameter. This is also diameter. This is also diameter. So can I say this is the moment of inertia about diameter? Absolutely, sir. Can I say this is also moment of inertia about diameter? Absolutely, sir. So use perpendicular axis theorem. What does that say? Iz is equal to Ix plus Iy.
So instead of Iz, you can write m into r square is equal. Instead of Ix, you can write Id. Instead of Iy, you can write Id. So this will be m into r square plus 2 times of Id. So this moment of inertia Id, it will be simply that is mr square divided by 2. And my dear NEET aspirants, it is mr square by 2. So this is the value of Ix and this is the value of Iy also. So we calculated this using perpendicular axis theorem. Moment of inertia of a ring about an edge parallel to the plane. Guys. You recently got moment of inertia about this. This was Id. That is mr square divided by 2. Now listen carefully. You have to find moment of inertia about this edge. This distance is r because this is radius. Don't you think we can use parallel axis theorem over here? Use parallel axis. Parallel axis simply means moment of inertia about an axis is equal to moment of inertia about center of mass plus md square. But what is the condition? Condition is one axis must pass through center of mass. See, this is passing through center of mass. Two axes must be parallel. See, these are parallel. This r must be perpendicular distance. Done. All the three conditions are satisfying. So moment of inertia about this edge will be, this is given as mr square by 2 plus this is m into r. This is r given over here, r square. 2mr square plus mr square is 3mr square by 2. 3mr square by 2. Okay. Guys, see, moment of inertia of a disk. If this is a disk, not a ring, moment of inertia of a disk will be mr square divided by 2, where m is the mass and r is the radius. M is the mass and r is the radius. This is the and remember this. This is the moment of inertia of a disk about its center of mass, perpendicular to the plane. Only saying about its center of mass, then it can be this axis also. It is wrong, which is perpendicular to the plane. Okay, if this is disk, it is perpendicular to the plane. That is correct. Mr square by 2. Okay, let's find. We know about z axis for a disk. Let's find about diameter, about x and about y. So don't you think we can say Iz will be Ix plus Iy? Again, I can use this perpendicular axis theorem. So this will be mr square divided by 2 is equal to Ix in this case is moment of inertia about diameter plus moment of inertia about diameter. So this will be mr square divided by 2. So 2 times of moment of inertia about diameter. 2 into 2 is 4. So Id will be mr square divided by 4. So this is actually Ix and this is actually Iy. Moment of inertia about x and moment of inertia about y. Okay. Let's suppose this is the question. This is a disk. This is a disk. Okay. You need to find moment of inertia. You know about this. You have to now find moment of inertia about the edge. What is the moment of inertia of this disk about edge? Moment of inertia of this diameter you recently got. That is mr square by 4. So you can also call it moment of inertia about center of mass. Why, sir? This is passing through the center of mass, but it is not perpendicular to the plane, but it is parallel to the plane. Moment of inertia about the center of mass parallel to the plane. And this radius is r. Don't you think I can use parallel axis theorem? So I'll write over here, use parallel axes. So what does parallel axes theorem say? Moment of inertia about E, it will be moment of inertia about COM plus I would say MD square. So moment of inertia about E. What is the moment of inertia about center of mass? That is mr square by 4 plus m into. How much is this perpendicular distance? That is d. Sorry, that is r. So r square. So 4 mr square plus mr square, that is 5 mr square divided by 4. Now, moment of inertia of a rod. Guys, see, if we say axis is passing through the edge of the rod, so moment of inertia will be ml square by 3, where m is the mass of the rod, l is the length of the rod, ml square by 3. About an axis passing through the edge. If it is passing through the center of mass, ml square by 12. ml square by 12. Now see, if you have to find the about this axis, what is the moment of inertia about this axis, which is at L by 4 distance from center of mass? Use parallel axes. Two axes must be parallel. One must pass through center of mass and this distance must be perpendicular distance. All the three conditions are satisfied. Use parallel axes. So moment of inertia about this will be moment of inertia about center of mass plus md square. So I is equal to moment of inertia about center of mass. About center of mass it is ml square by 12 plus m into L by 4 whole square. Okay. This is ml square divided by 12 plus ml square divided by 16. Now in this particular case, 7 by 48, ml square take common, 1 by 12 plus 1 by 16. Moment of inertia of a hollow sphere. Guys, if this is a sphere, if it is passing through the center of mass like this, in all the directions it will be similar, na? If it's a sphere, if you pass through center of mass like this, like this, like this, like this, it will be same like this. So moment of inertia about center of mass is 2 by 3 mr square. If I say what is the moment of inertia about edge? This is the radius r. Use parallel axes. Okay. So moment of inertia about edge is equal to moment of inertia about center of mass plus I would say md square. D is what? R. mr square. So IE is equal to moment of inertia about center of mass 2 by 3 mr square plus mr square. So 3 mr square plus 2 mr square, that is 5 mr square. So 5 divided by 3 mr square. Moment of inertia of solid sphere. For solid sphere about center of mass, this is 2 by 5 mr square. If I say about edge, this is r. Solid sphere means which is not hollow. Use parallel axes. So I can say moment of inertia about E, it will be moment of inertia about center of mass plus I would say m into r square. So IE will come out to be this. What is the moment of inertia about center of mass? 2 by 5 mr square plus mr square. So this is 5 mr square plus 2 mr square, that is 7 mr square divided by 5. Moment of inertia of hollow cylinder. Hollow cylinder is made up of, hollow cylinder means pipe. It is made up of infinite number of rings, large number of rings. Okay. It is made up of large number of rings. Can you, guys, moment of inertia of hollow cylinder about the center of mass is mr square, like whatever is the ring. whatever is the moment of inertia of ring. Because logic here is, it is formed due to many number of rings and same masses away from the axis of rotation. Could you please tell me what about the edge? What is the moment of inertia about an edge? Tell me, guys. Okay, how much it is be? Get how much you are getting? Okay, guys. Let's move. Now, about the center of mass, it is mr square. About this edge, use parallel axis theorem. Use parallel axis. So I would say moment of inertia about the edge, it will be, that is moment of inertia about center of mass plus m into d square. So about edge, it will be moment of inertia about center of mass, that is mr square plus, this is also r na, so this will be mr square. So this will be 2 times of m into r square. Moment of inertia of solid cylinder. Guys, for solid cylinder about center of mass, it is mr square by 2. About edge, I have used again parallel axis theorem. Mr square by 2 plus Mr square, 3 by 2 Mr square. Simple. Okay. Moment of inertia of a plate. Guys, see. This is the plate. Its length is A, breadth is B. If I say, what is the moment of inertia of this plate about this center of mass? It is passing through the center of mass, but it is cutting the length. See guys, when the axes are parallel to the plane and along the breadth, about the edge, guys see, moment of inertia is same as the moment of inertia. Moment of inertia is same as the rod, because same mass is distributed from the axis of rotation. Guys, see. What is the moment of inertia of a rod about the center of mass? ml square by 12. Here in this particular case, length is A, so it will be about the center of mass, Here it will be ma square by 12. Same. Because same mass is distributed away from the axis of rotation, like in case of rod. Okay. So I can say about center of mass, it is ma square divided by 12. About center of mass, it is ma square divided by 12. Okay. And about this edge, it is ma square by 3. Please listen to this very carefully. If it is cutting this breadth, length, in that case A. But if it is given something like this, if it is cutting the breadth, in this particular case, it is going to be this ICOM, simple, that is MB square by 12. And this IA is going to be simply, or I edge is going to be simply, that is MB square divided by 3. So in case of a plate, if it is cutting the length, that is then MA square. If it is cutting the breadth, then you will take MB square. I hope this point is clear. Okay, now comes the concept that is radius of gyration. Now comes the concept radius of gyration. See guys, what does radius of gyration mean? We say concept of center of mass is not valid for the calculation of moment of inertia. See, let's suppose this is a rod. We are assuming the mass of the rod at this point, at center of mass. How do you define center of mass concept? That point where you can assume whole mass of the system or whole mass of the body. Yes, that is the center of mass. Now the axis is crossing through the center of mass. What is the moment of inertia about this? About this? Sir, moment of inertia must be 0. Why? Because if you are assuming the mass at center of mass and axis is passing through that center of mass, then moment of inertia must be 0. We say if mass is assumed at COM, then in that particular case, moment of inertia about COM is 0. But we know moment of inertia of this rod about center of mass, it is ml square by 12. So when we are assuming center of mass to be at center of mass for the calculation of moment of inertia, we are getting 0. But which is wrong. So can I say, if we use the concept of center of mass to calculate moment of inertia, we are getting wrong answer, incorrect answer. Absolutely, sir. Why? We are getting 0. Like here, take a look. If I say, let's suppose you assume the mass to be at center of mass. What? And center of mass is at what distance? That is L by 2 distance. Then we say mass is assumed if mass is assumed at center of mass, then what is the moment of inertia? M into what is the perpendicular distance from the axis of rotation? L by 2 whole square. So I will come out to be M L square by 4, which is wrong, because moment of inertia about the edge, it is M L square divided by 3. But when you are applying the concept of center of mass for the calculation of moment of inertia, you are getting the wrong answer. So my dear NEET aspirants, so can I say concept of center of mass is not valid for the calculation of moment of inertia? Because we get wrong answer if we apply concept of center of mass. So what we do instead is we apply the concept of radius of gyration. So for the calculation of moment of inertia, we assume the mass to be at a radius of gyration, ROG. We assume the mass to be at radius of gyration, because if we assume to be at center of mass, we get wrong answer. So we assume to be at radius of gyration. Let's suppose we are assuming the mass at this point, which is at radius of gyration. So radius of gyration is at what? This is at k distance. K is the radius of gyration at k. So we say, if you are assuming this to be at k, so if mass is assumed at k, then what is the moment of inertia? That is, mass is m into k square, because it is at k distance. Yes, sir. We say, as we know, what is the moment of inertia of this rod about the edge? ml square divided by 3. Now, this is according to radius of gyration. This is what we know. So balance the two, my dear NEET aspirants. We can say mk square is equal to ml square divided by 3. Now this m and this m will cancel. So k will come out to be, take this square over here, this L square already. So it will be L become L divided by root 3. It will be L divided by root 3. Okay. So this is the radius of gyration of this rod with respect to this axis. Now see, now check. Now you said, sir, moment of inertia with respect to the radius of gyration, it is mk square. Okay. Value of k is this. So I is equal to mass is m. K square, that is L divided by root 3 whole square. Okay. So I will come out to be m L square, root 3 whole square is 3, ml square by 3, which is absolutely correct. So that is the reason. Guys, you understood this concept. Tell me in the chats, na? This is very important. Tell me in the chats. Quick. Tell me in the chats. Is this clear? I need the signal in the chats. Oh, wait now. Oh, Lethan, wait.
We already knew L by 3. Wait. Take a look at the question which was asked in NEET 2023. Now, take a look. The ratio of radius of gyration. This is what we are finding. The ratio of radius of gyration of a thin uniform disk about an axis passing through its center and normal to its plane. Guys, see, this is the disk. Okay. You have to find the radius of gyration here. You have to find the radius of gyration here. Okay. See, guys, in this particular case, it says you have to find the radius of ratio of the radius of gyration. See, guys, this is K1 and this is K2. Let's suppose radius of gyration here is at K1 and in that case it is at K2. We have to find the ratio. Now, my dear NEET aspirants, we say, what is the moment of inertia of this disk about this axis? You say, sir, I is equal to mr square divided by 2. This is what we know. Now, if you assume the mass to be at radius of gyration, then what will be the moment of inertia? Sir, then it will be m into k1 square. Now, equate the two. We say m into r square divided by 2 is equal to m into k1 square. So, this and this will cancel out. So, k1 will come out to be r divided by root 2. So, this is the radius of gyration of this disk with respect to this axis. Yes, sir. Now, let's find the radius of gyration in this particular case. Okay. What is the moment of inertia of this disk about this axis? Sir, this moment of inertia we have recently studied. This is mr square divided by 4. If you remember about the diameter. Now, in this particular case, if we assume the mass to be at radius of gyration K2, then according to that, it will be m into K2 square. Now, balance the two. So, we can say mr square divided by 4 is equal to m into K2 square. M and m will cancel. So, K2 will come out to be, take the square here. That will be under root of r square by 4. That will be r divided by 2. This is K2. So, this is the moment of inertia, my dear NEET aspirants, in this particular case. Sorry, this is the radius of gyration of this disk with respect to this axis. Now, you have to find the ratio of radius of gyration, K1 divided by K2, NEET 2022 question. So, it is r divided by root 2 upon, we say r divided by 2. This and this will cancel. It will come out to be root 2 divided by root 2. Okay. 2 divided by root 2. Okay, you can multiply with root 2 over here. You can divide with root 2 over here. Root 2, and this will be cancelled. So, this will be a root 2 divided by 1. So, K1 divided by K2. Now, I hope you got the feel. Is this clear? Is this clear? Or tell me. Okay. The radius of gyration of a, okay, this I'll keep you as homework. This is the question from NEET 2023. This I'll keep you as homework.
This I'll keep you as homework. Now, let's move on to the new concept, that is what we call the torque. Okay, let's move on to the new concept, that is what we call the torque. Okay, let's move on to the new concept, that is what we call the torque. See guys, what does torque actually mean? Okay, take a look. Let's guys, this is a let's consider this is the door over here. Let's suppose I'm taking a door over here. There's a door. Okay, now I'm saying that you have to open the door. Okay, like this is a door. You have to open this door. Tell me, my dear NEET aspirants, is it possible that, sir, how is it possible that I can open this door? By applying force? Okay, apply force. Apply force. No. Sir, apply force. Apply force. No. No, sir. Now, if you are saying that the door is rotating because of force, it is wrong. It is not only the force. It is not only the force. It is basically, my dear NEET aspirants, you need to apply the force in a proper direction, in a proper way. So due to that force, we say rotating effect. Like guys, when you pull this in the outward direction, no rotating effect is created. When you push this in the inward direction, no rotating effect is created. But when you apply the force something like this perpendicularly, we say rotating effect is created. Rotating effect is created in this particular case. So that rotating effect is torque. So it is not force which is rotating the door. Because I am applying the force, nothing happens. I am pushing it, nothing happens. But when I apply the force something like this, then only it is rotating. So basically it is something else which is rotating the door. Like here, if you are applying the force over here, this force will have two components. This one. So it is basically that nut opener. This is the bolt. It is that nut opener. Now, this component of the force is pulling it. This component is pushing it. Due to this, it is going to rotate. So basically, torque is something due to which an object, I would say, rotates. Torque is what we call the rotating effect. Torque is something what we call the rotating effect. Okay. Like here, guys, if I say a car is moving, so it is because of force. An object is rotating, it is because of torque. So in this particular case, my dear NEET aspirants, see guys, we say this is a force F. This is F cos theta. This will be F sin theta. Can I say in this particular case, we say torque is what we call a rotating effect. Rotating effect. So in this particular case, I would say due to F sine of theta, we say torque is created. Because it is obvious this F sine theta is only rotating it. Okay, F cos theta is basically pulling it. So when I say this torque, this torque will be simply, that is this R into radius into which component of force, F sine or F cos? F sine or F cos? F sine or F cos? So I would say, sir, F sine or F sine theta. Now you might have heard A B sine theta is A cross B. So you can write torque is R vector cross F vector. So basically torque is something due to which an object rotates. And you need to apply the torque in a proper way. Then only it can rotate in a nice, then only it can rotate, then only it can create torque. Okay. Okay. Yes. So my dear NEET aspirants, what is this torque? Torque is R of sine theta, or we say torque is actually R vector cross F vector. Now let's suppose maximum torque. Maximum torque. When is the maximum torque created? Listen to me very carefully. When is the maximum torque created? Take a look. We say this is, let's suppose this is a rod. It is fixed over here. Now, if you are pushing this rod in the upward direction, this is radius R. How much is the angle in this case? 90. And if I say how much is the torque created over here? Torque is, I would say, RF sine of theta. So torque in this case will be RF and I would say sine of 90. Sine 90 is 1. So torque in this case will be R into F. And this is the maximum torque. This is the maximum torque. If I say minimum torque, as this is the rod fixed over here, you are pulling this rod in this direction. Force F. What is the angle between this F and R? That is 0 degrees. So in this particular case, my dear NEET aspirants, this torque is, that is RF, I would say sine of 0. Sine 0 is 0. So torque in this particular case will come out to be 0. Torque in this particular case will come out to be 0. Okay? Torque in this particular case will come out to be 0. So basically, my dear NEET aspirants, if you are pulling this rod with a force F, okay? If you are pulling this rod with a force F, so in this particular case, it will not rotate. There will be no rotating effect. It is common. It's common sense. So you are pulling it. So if you want to create the rotating effect, you need to apply the force, something like this. Okay. Now, my dear NEET aspirants, so this is how we define a torque. So basically, if you want to create a torque in a body, you need to apply the force in a proper manner. Okay. Yes. Torque is what? Rotating effect. Due to rotating effect, only a body rotates. Torque about a point. See guys, this is also very important. Torque about a point. Let's suppose, my dear NEET aspirants, there is a body. Its mass is M. You are applying force on this body, something like this. Okay. Now this is the point A and this is point B. Now, if you see from point A, we say if force is acting, it will move linearly. When you are sitting at point B, if you look at from point B, okay, let's suppose this is radius R, this is position vector R. So with respect to the point B, my dear NEET aspirants, can I say in this particular case over here, the body is moving angularly. With respect to the point B, can I say the body is moving angularly? So can I say in this case, I would write over here, with respect to point A, body moves linearly. And when I say with respect to point B, body moves angularly. With respect to point B, body moves angularly. So it will have angular momentum. Okay, so it will, so I would write, so not angular move. With respect to point B, body is moving angularly, so torque is created. You just write this. So torque is created. Now, my dear NEET aspirants, if this is R, so, and this is theta, can I say this will be R cos of theta? Because this is theta, this is R cos theta, and this will be R sine of theta. Now tell me, which component I am supposed to take over here? You need to take that component which is perpendicular to the radius. So here in this particular case, I would say torque will be, that is r sine of theta into F. Don't consider this because this will not create torque. They are parallel to each other. You need to take this. So here torque will be simply, that is Rf sine theta. In this case also torque will be Rf sine theta means R vector cross F vector. R cross F. Okay. Okay. R cross F. I hope you got the feel of this topic. You got the feel of this topic. Now, let's take a look at this particular question. The moment of force F at 2, 0, minus 3 about a point. See guys, it says that there is a particle. Moment of force means torque. This is the another name of torque. Let's suppose there is this particle. On this particle, I'm saying force is acting. This is the force acting on this particle. This is the force acting on this particle. Okay. And coordinates of this particle are given as 2, 0, minus 3. These are the coordinates. With respect to this point, this is the reference point. With respect to the point, about a point means 2, minus 2, minus 2. So this is the force acting. We are supposed to find torque. And my dear NEET aspirants, torque will be simply R vector cross F vector. R cross F. Torque will be simply R vector cross F vector. And in this particular case, boys and girls, in this particular case, boys and girls, what I can say is that, if you have to find the position vector, that is this position vector, that is this position vector, this is R. See, how do you find the position vector? Remember this. Guys, this final x coordinate minus initial x coordinate, 2 minus 2 is 0. So 0 I cap. Then 0, see, this 0 minus of minus 2. So that is plus 2. So that is plus 2 j cap. Then minus 3. And then this minus of this minus 2. So minus into minus is plus. Minus 3 plus 2 is minus 1. So minus k cap. Minus k cap. Minus k cap. Okay, minus k cap. Now, my dear NEET aspirants, this came out to be the position vector. This is the force vector. Now, you have to basically find torque, that is R cross F, cross product of two vectors. Guys, if you have the two vectors in, you have to do the cross product. See how what you are going to do. So, see, let me show you the cross product today. You'll be mentioning over here I cap, you'll be mentioning over here j cap, you'll be mentioning over here in this particular case k cap. Okay. Then, my dear NEET aspirants over here, first you'll be mentioning the coefficients of R. R is, what is the I coefficient of I? 0. Coefficient of j is 2 and this is minus 1. 2 and minus 1. Whenever you have to do cross product, draw a determinant, something like this, right? I, j, k, coefficient of R first, then F. First R, then F, because it is R cross F. And what is the coefficient of F? 4, 5, minus 6. 4, 5, minus 6. Now solve. So this will be, torque is, first, my dear NEET aspirants, see how you are going to solve. You need to first solve it for I. Sir, what does that mean, solving for I? You hide that column in which I is present, you hide that row in which I is present. So first row, first column. So remaining is 2 minus 1, 5 minus 6. Do the cross. 2 into minus 6 is minus 12. Then minus. 5 into minus 1 is minus 5. Okay. Then solve for j. But in front of the j, you need to put negative sign. Hide that column in which j is present. Hide that row in which j is present. Now 0 into minus 6 is 0. 4 into minus 1 is minus 4. This is formula is minus. So 4 into minus 1 is minus 4. Then plus. So in front of the j only you need to put negative. Then solve for k cap. Hide that column in which k is present. Hide that row in which k is present. So first, third. So 0 into 5 is 0, minus 4 into 2 is 8. So torque in this case came out to be, so minus into minus is plus. Okay. So minus 12 plus 5, that is minus 7 I cap. Minus into minus is plus, that is 4. Okay. Then again minus. So this will be minus 4 J cap. And this will become minus 8 K cap. Okay. So this is basically the torque in this particular case. Guys, tell me in the chats quickly, is this clear? Tell me in the chats quickly, is this clear? So this is basically the cross product over here. That's it. This is the cross product over here. Okay. Let's move on to the next question, guys. J means 2025. The coordinates of a particle are given 1, 1, 1 with respect to the origin. So if these are the coordinates, so its position vector will be I cap, J cap, K cap. Done. If a force is given over here, force in this particular case is given as I minus J plus K. X on, then the magnitude of torque will be. Torque is simply, that is R vector cross F vector. Okay, now make the determinant. So we'll be mentioning over here I, J, and this will be K. First, we'll be mentioning the coefficients of R, 1, 1, 1. Then F, 1, minus 1, 1. Okay. Then, my dear NEET aspirants will be solving it first for I cap. Okay. So, hide first row and first column. 1 into 1 is 1. Okay. Minus 1 into 1 is 1. Minus 1 into 1 is minus 1. Minus into this minus becomes plus 1. Then minus J cap. Solve it for J. Hide first row and second column. 1 into 1 is 1. Minus 1 into 1 is 1. Then plus, solve for K. Hide this column and this row. Sorry, this column and this row. 1 into minus 1 is minus 1. Then minus 1 into 1 is 1. Now this torque came out to be 1 plus 1 is 2I cap. This will be 0. Minus 1 minus, this will be minus 2K cap. This is the answer to the question. J means 2025. Let's take a look. Find the torque due to mg about point O and about center of mass. Guys, see, this is the mg acting over here. Since if we find the torque about this point, means then torque about O will be. Guys, see, about O, I'll write over here, about O. about O. So torque will be Rf sine of theta. So torque will be R. R is from O to where the force is acting. L by 2. F is mg and angle between the two is 90. So you'll be simply saying mgl divided by 2. mgl divided by 2. And if I say about center of mass, guys, if the force is acting at the center of mass only, what will be the value of r, perpendicular distance? 0. So torque about center of mass will be 0. Okay. Now guys, rotational equilibrium. What does rotational equilibrium actually mean? We say when the net torque on a body is 0, it is said to be in rotational equilibrium. What is translational equilibrium? Translational equilibrium means, let's suppose this is a body, force acting from this side is F, force acting from this side is F. So we say in this particular case, net force is 0. If net force on the body is 0, it is in translational equilibrium. Rotational equilibrium means when net torque on a body is 0, it is said to be in rotational equilibrium. Example is this. See guys, let's suppose this is the point over here. This force is pulling the body in the downward direction. Let's suppose this is F1, this is F2. Understand this very carefully in this particular case, whatever I am trying to say over here. See, we say this force will try to rotate the body something like this. So this will be the torque. And how much will be this torque? Let's call this tau 1. There will be Rf sine 90. R is R1 and this is F1. Sine of 90 because angle between this and this is sine 90. And it is anti-clockwise. ACW. Now, let's talk about this one. So it will try to pull the body in this direction. It will try to rotate the body in this direction. This is tau 2. So tau 2 will be R2 into F2 sine of 90. But this torque will be clockwise. Now, this torque, anti-clockwise, clockwise. So we say net torque is 0. So this body, this rod is in the rotational equilibrium. When the net torque on the body is 0, it is in the rotational equilibrium. As simple as that. Example. Let's take a look. Guys, first of all, this is a rod. So you are pushing the rod in this direction, you are pushing the rod in this direction. Equal and opposite force, so net force is 0. Even net torque is also 0. Guys, if this is fixed here, so force is passing through the axis of rotation. So it will not rotate the rod, na? Net torque is also 0. So here body is in translation as well as rotational equilibrium. Take a look here. This is the force F acting, this is the force F acting. It is hinged over here. In this case, force is equal and opposite. So net force is 0. This is in translational equilibrium. Translational equilibrium means it will not move, it will not do the translational motion. When it comes to the net torque, see guys, this is R by 2. So due to this, torque will be something like this. Let's call this as tau 1. This is F into R divided by 2. And this torque is anti-clockwise. Let's find the force due to this. It will be something like this. It will rotate the rod something like this. And we say this torque will be R divided by 2 into F. Because this is also R by 2. And this is also anti-clockwise. If this is anti-clockwise, this is anti-clockwise, do you think that they will cancel out each other? No. So net torque is not equal to 0. So in this case, we say body is in the translational equilibrium only, not in rotation. See, this rod is going to rotate. It will rotate, but it cannot move. So if the body is in the translational equilibrium as well as in the rotational equilibrium, so we say neither it will rotate nor it will move. Now, Translational equilibrium. Translational equilibrium. Take a look, my dear NEET aspirants. When all the particles of a point of a rigid body, see. What does translational motion actually mean? Let's suppose this is a body over here. This body is moving with certain velocity. If I consider different number of points in this particular body, we say if all the points have same velocity, v1 is v2 is equal to v3 is equal to v4, then the body is said to be in the translational equilibrium, translational motion. When all the particles points of a rigid body moves with the same velocity, okay, then it is called pure translational motion. If all the points move with the same velocity, same displacement, then it is called pure translational motion. Okay, let's talk about rotational motion. Let's talk about rotational motion. Understand this very carefully, guys. This point is important. Let's fix the rod over here. And let's rotate the rod. After some time, rod reached here. See? So we say this is the point it reached here. This is the point it reached here. This is the point it reached here. Okay? Yes. Now, guys, in this particular case, if I say how much angle this has covered, theta, how much angle this has covered, theta, how much angle this has covered, theta. So this theta is angular displacement. Angular displacement is same. Okay. And if I say how much time this has taken from this point to this point, let's suppose it is t seconds. So this will be also in t, this will be also in t, or 1 second, 1 second, 1 second. So same, if the rod reaches from this point to this point, so we say at the same time, all the points will reach now. Yes. So if I say angular velocity omega, first of all, I would say theta 1 in this particular case is theta 2, in this particular case is theta 3. Theta 1, theta 2, theta 3. Angle will be same. Okay. Angle. And in this particular case, my dear NEET aspirants, if I say, in this particular case, my dear NEET aspirants, if I say, when it comes to the angular velocity means simply angular displacement upon time. Like velocity is displacement upon time, angular velocity means angular displacement upon time. Guys, if the body is moving linearly, it will have velocity. If the body is rotating, it will have angular velocity. Now, in this particular case, if this is same, this is same. This is same for all points. This is same for all points. So can I say omega 1 is equal to omega 2 is equal to omega 3? So angular velocity of all the points is same. Okay. Now, guys, next point. If I say this point, now remember this. If an object moves in a circle, it will have angular velocity as well as it will have linear velocity. Both. If an object moves in a circle, it will have both linear as well as angular velocity. My dear NEET aspirants, in this particular case, we say this point is covering less distance in the same time. This point is covering more distance in the same time. This point is covering more distance, more linear distance in the same time. So don't you think that this point V3 will have more linear velocity as compared to V2 as compared to V1? So in case of rotational motion, different points have different linear velocity, but angular speed is same, linear speed is different. Please tell me if this point is clear. Please tell me if this point is clear. Tell me. So angular speed in case of rotational motion is same.
But I would say linear speed is different. Okay, so this point will have angular speed also, how fast it is rotating angularly, how fast it is moving. So this distance here, it is more, time is same. So obviously this velocity has been more. This velocity has to be more. Okay. Yes. And that is mentioned in this slide. When all the particles points of a rigid body are moving in a circular path of different radius, this will have radius r1, this will have radius r2, all will have different radius, but about a common center. Center is common with same angular speed is same, but different linear speed is different. It is called pure rotational motion. It is called pure rotational motion. Now let's spot the difference between translation and rotational motion. Guys, if an object is moving in a translational motion, we say it is covering some displacement s. If an object is performing the rotational motion, we say it is covering the angular displacement theta. How much angle it has covered? Linear displacement, angular displacement. If I say how fast an object is moving from here to here, this velocity, ds by dt. If I say how fast an object is rotating, angular velocity, d theta by dt. Okay, rate of change of angular displacement. If I say how fast velocity is changing, that is acceleration. Okay, how fast velocity is changing. If I say how fast angular velocity is changing, that is angular acceleration. That is d omega by dt, rate of change of angular velocity with time. If I say Newton's second law, F is equal to dp by dt, here you have Newton's second law. Instead of force, you have here torque. Because torque plays the same role in rotational motion as force plays in linear motion. So we say torque is equal to dl by dt. L is angular momentum that we have to study next. Okay. So dl divided by dt. And we say force is equal to mass into acceleration. So torque is equal to I into alpha. Torque is equal to I into alpha. Okay. Guys, mass plays the same role in linear motion as moment of inertia plays in angular motion. A is the acceleration, I alpha is the angular acceleration. Okay, P is mb, momentum is mass into velocity. L is equal to I omega. L is equal to I omega. L is angular momentum, I is moment of inertia, omega is angular velocity. Okay, work done is equal to force into displacement. Here work done is equal to, we say, torque into angular displacement, or integration of f ds, integration of tau d theta. Kinetic energy is 1 by 2 mv square. Here kinetic energy is 1 divided by 2. Instead of mass you have moment of inertia, instead of velocity you have omega square, or we say p square by 2m. Here it is L square by 2i. Guys, in translational motion you have mass, here you have moment of inertia I. Keep that thing in your mind. Here you have force, here you have torque. Equations of motion. Guys, when acceleration was constant, what was the motion? What was the equations that you were using? B is equal to u plus at to find velocity. S is equal to ut plus 1 by 2 at square to find displacement. Now, if in rotational motion angular acceleration is constant, you can use this equation. Final angular velocity is equal to initial angular velocity plus alpha t. It is exactly the replica of this. So here you have linear displacement, you have angular displacement theta. Theta is equal to omega I into t 1 by 2 t square. V square minus u square is equal to as. See, omega final square is equal to minus omega initial square plus 2 alpha theta. Please do check these from your end. These are simple. Just the replica over here. Now you have a question. This is a question over here. Okay, we're almost done with this. Now it will require 20 to
20 more minutes and we are done. Okay. Is that clear, guys? Okay. Let's finish this, guys. Huh? Let's finish it. Let's finish it. A constant torque of 100 Newton meter turns a wheel of moment of inertia. Torque is given. In this question, we say torque is given. That is 100 Newton meters. Okay. And moment of inertia of the wheel, I, is given as 300 kg meter square. About an axis passing through its center. Starting from the rest. Okay. Its angular velocity after 3 seconds is, after t is equal to 3 seconds, we have to find its angular velocity, final angular velocity. So initial angular velocity in this case is 0 because it is starting from rest. You will say simply, sir, final angular velocity is equal to initial angular velocity plus alpha into t. V is equal to u plus 18, but in angular version. Final angular velocity is equal to initial plus acceleration into time. But acceleration you don't know over here. So in order to find acceleration, you can use Newton's second law. F is equal to ma. The similar law here is tau is equal to I times of alpha. A alpha, mass, moment of inertia, force, torque. Now guys, this torque is given as 100 is equal to I is given as 300 and this is alpha 0, 0, 0, 0. So alpha is given as 1 by 3 and it is radian per second square. Now, final angular velocity is equal to initial angular velocity is 0 plus alpha is 1 by 3 and time is 3 seconds. 3 and 3 will cancel. Final angular velocity came out to be 1 radian per second. This is the question of NEET 2023. Now, the last topic over here is angular momentum. See guys, I'll quickly finish this. Let's suppose you know momentum. Momentum is mass into velocity. Sir, let's suppose you have an object over here, its mass is m. Okay. Okay. Now guys, with respect to the point A, this mass is moving linearly. Okay. So I'll just write over here, with respect to point A, this mass is moving linearly. It has linear momentum. Linear momentum. Guys, it is simple. If an object is moving linearly, it will have linear momentum. If an object is moving angularly, it will have angular momentum. Over there it is linear, here it is angular. So with respect to point B, it has angular momentum. Angular momentum means L. So with respect to point B, it is moving angularly. And if you ask me, sir, how much will be that angular momentum? That angular momentum will be m, mass is m, v is velocity, then r, then we say sine of theta. mvr sine of theta will be the angular momentum. Even you can write it like this, L is equal to mass is out. Vr sine theta, you can write v vector cross r vector, v cross r. Okay. Even you can write it like this, L is equal to r, then we say mv, then we say sine theta. mv means mass into velocity is p. So this angular momentum, you can write it like this, equals to r cross p. R cross p. So L is equal to, this is r, mv is p, and then we say sine theta. So L will be equals to, that is r vector cross p vector. Moment of momentum. So with respect to point A, it is moving linearly, so it will have linear momentum. With respect to point B, it is moving angularly. See, it is cutting the angle. So if I say with respect to me, it is moving angularly. So it will have angular momentum. So this is the value of angular momentum. Now here in this slide, guys, if I say this is mass m, with respect to point B, it is moving angularly. So this is the position vector r and this is theta. If this is r, this is theta, this will be r cos theta, this will be r sin theta. Tell me, which of the two components of the radius will contribute to angular momentum? Sir, r cos cannot. Why? Because this is parallel to velocity. So we say r sin theta is perpendicular to velocity. So it will create angular momentum, perpendicular component. Create angular momentum. And we say this angular momentum is equal to, that is mass m, okay, v is velocity, and r cos or r sin theta. R sin theta. That's what I was saying. M into r cross v. L is equal to m into r vector cross v vector. This is the angular momentum. Now, this is the angular momentum of a body which is moving angularly, or angular momentum about a point, like you study torque about a point. Similarly, my dear NEET aspirants, if I say angular momentum of a purely rotating body, not angularly moving body, purely rotating body, we say angular momentum is MVR. Okay. Now there is a relation between linear velocity and angular velocity. V is equal to R omega. So put it here. Instead of V, you put R omega. This is MR into R omega. So this will be R into R is MR square. So MR square. MR square is moment of inertia, I omega. So this angular momentum will be I into omega. Like, what is the angular momentum of this body? You say, sir, L is equal to I omega. What is the moment of inertia of this rod about the center of mass? ML square by 12 into omega. Okay. Absolutely. Take a look at this, guys. See. An object is projected with speed u at an angle theta. An object is projected with speed u at an angle theta with the horizontal. Find the angular momentum of the object when it is at the maximum height with respect to the point of projection. When the object is at maximum height, what is the angular momentum with respect to the projection? This is the position vector r. See, guys, I'll make you understand here. Now, take a look. It is thrown with velocity u at an angle theta. At topmost point, object is here. At topmost point, object is here. This is the position vector r. And our topmost point, object has one velocity only. That is v is equal to u cos theta. Because we know vertical component is 0. Now this r will have two components. This perpendicular component and this parallel component. This is perpendicular component and this is, we know, h max. If you have to find its angular momentum at topmost point with respect to the point of projection, you'll be saying L is equal to mvr sine theta. Okay. So L is equal to mass is m. What is the velocity at topmost point? That is u cos theta. Okay. And what is r? R you need to take which component, my dear NEET aspirants? Perpendicular component. Perpendicular component is h max because this is the maximum height of the projectile. So maximum height is simply u square sine square of theta divided by 2g. So put it over here instead of r. That is u square sine square of theta divided by 2g. Theta is the angle with which you have launched this angle. And then this is sine 90 over here because you will be basically taking the angle between this and this 90. This is 90. Then you will be writing sine of 90. Okay, guys, this is the value of b, this is the value of r, and sine 90 as it is. So L is equal to u into u square becomes u cube, m u cube, then we say cos of theta, then we say sine square of theta divided by 2g. This is the angular momentum at the topmost point with respect to the origin. Okay. Now, guys, in this case, when the object strikes the ground, what is the angular momentum with respect to this point? With respect to the point of origin. See, guys, I'll make you understand this here. Understand this very carefully. This one. Guys, if you are launching the object with velocity u, this is theta. This will be u cos theta. This will be u sine theta. When it strikes the ground, it will have same velocity u. Okay, with what velocity you are throwing, it will fall with the same velocity. This will be horizontal component u cos theta only. This will be vertical component u sine theta only. Okay. Now, guys, In this particular case, my dear NEET aspirants, this is what we call range. If you have to find it, this is the mass. If you have to find what is the angular momentum at this point, you say, sir, angular momentum is mvr sine theta. Now, guys, L is equal to m. Velocity at this point, guys, see. What is the position vector r? Sir, this is the position vector r, that is range. Range from this point to this point, join this point. Now, which component of velocity you need to take over here? Sine or cos? You need to take that component of velocity which is perpendicular to r, which is perpendicular to radius, that is u sine theta. M instead of velocity, you will be taking u sine theta. Sir, will you not take u cos? No, because it is parallel to r. And this range we know it is u square sine of 2 theta divided by g. And then this sine, and this will be 90 always. Why? Because angle between range and this velocity is 90. This is angle between r and b, that is 90. Sine of 90. And sir, what about this theta? This theta is the angle of projection, bro. So L is equal to m, u into u becomes u cube, sine of theta, sine of 2 theta divided by g. This is the angular momentum. This is your homework. You will be doing it from your end. Please try to look at this from your end. Okay. This also, please check this from your end. This is simple. Angular momentum of hollow sphere, angular momentum of solid sphere, solid sphere is. Now, conservation of angular momentum. Conservation of angular. Is this clear or tell me? Is this clear? Smash the like button if you are not liked this session yet. Now, guys, conservation of angular momentum. We have studied conservation of momentum. When I say net external force on a body is zero, then we applied Newton's second law, F is equal to dP by dt. So if this is zero, we say dP will come out to be zero. If dP is zero, we say momentum is conserved. So what does that mean? Initial momentum is equal to final momentum. So we say, my dear NEET aspirants, if net external force on a body is zero, its momentum will remain conserved. In case of angular momentum, if I say net external torque, if net external torque on a body is zero, if I would say tau net external on the body is zero, then apply Newton's rotational version of Newton's second law, that is tau is equal to dl by dt. Put this equal to zero, then dl divided by dt. So we say dl is equal to 0. Guys, torque is equal to dl by dt, angular rate of change of angular momentum with time. So we say angular momentum will remain conserved. Angular momentum is initial angular momentum is equal to final angular momentum. Initial angular momentum will be I into omega. This I into omega is the angular momentum value na, of a purely rotating body. Final angular momentum is I dash into omega dash. Okay? Yes. Yes. See, there is a question over here. A thin disk of mass. Okay. A thin disk of mass. A thin circular disk of mass m and radius r rotating about an axis with rotating about an axis. Okay. Passing through its center with angular velocity omega. If another disk of mass m by 2 is placed gently on the first disk. See guys, it says that there is a disk, its mass is m and radius is r. And let's suppose its moment of inertia is I. It is rotating with angular velocity omega. Finally, what happens is that we say since this disk was rotating, okay, another disk is placed gently on it. This is m and this is r. Moment of inertia is I. Another disk of mass m by 2 is placed on it. So if mass m by 2 is placed on it, its moment of inertia will be halved, I by 2. What will be new angular velocity? Omega dash. See guys, in this case, no net external torque is acting. So we say tau net is 0. So angular momentum is conserved. Tau net is 0, angular momentum is conserved. That means initial angular momentum is equal to final angular momentum. So initial angular momentum is I into omega. Final angular momentum is I dash into omega dash. Initially, what is the angular momentum? I. Sorry, what is the moment of inertia? I. Angular velocity is omega. I into omega is equal to. Finally, what is the moment of inertia? For this disk, it is I. For this disk, it is I by 2. So I plus I by 2 into omega dash. Simple. Now this is I into omega. 2i plus I is 3i divided by 2 into omega dash. I and I will cancel. So take it over here. 2 omega divided by 3 will be equals to omega dash. This will be new final angular velocity. This is a previous year question. J Mains 2024. J Mains 2010. See guys, let me show you this question. So this is basically a ring. Its mass is m, radius is r. It is rotating with angular velocity omega. After some time, we have attached two masses on this one, m and m. When after attaching the two masses, what is the new angular velocity? Simply conserve angular momentum. Initial angular momentum is equal to final. Initially, it is I into omega. I into omega. What is the moment of inertia of this ring? mr square into omega. Moment of inertia of the ring about an axis passing through the center of mass into omega. Finally, what is the moment of inertia? For this mass, it is small mr square. For this mass, small mr square. So 2 into small mr square plus moment of inertia of the ring mr square into omega dash. From here, you can get the value of omega dash. This is the value of omega. Okay. This is one more. This you can check from your end. Class 11th, part 1. 16 hours of live teaching. Okay, done. Okay, so once I end the live stream, do let me know how was the session and all, because I have covered every single topic. Okay, I believe you will be basically revising each and every single thing. Okay, chalo guys, take care, and do let me know in the comments later on how was the session. Take care.